Hey everyone, just a quick check here. So here's Nick from the Geekle team. I will be on backstage like I always do. And now I just want to ask you that you can hear and see me clearly, and also to check that this right now is being broadcasted to both career and pro track. So you can watch this on YouTube, you can watch this on our platform, either if you open career track day one or pro track day one. And then we're going to switch and start two separate simultaneous live streams. So we can choose, if you have obviously the ticket to our conference, you can choose if you'd like to see content of the pro track or the career track. So let me just check that I can actually see myself on both tracks. And yeah, I do. So yeah, I see both chats. I see you all writing. So I'm happy to see you all here. And yeah, we're gonna start very soon with my fellow colleagues with the intro. So yeah, see you and enjoy.
And finally, Software Architecture Summit by Geekle, Volume 2. I'm so happy to welcome you here and so happy to open this event. Wait a second, I can't hear myself. I should mute myself in another tab. Yeah, and now it's okay. Well, I hope you can see me and hear me well. And if you do, just let me know about that. Write in comments, yes, and hi, or whatever you want to write there, because we are about to start this beautiful event. We was working for like, I don't know, maybe 4 or 6 even months to prepare this. But anyway, we have Anna with us. Anna, can you hear me? Yeah.
Yes, I can. Hi.
Yeah.
Good morning to you. I'm happy to see you.
Good morning to me. Yeah, it's really 6 a.m. now. I'm in Florida. I'm in Miami, Florida, and yeah, it's really early here. And what about you? Where are you now? And what time is there?
So I'm in Kyiv, Ukraine, and we have 1 p.m. here. So it's not early morning, but still, it seems to be because I barely slept. That is why.
Yeah,
I believe it's obvious, and it doesn't matter which summit this is for you. Anyway, you feel the same emotions. You feel that excitement and a bit nervous, but I'm pretty sure that everything will be great.
God, everything goes really smoothly. Like I can see you, you can see me, we can chat. That's almost enough. Yeah, we need some software architecture actually.
They will be soon.
Yeah, they'll be soon. So let's talk about the event. I'm so happy we started, and tell me more. What's going on? How we came here?
Yes, so actually, really, we've prepared the summit for nearly 6 months. But after the first architecture, we also tried or experimented a bit with meetups. That was really great, and it was really an interesting experience for me. After that, we moved to the second Worldwide Software Architecture Summit since we received great feedback from our attendees, and we just wanted to share new knowledge, perhaps new practices, in 4 months. So basically, I've started prepare the summit 4 months ago, and it took me 4 months to collect together these wonderful people. And it was I'm really happy that most of our speakers and most of our moderators, they just returned to us from the first summit, and I really can see their support. I believe that with this support, the summit will be definitely great. So
yeah, absolutely. So, yeah, I still remember our first architecture summit. It was amazing, actually. It was. I still hear nice words from people who remember that. So I expect this one will be even better. I hope so. Anyway, give us some numbers. How many people are in this community now, how many speakers and all this, information about this event, we would love to know.
Yes, sure. So we are planning to have 2 days. The first day will be for career and pro track as usual. The same one will be for career and pro track as well. And we have 40 speakers for this summit. It's a bit less than we had for the previous one, but anyway, we have great and amazing speakers. They're great topics, so I'm pretty sure you will enjoy. Despite the number of them, right now we have 70 people who are watching and joining us still. So I believe the number will increase. We are just starting. So thank you so much and joining us. And we have also people from Odessa, Ukraine. So hi from Kiev. I've just noticed that and couldn't help commenting.
Yeah. Anyway, people, just let us know where you're from right now. I mean, where you situated now, where you're watching us. Just write in comments your country, city, maybe a room, I don't know, or whatever you want. Just let us know you're here, you're with us, and we're about to start our sessions. Anyway, I have to mention that 95% of our attendees is usually free users. I mean, people who are not paying anything, but I'm really happy and thankful to those people who paid us even $1, I don't know, because that's what supports us. That's what helps us, to survive, because our mainstream, how to cover our expenses and keep going this project is tickets. So thank you very much to everyone who supports us with an intention or payments or whatever. And I guess we even have sponsors to this event.
Yes, you're right. And I'm really happy that they've joined us recently. But anyway, it was really great news. So we have 2 sponsors, our silver sponsors in a company. They're a consulting agency for software architecture and development. And we also have Appium Hub with their product, VU app. It's management tool. So you will definitely know more about this tool later.
Oh, that's nice. That's nice. Thank you very much, and thanks to our sponsors again.
Yes, and also I'm sorry for interrupting, but I couldn't help mentioning our program committee members, because we've just discussed everything, but not them. These are people who helped me a lot, and I'm really grateful. And really, I'm from summit to summit, I'm really shocked and surprised and astonished how people are devoted to what they really do. And I know that they all have their tasks, but anyway, they helped me, and almost everyone was online when I needed their help. They provided me with recommendations. They helped me with the topics. They helped me during all my ways. So thank you so much. This time we had a great program committee board. It was it consisted of 13 people, and it was really wonderful. Thank you so much. If you are watching us right now, I'm really grateful, and I love you all.
Wow. So much love here in this stream.
Yeah, so I'm the happiest community manager, as my LinkedIn says. That is why I love everyone.
Yeah, I'm sure you are. Okay, what's next? Let's go straight to the point.
Basically, soon we are going to start with our first block, and right now we need to have one just quick break. And while we have this break, I'd recommend you checking out our do's and don'ts. So stay tuned.
Oh, cool. By the way, our conference platform is still in beta. So if you have any bugs, or, you have any ideas to improve it, just, write to Nick, the guy who was before us with Anna in this stream, and maybe he will. Yeah, thanks, Nick. That's his email. So just write to Nick, hey man, you need to fix stuff. So and we'll do that, because we are just we're the startup. We are actually raising money, so to scale this startup up. So if you know some nice investors who could help us with this project, just write me on LinkedIn or whatever, just to help this project. Yeah, let's go. Let's do it.
Yeah. So we are going to have a quick
and-
break.
Yeah, quick break. Yeah, let's do it. Yeah.
Hi again, and I'm back, and I'm happy to introduce our first moderator for the career track. This person actually is a great supporter of Geekle. He helped me a lot. He was our attendee at the first Worldwide Software Architecture Summit, and then he joined us as a speaker and moderator. And I'm pretty sure that you will enjoy the time with him. So please welcome Gaëtan Bloch. Hi, Gaëtan. You're online, but I cannot hear you. Please unmute your sound.
Yeah, that would be better.
Yeah, I can hear you now.
Sorry.
Hi, I'm happy to see you.
Yeah, happy to see you again. So I'm supposed to introduce myself, right?
Yeah, sure. Please do that.
So I'm very pleased to be part of this architecture summit. I actually participated to the first one, but just as a viewer, and it was really interesting, and I'm really glad I'm being part of it as a moderator and a speaker for a few blocks. So you're gonna see a lot of me if you both on the career and the culture. So my name is Gaëtan Bloch. I'm broadcasting from France, actually from the West Coast, near the ocean. It's really rainy and not sunny at all, even though I'm at the beach. So it's not pleasing, even though I'm on holidays. But yet, we are here. And so today, for this block, moderation block, we're going to present you documentation about architecture. And after that, so we're going to have like 3 speakers. And after that, we're going to have a QA panels with the 3 speakers for 30 minutes. each talk will be 40 minutes, and yeah, don't hesitate to ask questions, to exchange opinions on the chat, and well, anything you want, no taboo, and please do as you please. And
yes, we really like your questions and we look forward to them during our speaker speeches. And Gaëtan, while we have time, perhaps you can share your experience, emotions on the first architecture, or perhaps you have already joined other summits by Geekle. Just tell us a bit more. We are really interested in your feedback.
I've joined the Architecture Summit, the QA Summit, the Angular Summit.
Oh my God, so many of them.
So yeah, I'm pretty addicted to Geekle, I might say, and yeah, so yeah, it's amazing to see how fast it basically started like around 2 years ago, right? If I'm not wrong, and like maybe more. I don't know. I'm not sure, but well, the first one I assist was the Architecture Summit. It was 1 year ago, approximately.
Oh my God.
And
I'm really pleased to know because this is my summit.
Yeah, I say first, and yeah, and that's why. And I really appreciate the quality of the speakers and the speeches that you provide, and the community behind. And well, I'm amazed about people exchanging about like high trends topics, and well, I'm really excited to be part of that. And further, all the architecture, even for the front ends, the React, the Vue.js, and the Angular summits were really great. We were brought with great ideas and great like news, and I learned a lot and a lot and a lot. I can't count how much I learned from the speakers, and that's really yeah, I can't like think about anything other than that right now. So yeah, I'm pretty happy to be part of it.
Thank you so much. I'm happy that you've joined us and for your great help, not only with actual software architecture, but other summits. As far as I know, you're joining our DevOps summit as well, and I'm really happy to have you there. And again, so our attendees will see you soon, and you will be here. You will have a talk on a use case. So perhaps you can spread a bit light on the talk just while we are waiting for our speaker.
Oh, just the speaker he's here already, but yeah.
Okay, I'm so sorry. Hi.
Yeah, the speaker is here, so I can put him. But even if you still want me to talk, I can. But I'm pretty sure he's waiting, so I'm gonna put him.
Okay, yeah, right? Sure. I've just didn't notice since we have so many windows over here, boxes. That is why Piotr, hi, we can actually add him. Yes.
Yeah.
Yes. Hi.
Hi.
Guys.
Hi. I'm happy to see you. And this is one of our program committee members, by the way. So thank you once again.
Hi, everyone.
Okay, so I believe that I need to go and leave you. So the floor is yours. I wish you good luck and thank you for joining.
Awesome. Thank you, Anna. So let me share my screen real quick. I'm going to do this. So my name is Piotr Zaniewski. I work at Fresenius Medical Care. And I want to talk to you today about cloud-native documentation. Maybe a little bit about myself before we start. This is my first experience with the summit. I've been approached by Anna, and it's been an amazing experience. I'm really excited to be here. The collaboration with Geekle was simply great. So really excited to share my presentation with you guys, and hopefully it will be fun. So let's start. By the way, on the bottom, you see the Twitter handle where you can reach me, as well as Medium. I publish a lot of blogs there. So if you're interested in reaching out, I would be really happy to hear your opinion and maybe questions about the presentation or anything cloud native or Kubernetes. All right, so I think most of you was in the situation where you get into a new project and the documentation is either not there or not sufficient. You cannot find anything, you don't know how things work, and it's simply an awful experience. So why is it happening? Since we know that documentation is important, why software documentation is not maintained? So I think there are a few reasons for it. The first is that the pace of software development is constantly increasing, And unfortunately, there are often business decisions to let the documentation go, or don't even do unit tests or other awful things. So that's probably one of the reasons. Another reason is that documentation tends to be more and more complex over time. Things like diagrams, drawings are very brittle. The more architecture you introduce to your system, the more microservices you might add to your system, the more documentation tends to be complex, and then maintenance of this documentation is really hard. And finally, if you would think about spending your day coding and writing documentation, which one would you choose? Well, most of us would choose coding, right? So writing documentation from scratch is boring, opening Word editor or whatever. So definitely developers tend to skip the documentation parts and focus more on coding. So since we know why documentation is not often maintained and correctly maintained within the projects, what are the goals actually, just as a little reminder? Why do we even care? Why do we bother with good documentation? So there are many reasons, but here I listed 4 I believe are very important. So first of all, I guess most of you had this experience where you have new team members coming to the team, and then they just take a lot of time. You have to spend a lot of time with them if there's no documentation. If they would have been a good documentation, then it's much easier to onboard new team members, right? You just place someone in front of the screen, they spend some time reading good documentation, and they get up to speed with the project. In the larger companies, it's very often that you transition your projects between the teams internally or externally between contractors. So the same kind of principle. If your project is well documented, it's just much less friction and much less lost time in communicating with the other teams or contractors, so they can just read the documentation, right? Another big part, especially in companies that are heavily regulated, like Fresenius, for instance, you have a lot of regulatory and compliance requirements. So you're very often audited by external bodies. If this is the case, auditors often require documentation to be there and fulfill specific criteria. So regulatory and audit requirements are very important. And finally, last but I feel most important, documentation really helps you think and address all the stakeholders of your project. When I mean all, I really mean all. So people like your customers, your colleagues, your peers. So there's all kinds of stakeholders that will essentially consume your documentation. So when I learn, I like to use acronyms or all kinds of techniques to memorize better what I'm learning about. So I found out that good software documentation have these 5 characteristics, and so happens that they form a nice acronym called SHARP. So the characteristics of good software documentation are as follows. First of all, it must be simple. Simple means that documentation should really be as minimalistic as possible to decrease maintenance effort. Because as you remember, one of the reasons why documentation is not maintained is the fact that people just don't have time for it and becomes more and more complex over time. So keeping the simplicity is really critical. Next point is holistic. I just talked about this a moment ago. Documentation should address all the stakeholders. Finally, automation. We live now in the era of DevOps, cloud native applications. The software development process is much faster. Applications are created, deployed, destroyed. You have containers, you have Kubernetes. It's a lot of things that are moving around. So documentation, in order to correctly reflect the state of your system, must be automated in order to make it maintainable over time. Now, when I say automated, that doesn't mean that you automate everything. We're going to look at this in a little bit more detail later. documentation should be automated around the process of creating it, wherever it makes sense. Finally, documentation should be reusable, meaning that if you work with a certain team inside of your organization, you want to be able to apply the structure, vocabulary, and model to all the projects across the company. So building reusable blocks that you can compose your documentation off of is really important. And finally, portability. There are obviously off-the-shelf tools that help you maintain documentation and create it, like Confluence or SharePoint, but all of this is not really portable. You cannot take your documentation and just deploy it to AWS or Azure or host it on your Raspberry Pi. So the goal of having a cloud native documentation is really very high degree of portability, so you can reach your audience anywhere. All right, so let's look a little bit deeper in the simple part of the documentation. Most of you probably who work especially in a bit larger companies or a highly regulated environment have some proprietary systems that require typically Word documents or PDFs. So somehow Word and PowerPoint become de facto the documentation tools, which is really cumbersome because the format that they use is not open, it's not an open standard, and it's not really something that developers tend to do. When we code, we are typically in Visual Studio Code, Eclipse, Atom, so ever. And we don't want to break the stride, right? We don't want to exit it. So my opinion is that the base of every good documentation should be Markdown. So Markdown file is a very simple format where you can put just a few attributes around your text, and then Markdown file is being formatted. Moreover, this Markdown file can be used as a base to create more interestingly looking and fully fledged web pages for your documentation. Besides being simple and ubiquitous within the environment, Markdown is also fits seamlessly into developer workflow. So when you work with your source code, you typically would have a README file. Most of the projects on GitHub would have also a README file. There's some degree of automation around it. And this is very natural for developers to work with. And last but not least, Markdowns are very easily converted to other formats. There are a lot of tools that help you take the Markdown content and convert it, as I mentioned, to web application, static web app, or to convert it to PDF or Word format or other formats. So what does holistic mean? There are no tools that I know of that can help you create your documentation in a way that which will help with naming conventions. All right. And finally, you should try to provide ways to collaborate online. I am giving here specific tools as examples that you could use, but there are obviously always alternatives. So HackMD is one of such tools where you can export the Markdown file, collaborate with your stakeholders, and import it back to your repository. All right, automation. As I mentioned, automation is important, but when it makes sense. You don't want to automate the content of your documentation. This is something you have to write about your software. But for example, generating visual aids like diagrams or rendering other helpers like that can be automated by introducing diagrams as code tools, like, for example, Plant2ML that I like to use, or Mermite, or there's many other ways to do it. And the benefit of this is that your diagram is at the end created as code, as well as you can then distribute this code and render your diagram. Then when you make changes to parts of your diagrams, you can easily do this and reuse parts of your diagrams in other diagrams, like building blocks of your system, which really saves time and makes sure that your diagrams never become brittle. They always stay up to date because you do have just a few places to update your diagrams in. And finally, using CI/CD pipeline to format, transform, validate, and distribute documentation. You shouldn't really manually distribute anything. This is a process where CI/CD pipeline can help. There is some other tools that can help here, especially around APIs, gRPC, REST APIs, things like Swagger, Open API spec. So if you write an API, you should consider writing an API spec first, so creating a JSON specification for your API, and then using tools like Swagger to generate documentation from there. Reusable. So if we talk about software documentation specifically, there are certain standards that provide structure around the layout of your documentation, how this document looks like, and what goes into each chapter. So TOGAF is one such methodology that is more geared towards enterprise level architecture. This is probably not something that developers directly would be dealing with, more like enterprise and system architects. Arc42 is a really interesting project that proposes a very detailed structure for software architecture documents. So the way inside, how it looks, what are the chapters, what each chapter contains is very, very well laid out by the Arc42 standard. You can combine Arc42 with C4 model, which is another model of helping you to model your software. And this becomes your reusable standards from project to project. How are you deal with documentation? It's really helpful to agree with all the project stakeholders that this is how it will look. And portability, finally. For me, portability really means that I want to be able to deploy and host my documentation anywhere. So how to achieve portability based on the previous tenants? So we already saw that using Markdown is something that we can do and build from Markdown our web pages. So if we use things like Doxify or Hugo or Gatsby, which are static site generators, those of you who are closer to web development space probably heard about Jamstack, which stands for JavaScript API markup, which is a relatively new form of creating web experiences. So this is very similar philosophy, but applied to your documentation. So when we do this, we can actually host our documentation anywhere. So here I listed a few major cloud providers, things like Netlify, Surge, Vercel. You can host it again on your Raspberry Pi or on-prem or on your laptop. So it's just simply a set of static files or a very simple web server. Additionally, you can use PWA features, which stands for Progressive Web Apps, to enrich the experience of your end users and make your application look like an operating system application, Windows or macOS, or also available offline. So the options are there, and those are all open source tools and all free to use. So just a quick summary. This diagram was, by the way, generated in plant.uml. So there is a text behind this diagram, and plant.uml generates it. So you don't necessarily need to have an ugly-looking diagram. So it can also be pretty nice. So we have simple, as I mentioned before, holistic, automated, reusable, and portable. So there are a few more advanced topics that I didn't cover in this kind of basics of documentation. So first of all, there's something like developer portals. Now, this developer portals has a few different meanings, so let's disambiguate this. Developer portal is often means a set of APIs that are exposed to external developers and we can consume. So for instance, companies like Mercedes have won last year award for the best developer portal. It's somewhere where you can go, create an account, and play with Mercedes APIs. But the other meaning of developer portal is actually an internal structure where you can capture how your documentation and access to all the software looks like from developer point of view. I highly encourage you to check out the project Backstage. I believe it's from Spotify. And part of this developer portal is actually a much nicer and more, I would say, holistic documentation, where the documentation that we developed in this way can be part of something bigger. So this is kind of more advanced topic where you start seeing that your single documentation and there's some other documentation, they need to be somehow connected. Then things like Backstage can help a lot. Now, if you work more with cloud or more in DevOps, you probably know that deployments continuously change. So a deployment diagram would really be a diagram that depicts current state of my infrastructure and my application. So this can really evolve rapidly. So making those diagrams, even in an automated diagrams as code way, is cumbersome. So what you really want is a tool that can take the state of your infrastructure in the cloud or your applications and then automatically generate a diagram for you that is kind of like a live object, and you can embed it in your documentation. And as I mentioned before, one more advanced topic is conversion between different formats. I talked briefly about the fact that highly regulated environments often have their proprietary software that require a PDF in a specific format or doc in a specific format. So all those things can be converted in an automated way using tools like Pandoc. It's a very popular tool that converts any format to any format. And the way to do it, looking at the tenets of good software documentation, is really create a step in the CI/CD pipeline that takes part of your source from your documentation, which are markdown files plus some pictures, and uses Pandoc command line tool inside of the CI/CD pipeline to generate a PDF or Word document and then put it somewhere on SharePoint or somewhere available. So again, fully automating this type of process. So who uses this approach, right? That's not something that is niche or weird. This is actually a very mainstream concept that is used by the big tech companies. So for example, if you go to Microsoft Azure Docs, this is generated in exactly this way as I explained, using Hugo. Most of those documentations are generated using Hugo. The same for .NET documentation, or in the right-hand side, you see Ansible from Red Hat, or the GitHub docs themselves are all generated in the same way. Those different tools that help generate the documentation work slightly differently, So we have a tool that is more geared towards creating document-looking like pages, or a tool that is more geared towards creating web pages experiences. So let's look at how could we implement this particular architecture within our system. Another diagram generated using PlantUML that shows us how this could be done. So imagine that you have a system. Let's say it's not necessarily microservice architecture. It's an N-tier system that has separate repositories for database, separate repository for UI, separate repository for API. What you could do with this instance, you can create a dedicated documentation repository, and I think I will still have a little bit of time to actually show how it looks in real project. So you would create a dedicated Git repository that would contain your markdown files that you write your documentation in. So you explain what your system does, you create some high-level architectural diagrams inside, and you just give all the stakeholders relevant information about your system. Then you would place necessary configuration files for the tool that you're using. For example, I'm using Docsify for my personal documentation, or I'm using Hugo for my blog. So you could just have all kinds of different tools, but they all require some form of configuration. And then additionally to that, since your system consists of multiple repositories, you can actually pull in the README files from all those 3 other repositories. So those repositories just have their own README MD, and maybe there are other developers or other teams that develop those subsystems, and they can create a documentation in those repositories independently, and your system could pull it in, making a composable documentation. So once this process happens in the CI/CD pipeline. So whenever anyone commits something to either of those repositories, you can set up a CI/CD pipeline that would detect the change, take the Markdown files, convert them to a web page, and then deploy this web page to wherever you want. It could be Azure, like in this case, or Netlify, and it would be served as either a static content or a web page, normal web page from the server. And then your stakeholders can consume this documentation. Now, since this is a web page, then you have all the perks that web page provides, right? So you can, for example, add authentication to your web page. You can add additional elements to help your stakeholders render your web page and access it via browser. So this is an example of the implementation. You can obviously have different architectures around it, but I think this one is in one way, minimalistic architecture that gives you enough to start working with, and also has this nice added benefit of pulling the documentation from other sources, so you can compose documentation of your system. All right, so since I think I still have 15 minutes left, can someone confirm? Then I can show a little bit of demo.
Oh, sorry, we lost Piotr. I don't know where he went. Oh, okay. He's back. I put you back. Yeah. Sorry, Piotr. Yeah, you do have 15 minutes left. You can continue your talk. I don't know if you hear me. You're hearing me. Okay.
I can hear you. I can hear you. All right. Yeah. So let me come back. Apologies for that. I just dropped the connection. Okay. So if you don't see my screen, guys, just let me know. But I hope it's all okay. So let me show you how does this look in practice. So here on the screen, you can see a source code repository for my personal documentation. This documentation is around learning and preparing for IT certifications. It's just for me. I typically make notes and diagrams for myself, but please feel free to use it. It's hopefully contains some useful information for you. So let's first look at the final product of how it looks. So this is a web page, right? I have a nice splash page. I have some additional content here, an icon to take me to GitHub. I can click. It has animations, menu on the left-hand side. In this particular case, I have here information around passing Azure certifications, Kubernetes certifications, and so on. And here I also have some cheat sheet and commands. And as you will see in a second, they are coming from different sources, not from my documentation. And let me just show you one of the diagrams. Hopefully we can go to this page and then look at, this is sometimes showing unavailable. Like you see, this is a diagram from Plant.uml rendered dynamically. I haven't mentioned this, but what you can do with your diagrams in this particular way, you can either embed your diagram as a picture, or you can use Plant.uml proxy server to render the diagrams on the flight. This is particularly interesting because if you change, you can have a different repository for your diagrams, if you choose to do so. And the moment you change a diagram source code and commit it, then all the other repositories that reference this file would have a new version of this file available. The downside of it is that sometimes you get this error 503, which means you got to refresh the page, and then this error will likely go away and render the diagram. But as I said, you can also embed the diagrams directly. So that's how it looks. The final product is a fully fledged web page. You can even do things like make it light, which nobody should really do. We all like dark. So that's the dark theme. It has these nice boxes. You can share this on social media. So, right, a normally nicely looking, sleek web page. So how does the process of getting this end product look like? Well, here is my repository. And you notice that within the repository, I just have some README file that is only for the repository describing what's inside. And I have a docs folder. So inside of my docs folder, there's a bunch of Markdown files, really. If you look at the extension of the files, almost all of them are Markdown. There's only one file called index.html. And in this particular case, what I am using Docsify, which is a really interesting open source product that helps you generate those document looking like pages. So this is a little bit of busy here at the end, but it's not that difficult. You just really what you do, you add those plugins. So Docsify works with different kinds of plugins to make your page look nice or to add certain functionality. Like for example, here I have a plugin that I am pulling from JS Deliver CDN, and this plugin gives me a code highlighting. So this is very useful when I have a, for example, bash or YAML file. It looks much nicer and it has colors. If you remember, I mentioned that we can pull documentation from different sources. So here I have an actual router, internal router within my web server, because this documentation is not a static page. It's actually a very simple web server that serves the documentation in HTML form. And I'm pulling those gists, in this case, those are Markdown files in gists that are rendered as web page. So for instance, here I have a bunch of useful kubectl commands. I can go back to my page and I can say kubectl commands, and there they are. And this actually comes from this external content of my gist. but I'm also linking other people's gists, for example, for tmux or other commands, which is really useful. And as far as configuration goes, you could see here in this particular tool, we have an object called window that you can configure by adding all kinds of additional plugins and configure those plugins. So something interesting here, for example, I am enabling remote markdown, so I can do those things here, so render markdown remotely. I am using flexible alerts, which is a nice plugin that gives me this kind of nice look and feel for my boxes here with attention, note, and so on. And everything else other than this configuration, so that's really all there is to it, is markdown. So if you go to this main README file, which is the main page, this is the only thing that is not markdown specific. So this exclamation mark note renders to this alert box that you've seen before. Everything else is just markdown. There's nothing else. There's just markdown here. And all the other files are also markdown. So how, for example, do I construct the menu here? How would I do this? Normally in web programming, I would have to have some nav bar element and do a little bit of CSS and Java. Oh, I'm sorry, my dog just barking. So how do I do this? It's very simple. I have the sidebar file where I just create, again, a markdown representation of my menu. So everything is configuration input and then output as a web page. So those are those elements, and as you can see, this is really easy. It's extremely easy to do. So there are some bits and pieces that you have to configure using this index.html, and everything else is really markdown. Now, as for diagrams, those diagrams are actually in different folder. Here are my diagrams, and here are my plant.uml diagrams. They are all in the plant.uml format, and they are then rendered to the pictures that you've seen before on my webpage. So all those other kinds of diagrams are actually here. So you could imagine having certain naming conventions like I have here, something about Docker, something about CKS, which is a Kubernetes certification. And then I'm just following this naming convention. I'm including different parts of the diagrams within my diagrams. And this just makes me very productive in terms of depicting how my system goes. Now, I am using this particular project as my personal notes-taking product that I share with everyone else to just benefit from if you would like. But remember, you can do the same with having an actual software documentation. So you would follow ARC42 or other standards to actually capture your structure of your document. And since I think I have a few more minutes, I can actually show my other project that is also in the same way, but is actually a block. So just load all my million repositories. So my blog is actually done in a different technology. So I am using a Hugo site generator here. It's a little bit more involving. So the same configuration as you've seen with the Doxify tool was in the index.html. Here I'm using TOML, which is a lot of stuff here. So Hugo is kind of provides you much more flexibility around configuring the end result of your web page. It's not that difficult to learn. It's very well documented in and of itself. And I'm steering how my web page at the end would look like by using those configuration parameters. But with Hugo, I can also provide additional layouts. So I'm going to show you a file. Please don't be afraid. So you see, it's pretty busy, but it actually comes predefined with a theme that you want to use. So here are so-called Go templates. Hugo is written in Go, mixed with raw HTML. It basically builds the scaffolding of your web page. So Hugo gives you way more flexibility around how the end product will look like, whereas exposing you to more complexity when you do this. And it's more suited to kind of more, I would say, busy web pages. So if you remember, I showed that .NET docs or Azure docs are actually written in this particular way. They are generated using Hugo. And so this is Hugo, and the end result would look something like that. So that's my blog. Again, it has this similar functionality. It can be dark and light. Obviously, we all prefer dark. It has some posts. You can click on one of my blogs and just read through it. So very, very similar experience like the previous one. But again, this is more like a web page. So this is where I'm using it for my blog. So you don't have to be a professional web application developer in order to actually create those experiences and web pages. And most of all, the degree of automation that you gain from doing this in this way is extremely high. So you don't spend time tweaking, little bits and pieces of CSS. You don't really need to create those kind of snowflake-like experiences where you can more follow specific standard. And then if, let's say, someone else takes over your documentation, they can very easily understand how it's put together because it uses those open standards and open tools to generate itself. So highly encourage everyone to look at those tools. Please feel free to explore my GitHub repository. It's the same handle as my Twitter, by the way. Look at the pages and give it a try yourself. Let me know on Twitter or on GitHub what you think. If you have questions, I would be very happy to look at problems that you might be having with your documentation and help you. So you can reach me out like that. You can also connect to me on LinkedIn. I'm really interested in your opinions about your experiences with those type of open source, fully cloud native documentation as code. So I think that's about all I have for today. Thank you so much for having me. I hope you learned something, and till next time where we have QA session in an hour or 2 hours. Thank you.
Thank you, Piotr. And that was very interesting to learn. Since we have like 2 minutes left, I had a question for you because you talked a lot about Markdown, but what do you think about ASCII doc format actually for documentation?
Yeah, you can do the same. So as long as you can generate web pages based on it, as long as it's a standard, an open standard, definitely a way to go. ASCII doctor or ASCII format, absolutely a good approach. Yeah.
Okay, thank you, Piotr. We'll see you at the QA panel. Thank you.
Thank you, everyone.
So now we are receiving Dima Ovcharenko, if I'm saying it right.
Yeah, you're right. Hi.
Hi, nice to meet you.
Nice to meet you too.
So you are going to talk about how to document your decisions. Is that right?
That's right. Yeah, we will talk about how to document architecture decision from my experience in a huge healthcare projects. You're right.
Then I'll let you the hand. Thank you.
All right, so we can start, right? Let me share my screen. Hello, everyone. Just a second. Yeah. I suppose you right now see my screen. So yeah, today we will talk about how to document your architecture decision. A few words about me. My name is Dima Ovcharenko. I'm a senior solution architect in a SoftServe company. the biggest service consulting company in Ukraine. And a few words about my experience. I'm a huge fan of architecture methodology. I'm working with the last years. I work with Department of Defense, United States, and it was a really challengeable experience for any architect in context of documentation, enterprise architecture, etc. So yeah, in my topic, I will not share why you need to document your decision. We assume that you already understand that documentation is the right way for your architecture decision, for knowledge sharing, stakeholders management, etc. So let's deep dive. So first of all, yeah, let's define what is context of our documentation. So what we actually documented. Right? Software architecture definitions. Actually, from my experience, I'm reading a lot of books, participated a lot of trainings, software architecture trainings, and I heard a lot of definitions of software architecture. But I like more this one because I can explain it with one diagram. So software architecture, it's a simply structure, right, or set of structures which consists some elements. In this example, you can see semi-structured format like UML. And these elements like packages or components has some visible externally visible properties. Architects call them qualities of the system or qualities of the components, right? For example, this web service has some relations to capacity or performance, right? This client application has some usability quality, right? Or this one device has a capacity, right? Like CPU, RAM, etc. So all of these elements has relations between each other, and this very important as well. Yeah, and from my experience, again, I read a lot of books about architecture. I understand what is architecture, but what next? So the simple question, okay, I understand what is architecture, but how I should implement architecture, how I should define right decision, which will achieve the requirements from different stakeholders. And a lot of us understand that there are a lot of actual architecture methodologies, a lot of architecture frameworks around, and my short summary here. So any methodology actually consists 3 simple steps. The first one, we as an architect should gather requirements. Then based on these requirements, we actually make decisions, right? And the third step, we should analyze or test somehow our decisions, right? On the first step, the main, I would say, requirements for architects should be business goals. We should understand what the business need is, right? We need to understand some main features, not all of the features from the project. Usually architects don't care about all requirements from functional standpoint. They think more about quality attributes or non-functional requirements, quality attribute scenarios, technical constraints, business constraints, architecture concerns, and risks. So this is the set of main significant requirement or architecture drivers for any architect to make right decisions. Then we start and think about, all right, so I gather some requirements, so what next? And on the market, we have a few very well-known architecture methodologies like attribute-driven design from Software Engineering Institute, or ADM from TOGAF, or even we already discussed C4 from Simon Brown. It's a great tool for architects, young architects, how to document and how to decompose their decisions. Of course, we have ATAM, attribute trade-off analysis method, and cost-benefit analysis. We have some books or templates. Already mentioned Peter about ARC42. It's a great example of how to document your architecture. And of course, analysis, the first step, how to test your decision, creating proof of concept, or provides to another architect, perform some peer review, or again, perform a TAM for analyzing your decisions. And all of these three steps has some connections between each other. And let's dive in details and see how it look like from detailed view. So our business goal, it's I would say it's a main driver. So all our system, all our development efforts, quality control efforts, all about business goals. So this is the main important for us. And business goals, it's kind of abstract, real business needs, right? And it's quite difficult to create decisions around business goals. So that's why architects define significant architecture requirements or architecture drivers, which actually consist quality attributes, scenarios as functional requirements. Usually functional requirements answer on the question what system should do, right? And the quality attributes, scenarios and quality attributes answer on how, right? How quickly, how securely, etc. Also, we should define some constraints, right? There are a lot of them, like time frame constraints, legal constraints, Scrum or Agile constraints, SDLC constraints, architecture technology constraints, right? Legal, HIPAA, PCI compliance, ISO standards, etc. And subset of architectural technical concerns. It's all about configuration, CI/CD, code review, coding standards, etc., etc. Who never saw 12factors.com, please visit it. It's a great, I would say, list of technical concerns. Any quality attribute scenarios consist a few parts, and one of the important one, it's actually response measure. Architects should define response measure for non-functional requirements because it matter. Usually, stakeholders they think about, for example, availability. Like, okay, we would like to build web application with high availability or with highly security. All of these highly faster words, it should be a trigger for architects. So architects should define what mean this fast or what mean this highly available, right? So we need defined numbers, and it is really important in future to test and achieve these numbers in our architecture. When we define our architecture drivers, we start to generate architecture decisions, right, which will achieve high and medium priority requirements from architecture drivers. And any architecture decision will decrease or increase costs, right? Usually increased. It decreased complexity of the system. It could have some positive sensitivity points on measurement of non-functional requirements, right? So, for example, I'm introducing load balancer as a pattern, and I will positively affect availability of the system, for example. And it would be a sensitivity point. Why actually I'm introducing the load balancer? Because I have availability requirements, right? I can introduce some trade-offs or risk. For example, I have highly secure application or security quality attributes with a high priority, and the performance quality attributes with a high priority, right? And when I achieve security, usually I decrease performance, and it would be a trade-off. And all our architecture decisions and architectures actually built on trade-offs. It depends. It's a usual sentence from architects. Architecture decision actually combines solution architecture, which models solution, and solution achieve business goals. So it is how all stuff related to each other. And okay, we understand it. We understand methodology. We understand that we need somehow manage architecture drivers. We need somehow, I don't know, document or store our architecture decisions. we need somehow analyze our architecture decisions. So, and right now we need to think about how actually, what the structure of the document should be to achieve all of this stuff. And here's the artifact reference model of our architecture documentation. And we will deep dive in each section right now, but you can see that we have quality attribute requirements and requirement solicitation section, and we have architecture drivers here, right? And all important requirements here. We have a section of solution architecture and architecture view. Probably most of you heard about architecture views or viewpoints. It is something I would imagine it like, you know, package of slice of architecture or package for architecture decision for some stakeholders' needs, right? And we will detailedly describe how it's actually structured, and we will have here reasoning section, which actually our analysis phase where we define our trade-off risk and non-risk items. If we working on consulting, usually we have estimation and planning section where we propose what the deliverables will be, what the milestones, estimates, team composition, team skill set and structure should be, right? All our assumptions and limitation in this section. Yeah. So during consulting activities in our company, we have such type of documents. First of all, it's proposals on pre-sale activity. When we convert potential client into our client, we understand on high level his needs, right? And we propose, so it's short documents where we propose ideas on high level, right? Some high level requirements, high level architecture, technology stack, team composition, and some high level estimates. Then we start in work closely with our clients, and we start and build production system, right? And we generate architecture vision. And template, which I showed before, it is actually architecture vision. Usually we also perform a lot of architecture assessments, and we have another templates for architecture assessment reports. When we documenting existing architecture, so we call it a software architecture document or SAD, and it is much bigger than architecture vision. We describe product line, we describe the stakeholder management and their concerns there. So there are a lot of additional sections. And on low-level design, our technical leads usually prepare feature design documents before starting new feature. They actually create the low-level design with class diagrams, entity relationship diagrams. Some, if they introduce some new libraries or tools, they perform some comparison analysis. So, and they approve this ideas, this designed with architects, and move forward to implementation. So any documents from list above has a general section, which actually includes some executive summary, some reference to other documents. We have drivers, right? Significant architecture requirements. So the section with all of these requirements also should be existing in document, and then architecture decision, which should have linked to the requirements, right? And here's the structure of our documents in details. So again, introduction and executive summary, most important one, because any stakeholders, C-level stakeholders, management, business analyst guys, technical stakeholders, they usually read executive summary. So that's why architects should include in short form the main decisions about our project, right? So in executive summary, all main risks should be there. Mitigation strategy about this risk should be also present in executive summary. Architecture drivers, we already discussed about them. Then we have solution architecture section, and solution architecture consists number of views, right? and we will discuss how they looks like right now. And of course, operation plan, but usually in modern application, we have separate documents with operation plan, CI/CD pipelines, infrastructure as code, etc. So it's huge part of the documents. That's why we actually split it on a separate one. So architecture drivers, the most important, as I mentioned, it's a business case and business goals. Also for architects, very important use cases, because based on use cases of the system, we usually build quality attribute scenarios as our non-functional requirements, right? If you perform some microservice architecture, even if not, it would be great to perform some domain-driven design, right? Perform event storming, and if you have documented artifact with all your domains, bounded contexts, etc., and relations between each other, so it would be great to put into architecture drivers as well. Constraints, I already mentioned them, and SLA, service level agreement. Actually, we filled this section from quality attribute scenarios. So we mentioned about availability, some security, legal stuff, etc. So architects actually impact SLA a lot, right? Any architecture's view structure consists intent section, which actually has a link to requirements. It is really important, or link to some stakeholders' concerns or stakeholder requirements, right? So intent is very important to explain what I will achieve in this view. So what the requirements I would like to achieve or cover on this view. Context in which we actually implement such decision. Of course, representation or diagram. So usually human being understand complexity and visual format, box and lines, or semi-structured like UML or structured ADL language, right? So, and also very important catalog of elements, because just the picture, it's not enough. After years on the project, when I saw my personal pictures, my diagrams, I just trying to understand what I actually mean in this diagram. So catalog of elements with all relationships between elements help a lot to understand what's going on the diagram, of course. Contracts, if you have some, or link to contract specification. If you need to demonstrate some dynamic, right, data transfer or some sequence diagrams or activity diagrams, you can put them into behavior section. Variability, usually all about configuration and boundaries on which your view still can be applicable. And reasoning. So here's our analysis of architecture decisions. So architect perform analysis. So defining all sensitivity points, all trade-offs, all risk and non-risk items here. So we usually recommend from the beginning, based on C4 model, already mentioned about this one, we define it system context view. So this is the high level visualization of our project. So where we have project as a black box, right? And all context around it. So all external services, all users who will communicate with our system, probably some deployment, cloud infrastructure where we deploy our application, maybe some major frameworks we will use on front end, back end, etc. Then we just a little zoom this black box and visualize containers. On this step, we can use all architecture knowledge around the world and trying to decompose our application using some architecture styles or architecture patterns, like service-oriented style or microservice, like a part of service-oriented, right? Monolith, layered architecture, entire architecture, etc., etc. So somehow you define this right style for your future product, and then you zoom it much more and actually define, for example, how my presentation tire looks like, how the single page application looks like, how I will manage my components, etc. So, or how my application tire looks like, right? What the archetypes inside this tire or layer, right? So this is important. Of course, deployment view, which is not part of C4, but it is something usual in current web application, mobile application. So we need to specify how we deploy our software elements into computation resources, right? And then number of tactic views. So what does it mean? For example, I have high importance availability requirements, right? And I need answer how I will achieve this availability scenarios or scalability scenarios, what the architecture decisions should be there, right? And I will have number of tactic views, how many high priority requirements, quality attributes requirements I have. So many tactics view I will have in my documentation. Also, we need to specify operation plans. So usually we split on transition phase and operation phase. Transition phase, it's all before the, so it's all stuff before production. So how many environments we will have, how our CI/CD will looks like, how the infrastructure as code looks like, etc., etc. Operation phase more about how we will maintain our qualities and achieve service level agreement. Yeah, let's perform some example and imagine we have the best web application in the world, and we need to achieve some database reliability, and there are some constraints like Java language must be on the project, and limited budget with 100K. All right, so first of all, we're starting with our architecture drivers, right? And we need to document all of them. So for example, business goals, create the best web application, not the perfect, I would say, requirement, because it doesn't consist some measurements. Even business goals should be measurable somehow, right? So, but we need to specify what is best web application means actually. Deadline is March 2021, for example. We already failed these deadlines actually. Constraints, the programming language chosen is Java. It should be fixed price, budget up to 10K, all right? So we understand it. Then we specify our quality attributes and quality attribute scenarios. In this case, we have business application like source of action, right? Make a transaction, so it's our action. In reporting feature or reporting module, it's our artifact, right? Artifact under high load, so it's our environment. So artifact could be in production, a regular mode, right? Under test, under the DOS attack, etc. So in this case, under high load, and we redirect our request to DB slave and return data without performance degradation. So redirect into DB slave, it's our response, and response measure without performance degradation, but it's still too abstract what is mean performance degradation, and we just put some nodes, approved latency up to 3 seconds, for example. Then we start and create our view, right? So I will skip all context and decomposition view. I'm just concentrate on tactic view. So how I will achieve this reliability on database level, right? And intent in this section, again, I build the link from my view to the requirements. Then I will have some context and representation. How I can achieve reliability, right, on the database layer. The simplest pattern probably it's master slave, right? where we have SQL clients which send some requests into proxy. Proxy cover and can read-write into master and read from slave. Master in some way streaming logs into slave. So regular, well-known pattern, and we put this diagram in box and lines into representation section. Then we have catalog of elements, simple table where we define all my components and actually put the responsibility for elements responsibilities, right? Then we describe contracts if we have some, and behavior, the most difficult sequence diagram in the world, just for example here. And variability, here we describe the configuration difference between performance staging and production environments and all other environments. And of course, reasoning, where we define our main architecture requirements, like using master slave. We have some sensitivity, positive points, how we will achieve this reliability requirements, right? We have some trade-offs, for example, reliability pattern or master slave requires some additional computation resources. It is not so trivial pattern anyway. We introduce additional complexity, additional cost to maintain, etc. And we define another architecture decisions and analyze them one by one. If we define risk, we need perform risk analysis. We should identify risk probability and risk impact, and then define priority for this risk. And if it's medium or high priority risk, we need generate new architecture decision which will mitigate our probability or impact or both. So and it is a new architecture decision, and we need again perform analysis of this architecture decision, what the sensitivity, what the trade-off, or maybe additional risks we will cover during this new architecture decision. And this kind of loop, architecture loops, architecture analysis. So probably that's all. Some useful resources I would strongly recommend to read: Documenting Software Architecture View and Beyond, 2nd edition, and even past the training from Software Engineering Institute about how to document your software architecture. Reading ISO standards around software design and documentation. Of course, applying UML patterns. Read about this community ARX42. Of course, TOGAF ADM, very good one for architects, how to create them and analyze the architecture. Of course, C4, or if you have questions, just send me them and I will answer in LinkedIn. I can share the templates which I demonstrated before, so, and answer on all your questions. Thank you. That's all from my side.
Okay, thank you. Oh, you still have like 10 minutes on the go. You have something to add, or well, I can just ask you a few questions.
Yeah, let's do it.
Well, maybe some general. Well, you've been a software architecture for architect for how long? I didn't catch at first.
So I'm leading my current project as an architect since 2013. It's about 8 years, probably, right?
Yeah,
something like that. Yeah.
So, what made you like realize that decisions was a key part of like making the architecture? What made you towards that direction?
So again, we have a huge, healthcare clients, and we have a lot of Scrum teams, and we figure out that the technical knowledge, it spreads around the team, and we don't understand what's going on right now. And we decided that we need some some methodologies, some frameworks how we will document our decision, because we have a lot of refactoring right now. We have part of legacy system, and we need perform some re-architecture, and without defining the architecture, without documenting architecture, it's really difficult to understand and analyze the impact of the re-architecture and refactoring, right? So that's why some years ago we started learn some architecture, stuff, and certify our technical experts in architecture methodology by Software Engineering Institute. And right now we investigate TOGAF a lot, because we have government projects, and they prefer TOGAF much more than any other, methodologies. So.
Okay, and what was the hardest part in that transition that you faced, and you and your experts, of course?
Transition? You mean transition in re-architecture, or?
Yeah, I mean like towards decisions, architecture making. What? I don't know if you understand the question, but yeah, what was like? You started basing your architecture on your decisions, and you said like you took certifications from infrastructures and stuff. And what was the hardest part to learn and to implement after that?
This is a great question, actually. When you start reading books and even complete the certification, you just still don't understand how to actually what any certification do not provide you templates for documents, right? They not guide you how to document your decisions. So that's why we just, it was experiment, so it was proof of concept. So guys, let's define this section or this section and section. So it was years of experiments with document structure, and then we actually defined this reference model of how the architecture documents should look like. And it is probably the most hardest task in our architectural learning path, how actually we can implement this methodology in practice. So it is the most hardest stuff, probably, I would say.
Okay.
Practical, yeah.
Okay. So anybody has a question on the chat? No, I'm checking, but like there is none. So I will just continue to chit chat with you. Basically, you've been on. Have you been for your company for 8 years? You said you were architect for 8 years, or you joined as an architect, or you started with another role, I guess.
So in our company, we have 10,000 people right now. So it's an outsourcing company. We have a lot of clients around the world, huge clients, and I participated in a discovery phase. It's kind of when we engage potential clients, and it was 11 years ago when we actually performed some discovery on some healthcare project. I can say the names. And I'm started like a senior engineer, front-end engineer on that time. So it was 2010, and we built the first single-page application probably in our company. And it was Backbone. No one probably remembered. Yeah. Backbone, XJS, etc. And then I'm shifted to technical lead, leading a few teams, and then starting the architecture methodology, learn about architecture, and perform this role after, from 2013, something like that. Yeah, we have 300 people right now on the project. We started from 10 people. And right now it's a huge, delivery account in the company. And we have a lot of clients and PST projects, like enhancements inside the SaaS application, enterprise application, again, for the last year, we work closely with Department of Defense, and there are real true architects in United States. They so strong from soft skills, from theoretical and practical experience. So it was a really great I don't know time working closely with so great experts. Yeah, kind of like that.
So if you have to pick one, it's hard. Just pick one of the best thing you heard from them. You learned from them actually. Like what made you like wow about something that you learned from those guys?
They and huge experts in communication. So
Yeah.
all I don't know kernel cases or something like that, some negative discussions, they just cut all of this stuff and they concentrated on reasoning why we do something. They not perform some hollywars or some talks about nothing. They just concentrate all stakeholders to resolve issues, right? Where we are, what we should do, and they really great document all the decisions. So decision log, it's really great stuff. They just, it's like meeting minutes, but they just capture in this context, we have such context right now, and we define this decision because blah blah blah, and who actually made this decision. It's really great. After 6 months implementing this project, we just ask why we using RabbitMQ. So not Rabbit, sorry, Redis for second level cache. So it was the question why we using this one, and we find the meeting where we define this decision and why we define it, and everyone understand. Oh, okay, yeah, it makes sense. But right now we need to make another decision and avoid this stuff because DoD has some concerns about Redis. I don't know why.
Yeah.
Still investigating. Yeah.
I was going to ask, what was the actual decision that made you choose Redis instead of Hazelcast or something else?
We will have meetings during this week. I will provide.
Okay. Okay, thank you. Okay. We're still waiting for the next speaker. So I guess, how do you see? You see like a continuous growth in your team, right? Because you started from 10 and now you're 300, and whole people in your team are following this kind of philosophy of decision-driven architecture. And I don't know, do you see how big do you think it's going to be in like 2-3 years?
So right now we under the migration from a huge monolith, because we built monolith, the simplest architecture pattern probably. Layer it just monolith, and it was 10-11 years ago. It was really okay, create entire architecture, and right now we face that we can lose our markets, right? And we right now CTO and all management from our customer, they decided that it is time to move into service-oriented architecture and microservice architecture. And right now we all actually learn a lot about these architecture patterns. We perform hackathons between team members just to speed up their knowledge ramp up in the microservice architecture. So we define learning paths, how to migrate from monolith to microservices, reading Sam Newman a lot. So and all other guys. So yeah, right now we are moving into service architecture and platform architecture in future. So, and I see during next 3 years we will be under transition phase, because again we have a lot of thousands of lines of code, and we need somehow to decompose it, learn about domain driven design a lot right now, and event storming. It's really great practices to define services not from just on feeling of beauty, right? But some, a good concept how to define services. So it's perform domain-driven design. So it's a great, process.
Nice. Thank you. Our next guest arrived. So I will see you at the QA after. Thank you for your talk, and that was great.
Thank you for your questions. Yeah.
Yeah. See you later.
See you. Bye.
So now we're gonna welcome Mahmoud Al-Hattab.
Al-Hattab, yes.
Okay, sorry if I pronounce it wrong.
No, it's okay, Mahmoud Al-Hattab, yeah, that's fine.
Yeah. Okay, so welcome to the Worldwide Architecture Summit. So what are you going to talk to us about, and can you present yourself and your talk?
Yeah, well, actually, it's part of that. Yeah, sure. Well, I'm going to talk about making the right decisions in software architecture. It's really related to what has been discussed by Dima a bit before. Yeah, we'll go through defining sort of a process and main guidelines, and give some an example of a process, along with other examples of what we see throughout building architecture or products. So yeah, this is it.
Okay, thank you. So you have a presentation or something?
Yeah.
I'm going to leave the stage and let you.
Yeah, sure. Thank you very much.
Listen.
Okay, let me just share my screen here, and I will. Okay.
Yeah, it's shared.
Yeah, you can see the screen, right?
Yeah, we can see it.
Okay. So, hello everybody. This is about making the right decisions in software architecture. Okay. Briefly, I will go through the agenda. I'm going to talk briefly about myself and about this presentation. Then we will go to defining software architecture from decision-making point of view. And then we will talk about decision-making in this profession, defining a framework process and the factors that are going to affect us while taking our decisions. Finally, if we have time, actually, I have already embedded some examples throughout the presentation. I'm afraid it's a bit long, but I will do my best to finish it within the time frame given. So, I'm a software architect. I have around 18 years of experience in software development. Some of the companies I've worked before, Samsung Electronics, Eastnets, and Lead Technologies. Currently, I'm in second step for software development. Here in second step, we develop systems for education and healthcare systems. Links are provided in the slides. You can see more details on LinkedIn or in the company profile page. Okay, about this presentation. The topic decision making, it's a very important thing to talk about, and it's actually not talked about a lot. So here I'm going to highlight the importance and the right ways to take the right decisions. I'm not going to talk about technical stuff a lot, just giving examples in the technical fields. However, the aim of this presentation is to make a mindset, a way of thinking, the best practices to follow, to be able to make the right decisions. So one of the main concerns here is not just to rush into our decisions or our technologies that we use, like what I call here action architects. No, there is set of steps that we need to take to reach our decision correctly. We need to know the concept, we need to know the theory behind everything, every alternative. We compare alternatives at some stages, so we need to know all the basics about the things, which is a time-consuming duty, which is very important and crucial in our profession and very important for the product that we are developing. Actually, needless to say, why decision making? It's really the source of software architecture. We will see some definitions from different resources in the next slide about the importance of decision making in software architecture. It's actually software architecture has been defined once as the art of making decisions. Why career track? Although I believe this topic is very important for all levels of architects. However, starting the career with the right mindset, with the right process, with the right guidance you have from the beginning, if you are new to software architecture or if you are willing to be an architect, then you need to start right so that you continue the right way. Okay, here I'm quoting parts of definitions. As I told you, Martin Fowler defines software architecture as the design decisions that need to be made early in a project. And in another paragraph, he says the decisions you wish you could get right early in a project. Okay, and it's not about only technical stuff. No, the architect responsibilities span technical and non-technical, business and technical stuff. So some decisions need to be taken in non-technical fields, and this is very important. The architect role is very important in such decisions. Okay, in another definition, it is software architecture is the set of design decisions, the rationale for these decisions, and the knowledge captured. Well, I have set some parts of this definition as bold, and we are going to talk about each part of these bold parts of the definition because they are very important, and every word is selected in for purpose. So these are mainly the examples that I'm going to be giving in these three areas in software architecture: microservices, SaaS integrations. Actually, we will go through them by the presentation. Okay, first let's look at a definition for decision making in software architecture. I have broke down the definition into bullet points. I think this is going to be easier to illustrate. First of all, it's a process of evaluating choices to take actions. This is briefly. When we talk about process, we are talking about step-by-step in a managed way. So there should be management for this process. There should be steps to be followed, and there should be a goal also to be defined, to be achieved. So we need to define a goal, and we will follow a step-by-step procedure to achieve that goal. In evaluating choices, we're talking about options and alternatives. We're talking about collecting information. We are talking about defining benchmarks, norms, and criteria to make the comparisons. Some decisions are, as I'm writing here, are binary. Sometimes we take a decision to use a certain technology or not to use it. In other cases, we need to make a decision which, for example, messages queue to choose. So in different situations, the goal is different, and everything accordingly will differ. If we talk about the action at the end of the day is the selection itself, is choosing the right decision, choosing the right tool, the right technology. Okay. This whole process includes also reviewing, evaluation, and feedback. It's a closed loop process. I need to communicate my decisions. I need to communicate my concerns, my steps, my decisions with everybody involved, with the teams I'm working with with sometimes with the customer, with the management, and this also contains sharing and documentation. And this is important in building the organizational experience, actually. Next case, a couple of years later, we may face a close project to what we have done previously. We need to refer to our previous decisions to know how to proceed with the new projects. At the end of the day, we need to be prepared always for mistakes. We need to have the agility and the dynamic way of our thinking to adapt changes, to adapt mistakes, to have plan B always. We hope we don't go to it, but sometimes we need it. Okay, if we talk about some points in the definition, the goal, it's always this, we're talking about goal in general, maximize profit and minimize risk. In our context, we're talking about maximizing profit in multiple areas. For example, if we are talking about technical and non-functional stuff, we talk about maximizing performance, scalability, security. If we're talking about cost and business, we may consider competency, a minimum time to market, lower costs. All these things are considered goals and will contribute in building up the criteria upon which we are going to make our comparisons. And we will see in an example, I think the next slide or the one after that, we will see how we use these goals. About the right decision. Sometimes, and I've been in this discussion actually many times through my career. Some claim that there is not a clear right or totally wrong decision. There's always a better or maybe a less better. However, if we define our goal comprehensively and correctly, and we define our criteria based on that goal, we will reach what a right decision is. So this needs to be clear and well defined. This is to get rid of the ambiguity about our decisions. At the end of the day, we need the highest level of certainty, the highest level of confidence about our decisions. If we are still unsure of it or about some decision, we need to investigate more. Then this means that we did not did our homework. We did not go through the research phase. We did not go through the investigation comprehensively. As I said, it's a closed loop process. We discuss always, we get feedback, we expect arguments from everybody, and this is healthy and normal and important to have a collaborative environment and collaborative decision making. Decision making is business and technology driven. We will talk about the factors more in later slides. And at the end of, as a bottom line, this needs to be, it's better to have it documented process and to be followed and to be audited as well. However, it's not that much done in many companies. I've been in multiple environments in multiple companies where we don't follow certain standard, for example, but at least we need to have these steps, these procedures in mind that we follow, even if I'm following it alone in building my architecture, even if I'm not documenting, which is wrong indeed. However, I need to keep in mind that the main goal is to have the best decision for the best solution. Okay. Now I'm going to talk about an example. It's DAR. This is a CMMI process for CMMI Dev Level 3. Actually, this is what we do in second step. We are CMMI Level 3 certified company. So as a requirement for this level, we need, our decisions need to follow this process: decision, analysis, and resolution. Here I'm quoting from the handbook for the CMI. I'll go quickly through them. they say that the purpose of decision of DAR is to analyze possible decisions using formal evaluation process, okay, to evaluate identified alternatives against criteria. In another paragraph, it's a formal evaluation process that reduces the subjective nature. And this is important. We are going to talk about rationalism in our decisions. We want to reduce the subjective nature of a decision and provide higher probability of selecting solution that meets multiple demands of all the stakeholders. And the last thing to say, a recommended alternative is accompanied by documentation of selected methods, criteria, alternatives, and rationale for the recommendation. We're going to talk about methods, criteria, and alternatives in DAR. Okay, and documentation is also a crucial part for the CMI and for the whole decision-making process. And we will see that in every practice DAR mandates us to do, there is a sub-practice of documentation. Okay, and the documentation is distributed to all stakeholders. It provides a record of a formal evaluation process and rationale, which are useful to other projects that encounter a similar issue. Okay, as I said, CMMI has defined 6 practices. Under each practice, there is a set of sub-practices. We are going to quickly go through them. The first practice, establish and maintain guidelines to determine which issues are subject to a formal evaluation process. The formal evaluation process is the process that we are going to see in the next 5 practices. So before I start executing the next 5 practices, I need to determine if this decision is worth to consume part of my time, which is sometimes a big cost. Is it worth to consume that time for this decision? CMI says that we need to define criteria to take this decision specifically. So I need to define if, for example, I'm giving here examples, if this decision impacts medium to high on the final product, or if I'm going to purchase some third-party tool or library, I can define a threshold. For example, if it exceeds, if my decision requires me to buy an external tool which costs more than the defined threshold, then okay, I will go through the process. Otherwise, its cost is manageable, and we can just go buy it and use it if the cost is the main criteria in the definition. So this is the first practice. I need to define criteria based on which to go through the next 5 practices. The second practice here, establish and maintain criteria for evaluating alternatives and relative ranking of these criteria. Here I'm defining, now I decided that this decision needs to go through this whole process, okay? So I need to define based on what my decision will be. Examples given here are, for example, cost, performance, and customer environment. This is just illustrative. This does not reflect actually 1% of what we what we face in real life projects. But for illustrating purpose, I'm limiting this to these 3 criteria. This means that I will compare alternatives based on their cost, based on their performance, and based on their compatibility with the customer environment. Of course, criteria are much more. So I give their rank. For example, cost is 5. That means that the main thing that is going to affect my decision is the cost of using technology X, for example. Okay, so this coefficient, I'm going to use it in a simple calculation as given the example in a couple of slides later. I will use this rank to reach a final score for each solution, for each alternative I'm comparing. Okay, so ranks actually doesn't need to be numbers. They can be non-numeric, like high, medium, or low, or whatever weighting strategy you pick. Okay, now after I have defined my criteria, I need to identify alternative solutions. So that if I'm going to use, for example, message queue, I have RabbitMQ, Kafka, Redis, for example. I have many options in the market. So I need to perform the literature research to list all the options that I can pick from. I need to identify them and investigate to a certain depth, not only listing. I need to know pros and cons for every alternative. I need to understand what they provide, where they perform better, which one costs more, for example. Okay. Examples: third-party libraries and tools, technology alternatives available, outsourcing service providers. Also, sometimes some decisions is to do this module in-house, or to outsource it to external third-party service provider. Yeah, these are part of the decisions. So I need to investigate the alternatives I have. So now I have decided that this process needs to go through the whole practices. Then I have defined the criteria upon which a decision will be made. Third, I now know all the alternatives, and in acceptable depth, I have the knowledge in acceptable depth to make the comparisons. Now I need to define the methods. Define the methods means find out how to, what to run, what to do to reach, to know, for example, which message queue performance is better for my case, of course. Which, for example, which provider, which outsourcing provider costs less, for example. These are the methods. They include testing, modeling, and simulations, proof concepts. I may write my own proof concepts to reach these scores, to reach these comparisons, to know which is performing better. I can look for studies and surveys, what other people has said about, for example, Redis or TIBCO EMS or whatever options we have on the market. Cost studies and surveys. I can contact also providers. I can contact, get, for example, price quotes from outsourcing companies if this is the decision to take. Yeah, all these things are considered methods to perform on the alternatives I have listed to reach the criteria that meets the criteria and make the comparisons. Fifth practice is evaluate alternatives using established criteria and method. And this is describing itself, lots of sub-practices. But briefly, yeah, for example, if I have selected a proof concept as a method, I will run the proof concept connecting to all messaging queues I have selected and see which is performing better. Okay. Yeah, this is simple and straightforward. And the sixth practice is selecting the solution. And this is the sum of all the process that I have done. Here, for example, if I'm having 3 solutions, okay, and this is criteria 1, the cost, with its coefficient 5, performance coefficient 4, and customer environment compatibility with coefficient 2. For example, here I'm scoring solution 1 is the most costly solution. However, it's the best performance and is compatible, the most compatible one with the customer environment. However, making the total score, it's not the one that we have selected. We go to solution 2. It's the cheapest, performs well, and not that much compatible. It scores the most. Now, And sometimes this, for example, let's say for customer environment, the customer mandates to use solution 1. This will be a limitation, and this should not actually be part of a decision-making process. So this comes with the requirements, so we need to stick to it. However, if I have the option to use something that is less compatible in the customer environment, then I can go through this whole process. Now, I can tune these coefficients if things are different. However, in our criteria we have created here, criteria ranking, we have given the least important criteria as a customer environment. This is why the least compatible, the most compatible solution was not selected, because it's the least important criteria. Other scenarios, of course, will result in different results. This is just a brief and very small example about how we can follow procedure, rigid process actually, to follow to reach the most rational and the most the right decision. Let's say the right decision. In this case, I define solution 2 is the right decision. Solution 1, solution 3 are wrong decisions. Well, later some requirements may change, some new technologies might appear, some other factors might interfere. If there's a need for a change, this whole process needs to be modified, factors, ranks, coefficients needs to be reevaluated, and the decision can change. However, under the given requirements and the given situation, this is the decision. If we go briefly, we need to identify the criteria to define which decision to follow the process. Then I need to define the criteria. This is very important, and the most effective thing in our decision is to define criteria well. We define the alternatives, then we go to select the methods. And by the way, every step needs a bit of investigation. Sometimes if we want to go through that same example I'm using the message queue, I will think the first thing is just to make proof of concept. Sometimes it's not needed, and sometimes more than proof of concept is needed. I mean, as an advice, don't rush to what comes first in mind, because situations really differ. We will talk about psychological bias in our decisions, and even in deciding the evaluation method and the criteria also, this applies. Finally, we run the methods to reach the final score and make our decision. Okay, so now I'm going to talk about factors and the challenges, factors that are affecting us taking our decisions. I have grouped them in 3 big categories: psychology and the software development lifecycle factors, and the technology. Of course, factors are not limited to what I'm going to mention here, but actually I tried to pick the most important ones, things that are really relevant and faced a lot in my experience, and read about them a lot in the literature. So let's go see the first set of challenges. Well, psychological challenges, and this might look weird here in this discussion. However, it's very important really, because at the end of the day we are humans, we have psychology, and we are affected a lot by these factors. First, our decisions, we always claim that we follow rational thinking when we take a decision. However, this is not always the case. We fall into many traps, many psychological traps. The first one to mention is the bounded rationality, or sometimes they call it satisfying decision. Sometimes I think that I know enough about one of the technologies, so I start continuing my process and evaluation comparison based on the lack of knowledge. However, This is why I previously said that sometimes proof of concept might not be enough. Sometimes I need to do more research about the method. I need to do more research about the alternatives I have done. Sometimes my proof of concept does not reflect some capabilities in what I have selected as alternatives. So we don't want to fall into this trap. We fall to what is called law of least efforts. I think I know enough about all alternatives, so I start picking what I think to be the right decision. Yeah, so I need to be careful to do enough research. At the other end of the story comes that I don't want to waste all my time just researching message queues or cloud providers or whatever technology. I need to define certain level of depth I need to dig for. I need to define in more details what am I looking in message queues and what is eligible to my proof of concepts or not. The second trap in rational thinking is the intuitive or naturalistic nature of our decisions. This is to unconscious emotions, like choosing the favorite. Yeah, and by the way, I have started my career as C++ developer, so sometimes when it comes a project or some feature, I'd love to work it on C++, especially if it's a backend or service. However, the other way is not to do it on C++. This decision needs to be investigated more, needs to go that whole process of defining criteria, alternatives, methods, and running all these things to reach that thing. It's not only, okay, I may be familiar a lot with Redis, for example, and I like working with Redis when it comes a cache or a message queue. I may think of Redis. However, this should not be the case. I don't want to be intuitive in my decisions. I need to be rational. The second thing about psychological factors is the bias. Our decisions should not be biased towards anything. It should be factual, based on facts and based on tangible results. The first bias is the anchoring bias. This is the context bias. This be careful from the previous decision. Today we receive a project and we start working on we started to, for example, on a normal SQL database. Okay, a couple of years or months later, maybe we receive another project that directly our previous decision affects us in our current decision. So this we fall in it a lot, actually, and this is because we got our minds programmed to working with this DBMS, for example. Anything comes, we just apply it directly on that DBMS. However, each project, especially if they are separated projects, each project should be studied in a different context while not losing our experience, our older experience and decisions in previous projects. I'm not talking about big projects. Sometimes it's a feature that needs to take a decision about what technology or how to implement it on our project, for example. So this is about anchoring bias. The second bias, it's framing bias. This is related to the requirements. This is about how the requirements is formulated. Sometimes our decisions will differ a lot if the requirements is written in other words. So we don't want to fall into this trap. We need to know the details, the low-level details actually about the requirements. This is why we need to talk to our business analysts and sometimes most of the times maybe even, to the customer themselves to understand what they exactly want. Sometimes the customer cannot formulate it in the way that's clear enough. And this is actually part of the architect, is to bridge the gap, these sort of gaps, actually, not only one gap. We need to bridge the gaps between the business context and the technical contexts. So this is a framing bias. The last bias I'll talk about is confirmation bias. I will give an example to illustrate this. Sometimes I have chosen a method of proof concept, for example, and in my proof concept I have connected my code to pull messages from Redis, for example. Now, when I want to run my method on another alternative, okay, I still have my code tailored a bit to Redis. Sometimes I didn't have queue agnostic code, so that I didn't utilize all the features. For example, for Kafka, for example, sometimes I didn't utilize some features that may result in better results for Kafka than Redis. My code is tailored towards confirming that Redis is the best. And this happens actually, so I need to be careful about this. Another psychological factor is the first choice. I think I mentioned it before. Yeah, the first thing in my mind, I just stick to it. I may fall, after I choose this, I may fall in confirmation bias when comparing it to others. I may fall in multiple psychological traps without being aware of them. So we need to be careful about all these things. The other thing is group thinking. In many situations, we have meetings to discuss alternatives and our results. Yeah, and in these discussions, group thinking is something good and important to share knowledge and share experiences, and help also in making the decision. In group thinking, people desire for harmony and minimize conflict. However, we don't want this to affect us to fall into Abelian paradox. They call it Abelian paradox. People do not object to the mistaken belief that their own preferences are counter to others. This is, for example, another peer architect suggests a solution. I don't object on his solution, even if my objection is valid and right, but due to the belief that I don't want to break that group thinking, the harmony, I just don't object. Or if I object, that architect does not defend, does not discuss, just not to break the harmony and the group thinking idea. So we need to be objective in our discussions, in our group thinking sessions, in our brainstorming, in our sharing the knowledge. Okay, factors that are related to SDLC in big categories: management, requirements, and teams. Well, I'll go through. I think I'm running out of time maybe, but I will do my best to do it quickly. Management, sometimes the culture, technology affects our decisions. Sometimes we come to a place where they're already using certain technologies and it's working, so there will be a huge resistance to change. So this affects our decisions. Sometimes we're limited to this technology, and sometimes even taking the decisions to change this technology is a challenge itself. Internal policies, third-party constraint, budget constraints, methodologies, and agility. If we are talking about, for example, if we are using Scrum as an agile methodology, or we are working on waterfall, we need to take care of these methodologies in our decision and in the process that we are taking our decisions. Yeah, they affect, especially when we talk about, if we are talking about Scrum, for example, continuous meetings with all stakeholders, they will affect us. They will our decisions will be evolving throughout this process. Time constraints also affect. Sometimes we don't have time to do the full evaluation process for the alternatives. So sometimes we decide, we make our decision based on which is faster to market, for example. The requirements themselves, I have mentioned them in the previous framing bias, sorry. So what is required itself is one of the main factors in our decisions, of course. Some requirements come with shipped with that we want, for example, AWS deployment cloud. Okay, so we are limited to it. How accurate the requirements that we receive? Do we need to do more illustration sessions with the customer or the business people to understand the requirements? Or these things affect us a lot. The size of what is required, how big our product is going to be, the number of users also affects our decisions. Teams, I have divided teams into two categories: architecture team, if we are talking about a big company with an architect's team, and operational teams. Now, we as architects need to be always prepared for arguments. We need to always prepare for objective and subjective arguments from peer architects, from those people who want really to show you that you are wrong, but you need to be backed up with rigid argument to prove your decision to be correct. If it's correct, if you are convinced, if he has a more powerful argument, then you need to admit, and so in an objective manner, we need to put aside all the personal issues aside. However, this is met a lot, unfortunately. Now, the same thing needs or is faced also with the development team. And it might be faced with other teams. And we need to put in mind the size of the development team, the testing team, technical support, deployment, implementation teams. All these things need to be considered in our decision. I don't want to select a technology where I don't have anyone in the development has an experience in, or I need to consider this in my decision and put it as a criteria in the evaluation. Well, if it's the best ever performing queue, for example, that's fine. We will have a couple of guys in development who are going to take training and then choose this queue, for example. All these things. Also resistance to change, and this happens a lot, especially when we are talking about a place where everybody works in Java, for example, and we need to do something in .NET or maybe in some other language. Lots of people might be resistant to change, and they will start giving excuses, logical and non-logical. You need to be prepared for these discussions. Okay, the last category of the factors that affect us in our decisions is the technology. First, knowing the theory and history behind the technology, and this is very important. I give the example here as NoSQL. If we know the history or why the NoSQL has been invented and evolved and becoming one of the main used things, and it will help us a lot in deciding whether I want to go to NoSQL or no, I don't want NoSQL. I will stay with SQL Server or whatever DBMS. These are challenges actually, because I need to know lots of things. Even if I decide to go NoSQL, I need to know which NoSQL engine I'm going to use. well, Mongo gives something different than Redis, will give different than Cassandra, will give different criteria I need to consider when choosing a technology, and I need to be aware of the lots of options we have. And this leads to the second point, lots of technological options, and this is another challenge indeed. I need to have a very wide knowledge with acceptable or needed level of depth in each, okay, to be able to do the comparisons, to be able to do to make the right decision. This is a real challenge. However, in some other times, the lack of options is the challenge. If we are talking about NLP in a specific field, and this is one of the cases that we have faced recently here, in the medical field, we are trying to have some NLP services to automate things in the system. However, we didn't find. We have started to investigate the cost and the requirements. Yes, I'm sorry. This is the last slide I'm going to talk about. I'm very sorry. Yeah. So the lack of technologies in some areas are the challenge. Sometimes we run into a situation of obsolete technologies, and we need to consider them in our decisions. And some other certain concerns like license and cost affect our decisions also. Finally, I want to say that technology trends are not always the best solutions. Nowadays, we hear a lot about microservices. Well, sometimes many people are thinking of monolithic solution is a bad solution. It's not mandatory. I'm not defending monolithic, nor am I defending microservices or attacking any architecture. But if a monolithic system is well, its architecture is built well and studied well, and there's no need for microservices, there's always a burden and extra effort needed to implement microservices. If not needed, the monolithic might be the right solution. So technology trends are not always the best solution. Examples, I've given some of the examples. However, we can, examples are actually a lot. We don't want to open this door further. I'm very sorry for taking too much time. And yeah, I'm done. Thank you very much. Thank you, Gaëtan.
Yeah, no problem. it's fine. It was very interesting. Yeah. So now it's going to be time for. We lost. Piotr was there, but he's gone now. Maybe. No, he's here. I just couldn't see him. Sorry, Piotr. So right now, I'm just gonna step back. I don't know if I can step back and still talk, but yeah, let's just check. Can you still hear me?
Yep.
No, you can't hear me. Yeah, you can. Okay. Okay. So we got a few questions for architecture in general and documentation. And I'm starting to think about DDT now as decision-driven architecture, not domain-driven architecture.
Yeah, maybe. Decision-driven, it is.
Yeah, that's quite a nice thought. So as for the questions, I prepared some that I've seen. Well, let me choose. Yeah, I have this question for all of you, and anyone can answer. Well, you all seem to have been working in large teams, but when the team is really restrained, how do you maintain that in really small? Well, because Piotr talked a lot about cloud deployed documentation and in large teams, and Dima is working with a few hundreds of people, and same for Mahmoud. So how do you recommend not to do too much overhead for a small team?
Maintain documentation, small team. Well, I think the same ideas apply, but in a smaller scale. I'm not sure if there is, let me say, if there is certain, managing the documentation. Actually, managing anything when the team becomes larger, managing anything in it is the headache. Will add headache and costs in terms of time, in terms of sometimes we need more tools or whatever. However, in small teams, the same principles I think may apply. In smaller scale, maybe the tool is not needed to a smaller license, or an open source tool might be used, or this sort of thing. I'm not sure. Maybe Dima or
Piotr?
I can share more thoughts about it.
So I've been managing both smaller teams and bigger teams of developers, and I feel that, you know, if you have a smaller, or at least if you start with smaller team, there tends to be more focus on automation. So smaller teams do not over-engineer, do not invent roles, you know, between each other, but they really have to be efficient. So they focus on automation. A good example of this are SRE teams, which really are, you know, very often small, and they are dealing with extremely high scale throughput. So I tend always to start having team topologies, if I can influence those things in an organization, to really start with many smaller teams rather than single large team. It's just fosters innovation and automation, in my opinion.
I totally agree. So we currently starting some, proof of concepts, and it is a few team members, and we defined Plant.UML as a tool for automation and creation documentation. So, and the concepts, how we actually create the architecture decisions, how we visualize them, the same on a smaller size or bigger size, but the automation tools and management of the documents and diagrams and decisions, I believe in really in automation, and Piotr already told about this. So really thank you for your presentation. I guess if many people review this, and probably we will, improve documentation in a lot of projects. So it's a really great tool where your documentation and your source code manage it together. We can review it like a code review. We can build this documentation like in CI/CD, like we do with source code. So it's a really great approach, I think.
Thank you.
Okay, I have another question about decision, actually. What are the most important decisions which cost a lot of change if they occur later in the process?
Well, yeah, as a rule of thumb, let's say the earliest decisions cost always the most. Okay, so my first decisions, my early decisions, I need to study them very well before I continue. And moreover, my next decisions will depend also on my first decisions. So this is one of the ideas that I can answer with. Thank you, Dima. Also, business-related decisions, which might result in different business that what's required from the customer, also sometimes will cost the whole deal, because the whole project, if I'm doing something that's the customer's not requesting. So this is very important also to consider. This is what's in my mind now, but it's a really important question. Thanks for whoever asked it.
Any other thoughts?
From my practice, Mahmoud, you're right. So the early decisions, like what the architecture style I should choose. For example, I define it monolith, and when I build the huge project based on monolith, even very well decompose it logically inside, right? In future, to, for example, introduce service-oriented architecture, will be a really challengeable task.
Disaster, yeah.
Yeah. So that's why these early decisions probably the most important, and changes in these decisions will be really expensive
Yes,
in the
indeed.
future.
Yes, indeed.
So I absolutely agree. It's a critical subject for software system enterprise architecture on all the levels. And I feel that there is a lot to be said about deferring architectural decisions. So this is a decision in and of itself, how much I can defer a decision, especially fundamental decision that is going to be foundational building block of the rest of my system. And that's why architecting around change is so critical.
Yeah.
So thinking correctly about what my system in future, how could look like, what changes can be there, and then making these decisions, changeable or exchangeable. That's absolutely critical. And I feel that that's really the core of architecting well. System is like a wine. The older it gets, the nicer it should be, and not the other way around. So absolutely critical point.
Absolutely.
Yeah,
Good
I
comparison.
totally agree with that. Yeah. I have another question, but I think Piotr is quite like. No, that's not the one. Sorry. I think actually this question is really up to what Piotr explained, like to maintain the documentation up to date, is to make it as proximate with the development, and make it versionable, and make it really reusable, and like anybody can access it anytime, and really use standards. Oh, I'm sorry, I'm answering the question for you guys, but
You're doing great. You're doing great. That's exactly it.
but that's my thought. I'm
Yes,
pretty.
yes,
That's what I get from your presentation.
yes. Yeah, I think Dima summed it up really well, right? You have your documentation in your source code repository. You manage artifacts of your documentation in the same way, with the same process as you normally would managing your source code, and it becomes intertwined with your development workflow. That's kind of the critical part. And then overlay on top of it high degree of automation, open standards, and then you find yourself in a position where you can, do it on a daily basis without a burden. And then if somebody takes it over, hey, those are open standards, and I've created an automated pipelines for you. You can reuse those things. Absolutely, that's a very good summary from your part. Thank you.
Yeah, thank you, Dima. Thank you, Piotr. Any thought on that, Mahmoud?
Yes.
No. Okay. Yes, you have, but you, yeah. Okay, another question. Maybe a more general question about architecture. How do you measure the effectiveness of architecture for business process? This is not really related to documentation, but I guess it's part of your jobs too, and mine, actually. Well, the first one say hello.
So maybe I can start, since
Yeah.
I was asked. So this is a really important and also complicated topic. So since architecture decisions are actually underpinning everything that the software will become in the future, its usability, security, all the ilities, right? I feel that measurement of the application of the architecture success is critical to build from the beginning within the application. So some of the measurements is, for example, adoption rate. If we architect something for all the products within an organization, and we have certain adopters coming and actually implementing those architectural guidelines within their product, that's one important KPI to keep track of. Another KPI that I really like personally, it's actually aligns with the State of DevOps report that says that in order to provide a correct architecture, you have to have strong foundations, and those foundations can also be automated in form of platform level services. So architecture, in and of itself, it's very creative endeavor, but it's also very prescriptive. So how do I ensure that architecture is being followed? Well, I don't want to enforce anything, but also I cannot really know whether people are following my stuff. So having services that developers can use within their development workflow and utilize those services like platform layer services in terms of deployment infrastructure, where those services follow the architectural guidelines and kind of almost create those guardrails that are physical guardrails for a development organization. That's the measurement way of doing those things. How are those low-level services utilized? Whether my platform layer is actually ingrained within the development workflow? Does it bring the expected benefits? Is the workflow easier? Are the deployments more often? Is there less mistakes per each deployment, and so on and so forth? So I feel that, looking at it holistically and trying to measure from the top down on the customer experience, backtracking to the low-level foundational services is something we don't do enough, and this is definitely important.
Yeah, I agree, and I'm pretty sure everybody agrees with that.
Yeah.
It's I have another question, but we still have only 1 minute, and I'm not sure if we're gonna, because like one or two advice you can give to. Oh, sorry, I didn't show the advice. A growing team based on microservices and micro front-end architecture in terms of spreading knowledge and documentation, I guess, by documentation. Well, this is that we have 1 minute to answer this question. It's really hard.
From my perspective, start from DDD, domain-driven design, and event storming. So this is the initial stuff for any microservice or micro front-end architecture. That's from my side.
Okay, that's a nice and concise answer. If anybody has to add something, otherwise, I think I may have to pass the relay to somebody else of the Geekle team, but I don't see anybody coming. So maybe we can continue the discussion. Actually, because they're supposed to take relay after me. I'm not sure what's on the agenda, actually.
Yeah, you still have 10 more minutes because our break is in 10 minutes. So you still have 10 minutes for questions, so go for it.
We still have 5 minutes. Okay. Okay, so I will pick another question. Okay. Yeah, another question, like anybody could answer. What are your daily main activities as an architect? I guess it depends on each of you. I mean, maybe they probably have some same kind of duties, but in general, it depends on teams and the sector and the area of work.
Well, yeah, it may include everything. Yeah, from meetings, from writing code, from research, from main activities for an architect. Sometimes you consider everything. So you need, sometimes you write the business code itself that will be deployed and running. Sometimes you just leave it in a proof of concept and deliver the results to the team to implement. Meetings, as I said, with customers, internal meetings, external meetings, research, anything that comes to your mind in a software development company, an architect will be involved in a daily, as a daily activity, I mean. Yeah.
So I really like a book from George Hope, the architect elevator. So it's a metaphor of driving the elevator from the penthouse where the CEOs are located down to engineering room. So I find myself doing this mostly, really trying to connect those two distinct realities and making sure that there is a cohesive set of goals being propagated down to engineers and feedback from engineers correctly being propagated up. So this is definitely a lot of time spent on meetings. I mean, that's the reality of an architect work. But I personally work a lot with cloud native ecosystem and things like Kubernetes. So I'm helping teams setting up Kubernetes clusters. I also do a lot with DevOps. So my role is kind of mixed a little bit. So I would, educate teams around DevOps. I would evangelize around cloud like Azure, AWS, GCP. Do a lot of lunch and learn sessions, trainings, and stuff like that. So between those activities, there is some time for coding and some time for creating diagrams with Plant2ML. So that's kind of my
You
day-to-day.
really like Plant2ML.
That's for sure. I think it's obvious from my presentation.
Yeah.
Yeah, a lot of meetings. I'm totally agree with architecture elevator. So it's a great concept and great book, and I really recommend to read it. And the integration patterns, the same author, so it's a great book as well. And a lot of trainings I perform actually and teach young architects inside the company, and a lot of besides meetings, of course, and some documentation stuff, and a lot of PFCs and a lot of learning. So proof of concept, it's my daily work. So I'm research something new and trying to actually scale it in production in future. So something like that. Yeah.
Okay. And just one last question: will you make your slides available for everybody after this meeting? Because people are asking for the slides and stuff. It's nothing to hide, right? Or you have to keep them. Okay. Well, I let the Geekle team handle that.
So from my side, I actually have this topic as part of my Medium blogs. You can just search for how to create and maintain good software documentation. I have this in the form of a blog where you can basically follow the same content. They don't have these cool slides with the bullet points as pictures, but the content is there.
Yeah. Okay, thank you. I will let I think we can close on that. Anna, what do you think? Okay.
Yes, I think that it was quite interesting discussion, and I was so grateful that all of you joined us. So now we'll have short break, I think like mostly 10 minutes, and then we're glad to see next speakers on the stage.
Yeah, I just want to say thank you to you guys. It was really informative and learned a lot.
Thank you very much.
Yeah, have a good end of the day, and let's see each other.
Thank you for having us.
Thank you guys. Have a nice day and conference. Bye bye.
Bye.
Bye. Thanks. Bye.
And also want to say thank you for moderating. You know, I just had my Flutter Global Summit, and I can compare that you did amazing job. So thank you for joining us. Thank you for being with us. And it's time for a short break.
Yeah, thank you. See you later.
See you.
All right, folks, I want to remind you that we have prepared 5 workshops by industry-leading experts. You can learn how to modernize Java applications using AI, go deeper into monorepo and micro front-end architecture, and get tips to start using gRPC Web today. Besides, you can develop a concrete roadmap to become a solution architect or start creating an architecture cheat sheet. Check out our webpage to find the best option for you and your team.
Hi, everyone, and welcome to our second block of talks. My name is Paul, and I am sponsorship and partnership manager here at Geekle. And I want to say thank you, just to give a big shout out to our sponsor, Enoch. So they're sponsoring this event, and I just want to say a couple words about them, what they do, and what kind of amazing services they provide. So basically, what they do, they are an IT consultancy, and for more than 20 years, as far as I remember, what they do, they consulting big SMEs and corporations, and what they do, they're helping you to actually realize your IT systems to starting with backend and with the practical experience in software architecture and development and digital platforms and infrastructures. So the whole product development cycle, you can actually get consultancy from them for that. And for them, technology has no self-purpose, and the technology is just the task that needs to be solved. It's just solving problems, and they're really good at this. And today we will have CEO of this company, Stefan, with us, and he will be speaking at our senior track, at our pro track, and we will hear from him about very exciting topic as far as I consider it. Is his topic is going to be good enough architecture. So he will be telling us about what he thinks is a good enough architecture, how to identify the architecture that is actually reliable and which is worth of being called an actual architecture. And I would like to introduce our next moderator, Largo. Let me wait for him to turn on his camera and to join us. And he will be joining us, I believe, in a minute or so.
Yeah,
he
just was a speaker.
Yay. Okay. Hi, Largo.
Hi, Paul.
Nice to have you
How
with
are
us.
you?
Doing great. Okay. Excited to have you with us. So
Yes,
I guess without any further ado, I'm just gonna pass the mic to you, and you will introduce our next speaker, Adrien, and
yes.
we will continue. We will roll with the next block. Okay.
Okay.
See you later today.
Okay. See you later. So hi everyone. I'm Largo Walid from PowerM. I'm Solution Architect, and I will be the moderator for this use case block. So we are excited to have today with us two speakers in this block, which are both from France. We will be starting with Adrien, which is a solution architect and passionate about robotics. So you can ask your questions, and he will be glad to answer them. So just to let you know the setup, so we'll have 2 sessions, and then we will have a Q&A session to answer your questions, but you can ask them as long as the presentation is running, and we'll get to answer them at the end. So let me bring Adrien with us. Hi,
Hello,
Adrien.
everyone. Hello, Walid.
Hi, how are you?
I'm fine, and
Great.
you?
Great.
Yeah.
So,
how did you feel to present 2 French people? How did you feel?
That was a nice coincidence to
Yeah.
to have both of you at the same block. So
yeah, that's true.
So I think you can try to share your presentation.
Yeah, of course. I will do it. And let's begin if you want me.
Yes. Okay, great.
Perfect. So hello everyone, and thanks to come to this talk about the journey to bring gRPC to a production-ready microservices architecture. So before talking about that, let me introduce myself. So I am Adrien. My name is Adrien Montagu. I am from France, and I work at Socotec.io, that is the innovation team of the French group Socotec. I am working with Vue, Python, and now gRPC. I am not an expert in gRPC, but I will try today to share my experiences with a migration from REST to gRPC. So what are we gonna to talk today? First, I will try to explain to everybody what is gRPC. I will not going into the details because there is a lot of better resources than me to talk about that, because I am not an expert on this technology in particular. But I will try to put the word, to put some word and some schema on it to help everybody to be on the same level of information and to understand everything on the talk. After, I will talk from where we start in Socotec.io, so why we choose gRPC, how we did, so how we successfully integrate it with what we know. We will see after what that means, but it's important when you change the technology to not change all your stack and all your way to do things. Then we will talk about how we improve this this integration with automated tools and everything and other things like that. And first, I will talk a little bit about what my team and I learned along the journey. So, first of all, what is gRPC? gRPC is a project launched in March 2015 at Google. The main goal was to rebuild their internet tools that connect their large number of microservices. So, okay, we mean Google, so we mean like thousands and thousands of microservices with a big performance impact. So they add another tools before that was making RPC call, and they decide with the arrive of HTTP2 to rebuild it with the standard of HTTP2 and make it open source to allow developer and architect like us and like me to use it for their architecture. It means Google Remote Procedure Call, as you can figure out, and Remote Procedure Call allow a client to execute function code in server. So actually, you call a function in your client, and the code will be executed in your server, and the return data will be sent back to the client. So it's a common way. Actually, REST is a RPC. It's a common way to make a communication between a client and a server and to exchange data. So what's new with gRPC is that the communication is over HTTP2. The serialization is using protocol buffer, and you can call the procedure in any language that is supported by Google, or you can develop your own, of course, but actually Google support like 10 language out of the box, so we will see that after. But you can see on the schema that, for example, a Ruby client can call a C++ server, and they exchange proto request and proto response that are binary serialized, so with a low bandwidth and really fast communication protocol in any language that you want. So this is the first part of the introduction. I will not go into the details about what is gRPC and how it works. You actually have a talk tomorrow about HTTP 2 and gRPC. So I think it will be more a dive out. But just remember that we are talking about microservice tools to communicate between your different microservices, or between your browser and your server. So, and it's full new of latest tools and latest technology and performance, best performance tools. Now, where we start, why we choose gRPC. First of all, we can do binary call, streaming call, both side, and bidirectional streaming call, all in one technology. I mean, like, it's like WebSocket, but you can, if you want, do only binary call. So it's the next step. I mean, there was REST, which was only which was where it was only binary call. Then it was WebSocket, where it was only streaming exchange. And now you can do what you want when you want. So it's the next step, and it's really appreciated. I mean, bidirectional streaming. That means no more pooling, no more streaming server technology aside your REST framework, and no more, I don't know how many tools you can use to learn and use in a scalable stack. So you can use only one, and it's really fast to use. I think if we would choose gRPC at our scale, it was mostly because of that, because it's the next step, is the next logical step in the API architecture and design. Now it has only fast serialization and low bandwidth consumption with protocol buffer. Protocol buffer is also made by Google. It was in the early 2000, I think, and it's transformed protobuf files you can see on the right in client in 10 different languages that serialize and deserialize the data in the best way actually on the market you can find. For example, at Socotec.io, we had a big request that was a little bit slow, like 3 seconds to make, and by just by using gRPC and protocol buffer, we won 30% on the 4 megabit request. So it's kind of a lot. It makes us save like 1 second of load in our web app. So it was another choice, of course, of why choosing gRPC. The last one is a lot of tooling to automate process. Actually, as a software architect, I love automating things for my teams and my developers, so they don't have to make mistake, learn the hard way, and lose time on small error that can be avoided by just automating everything. So I really love the gRPC logic where there is tool for almost everything, and if there is not, you can make it really simply with that. So let's see to awesome gRPC and see all the tools and the things you can do. It's almost like OpenAPI, but it's natively in gRPC. It's not like you can use REST without OpenAPI specification. It's like when you use gRPC, you can use this tool directly without any work. So it's really nice, and there is a lot of tools for that. As I said before, it's a multilingual technology. So actually, at my team, we only use Python and JavaScript for the browser, of course. But it's we don't know. Maybe tomorrow we will be supporting PHP or C# code as Socotec, my company, has like 250 different projects inside it. So it was important that any project that wanted to try new things, connect to our microservice architecture, will be able to really easily. So using gRPC allow us to be sure of that and to grow up and to help all the group grow up with the innovation team. So now, why not choosing gRPC? So of course, this slide is very small because it's a great framework, but you have to remember that binary serialization make it harder to debug. I mean, you didn't have in your console the data directly. You have to fetch it, deserialize it, and then print it. So it's manually logging and not automatic with tools. Except if you use Wireshark, but you need to know how to use it, of course. And there is less resources and support. That's true. It's because it's really new. It's a little bit complicated. So actually, people that do that, that use gRPC and already deploy it in production, are mostly architects that can find solution by themselves. So actually, if you are an architect, it's kind of easy. But if you are like a junior and want to learn, go learn it. But maybe don't use it in your next freelance project or something like that. If using gRPC Web, I will not talk a lot about gRPC Web. It's just a technology beside gRPC that allow you to use gRPC call inside your browser. Okay, it's really nice because you have only one technology everywhere, but it makes your framework more complex as it needs two entities to work, one directly with the gRPC server and one with the proxy running. And if you are messy with the data you return and you like that, you will not like gRPC because I didn't say that before, but protocol buffer are strongly typed message. So you need to know what you send and in which call you send it. So you can just say, oh, okay, I will just remove this field and or rename this field this time and other things like that. You will have to think about the data you return. Think about what you will return like data in 2 years, and it's really important that you are really strict on the data formats you exchange between your services. So if you like sending everything in any way, it will not be for you. So now let's deep in how we did. So this is, I think, the most valuable part of this talk because we really wanted to integrate gRPC, but we are a small team, so we are like 10 developers, and it was impossible for us to rebuild every framework, every library, everything that we use, and we use a lot of tools in our architecture. So the first thing I want to share is gRPC is just a communication protocol. It's not a MVC pattern. So if all your team already use a MVC pattern, like Spring Boot, Django for Python, Symfony, Laravel, or anything like that, just make sure that what learn your team, they can reuse it with gRPC. So build tools that allow developers to use gRPC without understanding that it's not no more REST, but is gRPC. I will show you an example of how we integrate it at Socotec.io. So we use Django. Django is the most popular web framework for Python. And Django REST framework is a framework on top of Django that is more used for the REST framework. And Django Sokayo gRPC is a fork of Django gRPC framework that is a proof of concept open source on how to reformat Django REST framework with gRPC. And we add all the features that was missing, like pagination, filtering, automatic generation files, and other things like that. So it's just a proof of concept we found on internet that we loved and that we improve for our need and for the production with the architecture that we was building. So now, this is the two next slide are how we declare a CRUD in Django REST framework. So we have a model that is a class, it's like a snippet. We have a serializer, and for example, and other attributes like permission or filter or search field and other things like that that allow us to control our CRUD. And for that, for everything working and correctly create a CRUD with a post, a retrieve, an update, a delete, and a create, we just have to inherit from a class that is model view set. Okay? And our serializer just need to inherit from model serializer that take a model. Like I said before, it's just a class with attribute and field that are in the model to understand what kind of type use. Like ID is an integer and name is a sharp field. So this is how we declare a CRUD in Django REST framework. So let's see how we declare a CRUD in gRPC with Django Sokayo gRPC. It's actually the same. The only thing we change is the inherit class, where we use an async model services instead of a model view set. And in the serializer, we change the inherit class, and we add two attributes in the meta class that are the Python object to serialize and deserialize, because as you know, we use protocol buffer for that, so the data need to be correctly formatted. And just by doing that, we are doing CRUD like Django REST, but with gRPC. And our developer didn't have to learn a new framework and other things like that. Actually, it's pretty easy in Python because the logic of the language is to inherit and override. So it was relatively easy to do that. But I think the logic of raising it and make it compatible and adapt gRPC to what you know is really an important concept if you want to bring and to use gRPC in your architecture without losing a lot of time. Now, you also have to support REST library that use request object, because you will not code and record everything in your framework. You didn't have time for that, except if you are Google or a really big company with a lot of budget. But there is a lot of open source library that are really nice, really good, and that are already maintained. So just make the gRPC request compatible with an old HTTP request with a proxy pattern. That's what we do. We just intercept the gRPC request, make some interception on it with a proxy pattern, and if someone wants an old attribute, we just pass the gRPC request and give it the data he wants without letting him know that he is using a gRPC request instead of an HTTP and a REST request. So I think this is one of the best thing I can bring you if you want to use gRPC, because it's really help us and allow us to use gRPC without an already full functional framework. So now let's talk about how we improve by building automatic tools. Like I said at the start of the presentation, I love building automatic tools because it works really nice. And as an software architect, I didn't pass a lot of time following bug and helping teams, but a lot of time coding and scripting. So it's the best thing for in my point of view. First of all, what we did and what we improved is to generate our protofiles from our service and serializer. Like you see before, we inherit from class, and our serializer has in its attribute all the field, all the information about the field in it. So from it, you should be able to generate your protofile. So we just create a command. So manage.py, it's a Django command specific. So don't bother you with that if you didn't know Django. But the main idea is just to create a command, generate proto. We pass an app at this command, and it will generate directly this protobuf. So if we go back and we see these services and this serializer, it will automatically, with this command, generate this protofile. So like this, a developer cannot make mistake, and if they add a field or anything, it will be opened directly in the protofiles, and you as a team leader or an architect, you will not have at each bug verify manually to each field to be sure it didn't forget something or miss something, and you didn't have to deep in the learning process because it's all generated automatically. The other thing we automated is to use the CI to be sure that the protofile the developer push is up to date. Why? Because like you now that everything is generated, the developer can just change his services without thinking about updating his protofile. So be sure to, so now with this in the CI, we are sure that the protofile that he is working on and he want to merge and master is matching with his services or its serializer. Another thing we do that is, I think, really important to not lose time in debug and in refactoring things is to create an automated flow to deploy an API with all our generated clients and automatically set all the URL of our microservices. I will explain that after I will finish the 3 point. So after that, we can also automatically check for breaking change in your API versioning, because there is tool that allow you with the protofiles to know if your API has breaking change or not, and automatically deploy the documentation of your API. Imagine you generate your protofile automatically. You check in the CI that these protofiles always match your services and your serializer, and then you synchronize all these protofiles that you are sure that are correct into a single web API, versioning API, that can be installed in every microservices with a specific version and with all the broken change listed and understood by every developer. So what it look like in the schema, because we are architects in an architecture summit. So let's show some schema. Here we can see that a flow of how the automating deployment of API. So first of all, let's imagine we are on one of our microservices, and we push on master or create to tag, depend of your Git flow. Now, you inside the CI, after your test and everything you done usually, you clone the API, your API repository, and copy the proto files you have inside your microservice to the API. Now you check if the proto files change. If the proto file change, you generate a multi-language client file, because you can have a client in Python, Ruby, anything. So you decide which kind of library you want to support. Then you check if the URL of your microservices change, because as we said earlier, you will have some difficulty to maintain all the URL of all your microservices, except if you use API Gateway, of course, and you should use API Gateway. But even in local, if you have a lot of microservices and doesn't want to bother with a local proxy, you can automatize all the URL and just pass in your API, like if you are in your local environment, your development environment, your staging, or your production, and the API will automatically connect to the correct URL because of that process. So if there is a field change or an URL change, we change the URL of the microservice encoding file. We generate auto import in your API entry point. That means, like we generate, for example, Python file, we have to import it into another Python file. We have to automatically generate at least one Python file that can be imported in your API entry point and be used after that. We check for the breaking change and find the correct new version. For example, if we are in version 1 and we see a broken change, we go in version 2, or we can block all the process and say, no, you have broken change, don't do that. It depends of what you want to do with that. We update the changelog because of the tools, of the proto tools, we can know exactly what changed inside the proto files, so inside our API. So we can automatically, when we publish a new version of our API, put every information inside the changelog. So when a developer come into a project, see we was in version 2 of the API and knows there is the version 4, he can check the broken change and see if the broken change concern this microservice or not, to be able to update it really easily without losing a trace or maybe miss a developer comment, because sometimes developer forget to update the changelog, and this can create a lot of problems. Then we push to the API repository with the correct semantic release commit message. And at this point, this is the CI of your API repository that will just deploy a new version of the API and deploy new version of the documentation. Actually, all this process is made in Socotec.io, and we are publishing in a library, a Python library and an NPM library because of this process. And this is saving a lot of time for us, because we don't have to copy the generated files in all our microservices. We don't have to put all the environment variables in all our microservice architecture, and we didn't have to handle the conflict where there is a rebase and two developers change the generated files in the same time. Other input about building automating tools, it's create a microservice templating to reuse, like cookie cutter or something like that. So your developer doesn't make mistake by copy pasting, and use Kubernetes or similar field declarative infrastructure to allow you to find the data about your deployment in the CI. So actually at Socotec.io, all the data needed by Kubernetes to deploy are directly in the µServices repository to allow us to automatize everything and to deploy it directly in the CI. Last part, what we learn in the journey. First of all, what we learn about gRPC is do not manually work with protobuf. I mean, you can do it, of course, and a lot of people do, and it works really great. But in a µServices architecture, it can be really hard, especially if you have nested data or you want to flight nested data. So it can be a little bit long and boring to like changing the protobus files, generate the client, test it, and doing it again and again. So just code like you do usually and generate all the protobuf logic and enjoy the speed and the low bandwidth consumption of protobuf without its inconvenience. Build and use complex message is not that easy. So it's what I was saying in the do not work manually with protobuf. gRPC web syntax look more like Java than JavaScript. That's something we learned. I am not criticizing it because gRPC web is a wonderful project, but the syntax in JavaScript is a little bit weird, and it's really like if you want to assign some data in a request, it's like one line per data, so it's a little bit how can I say that? It's a lot of verbosity. Yes, it makes your files look bigger than expected in traditional JavaScript. Use versioning for the generated client, because if you didn't do that, your developer will go back to a microservice like 1 month or 2 months after another one finish it, and it will be impossible for it to know which code is using, which call of the server is using. So it will be really hard for him to update it without knowing what needs to be done. And the last one is use async logic. Async logic is possible with gRPC, like we see, because we use streaming and other things like that. Actually, it's native in some language like Node.js, because it's built like that. But in Python, you have the support for both. You have the support for synchronous and asynchronous. And if I have an advice, is use asynchronous because it's more faster, and you can do a lot of more with streaming. What I can say is that we started with synchronous logic until we had to use streaming. And when we use streaming, we had to rebuild everything. So use async logic directly, because streaming is one of the best features of gRPC. So be careful with that. Don't go with the simply code first and really go deep into async logic. Even if you didn't know async IO, for example, in Python, use it. Now, what we learn about team learning. It's more like not specific to gRPC, but I wanted to share it. It's like go progressively because it's a new technology. So go first as an architect or team leader. Test everything. Put fully functional example code first. And when I mean fully functional, it's not like do a simple code. It's more like testing nested data, array in object and other things like that, to provide example to your team. Create recording meeting to explain all the choice you made. For example, we use a custom framework. So when someone arrives, it's not like you already use it. So even if all the logic is similar, so actually in 1 hour they can use it, we at least need to explain the choice, as I did with you before, to help him understand what changed and how it works. And record it, because you will not spend like 1 hour every time, and just record it and share it with all your team. And the last is prepare your monitoring and logging to have them debug in deployment stage. And this is more about the microservices architecture than other thing. Passing from one monolith to a microservice architecture, you need a good monitoring and a good logging to help them debug, because if not, it will be like impossible bug to find, and a lot of time lost with that. And the last one is the deployment phase. So gRPC is relatively new, so there is maybe not tool like HSGI or WSGI. It's Python example. Okay, so for you maybe have specific server that only work in production and not in local. So be sure that what you use actually to scale and to accept a lot of incoming requests work with gRPC, or are not an issue with gRPC, because if not, you will lost a lot of time for something you can't deploy. If you have automatic HTTP1 back office and you use gRPC web, as we do at Socotec.io, because Django has an awesome Django admin tools, you will have to deploy 3 instances per microservice, one for the traditional Django, one for the gRPC web, that is a proxy, and one for the actual gRPC server. So you have to think about that, to think about what you want, and if it's okay in your architecture, and if you can support the cost of that. Use Kubernetes, of course, especially if you use all the points I said before, because you will need it to deploy and to grow, and to, for example, we have 3 instances per microservice, but we want to scale only the gRPC one. So Kubernetes really allows us to do that without deploying the same code again and again, but just what we want. Be careful about the secure and insecure channel that work differently in your local environment and your production environment. So my advice is to centralize everything in the API you build automatically. Of course, you will remember. But if you didn't do an automatic API, be careful of that, and put code tools for your developer. And the last one, that is the more logical, but really do not waste the last week of your deployment to test the deploy process, because it's new, because there is proxy, there is service mesh, there is a lot of things to do if you are not using like GCP or AWS and a toolbox already ready. So be careful and test it directly in your proof of concept phase. I want to thank really all the developers that are working on this project. That's something we started like in the beginning of March, and we deployed the first microservices like 2 weeks ago. There are 10 microservices that are coming until the mid of October, and I think maybe 20 next year. There is like 8 developers working on this project. Actually, they are not working on just on the migration. They are working on a new project that use the same base code than another one, that a monolithic one. So we are extracting all this share code to use it in an architecture microservice. So they have done an amazing work, especially with with the few documentation that I was able to provide with all this work. So I want to thank all of them. And I want to thank you for listening to me. And I really hope you learn something and you will have some idea to how to integrate gRPC into your microservice architecture, because it's a really, really great tools. And I really think that we will find it like really, really often in the next year. Thank you. That's all for me.
Thank you, Adrien. Thank you for this great session about gRPC. Indeed, we are seeing a lot of traction to this protocol, as we had the past experience with Kubernetes. So something coming from Google is robust and designed to support large-scale deployment. It was really great to share with us as your specific use case and lessons learned. That's really important for our audience and for the architects that are planning to evaluate the gRPC protocol.
Yeah.
So thank you for this great presentation.
Thank you.
So moving on, we'll have Gaëtan. I don't know if it's pronounced correct. So presenting the next session, who is a software engineer with 10 years experience in backend and front end, also with Angular React, which is specialized into Java and Node.js technologies. So he will be sharing with us how to generate monolithic application stack with JHipster. So let me add you to the stream. Hi.
Hi there.
Welcome back.
Yeah, I'm back. It's not that too long.
So great to see that you are presenting JHipster, and big shout out to Matt Rebel for his great tour. Yeah. Okay, yeah. So I guess you are ready.
For me. Yeah.
Yeah. Okay, so the floor is yours. You can go ahead.
Yeah. Okay. So I'll stop presenting. So my presentation is about JHipster, and my use case is a simple one, is generating monolithic full stack application. There's a lot of content, a lot of points to go on, and I might not be able to talk about everything, and I might go fast on some topics. So if you have any questions, don't hesitate to ask after, or check out my GitHub repo. All the demonstration and the presentation are in there. Okay, so let's go. So just a little bit about me. I'm a software engineer, technical lead and solution architect for a consulting firm. I work principally on professionally and personally on projects with the French government currently. So about JHipster. JHipster is a code generator. It's a cross-platform Java-based web application framework. It was initiated by Julien Dubois in 2013. So there's a few links that you may want to check. The YouTube channel, the main website, the presentation, some of it I'm going to talk about, some not. The main team, so is Julien Dubois. He's the project lead. He's also the manager of Java advocacy at Microsoft right now. And the other two co-lead are Deepu and Pascal Grimaud. And there are over like 100 contributors and more main contributors than that. The sponsors are, I have to do a bit talk about it, like Okta is a gold sponsor. You have the Octo Consulting Group, the Micro Frontend, Nintendo Platform for Communities, and DataSax. And I may check on this link. Actually, this better. Well, this tool is used like by major company like Google, HBO, Heroku, BNP, Carrefour, a lot of French company. Well, it's made by Frenchmen, so I'm a bit chauvinist on that, but it's okay. Moving on, my presentation. So the project has more than 18,000 stars on GitHub, 3.7 forks, 3.74K forks. 9.2K pull requests and like 113K downloads per week. So it's a pretty huge and really used project. It has major contribution and major community. It has over 600 contributors. So the main point is, why should you use JHipster? It's completely free and open source. They're not making money by making JHipster. There is a huge community with world-class contributors. Basically, the application is just about create, build, and deploy a production-ready web application. It's like days of work reduced to hours. It has a great up-to-date website with documentation, and the generated code by the framework is documented and follow industry best practice. You have numerous resources, tutorials, books, videos on it, so you can find your joy. So what do you want more? It has like a microservice architecture deployment. It has security and authentication, CI/CD pipelines generation, QA best practice, SQL, NoSQL, graph database supports, highly used tools like Elasticsearch, Kafka, Prometheus, Grafana, bundled inside the framework. It generates REST API following the OAS specification. You can do monitoring, caching, logging, and containerization out of the box. And it's already cloud-ready deployments on AWS, GCP, Azure, OpenShift, Heroku, and Cloud Foundry, and more. So what we have on the client side, it's a single-based application. Although you can do also timely server-side rendering. You have the top three major framework and library front, like Angular, React, and Vue.js, fully supported from the version 7 of JHipster. It has SaaS support, modern browsers compatibility, internalization out of the box, usage of HTML5 boilerplate, and it has also, it integrates responsive design with Bootstrap theme. It's a Bootstrap-based themes for JHipster. You don't have to use it, of course. You can do your own CSS and even use Tailwind. You do whatever you want once it's generated with your code. On the server side, it's major Java and Spring Boot backend. So you have Spring Profile, one for the dev, for the prod, Spring Security, Spring Data JPA, Spring MVC REST, Spring Reactive with Webflux, Jackson serialization, and database versioning with Liquibase, which is really awesome because you can do a lot of stuff with that, even though it demands a lot of knowledge about ORM and stuff. So now it's time for demo. So it's going to be live. It may some stuff may happen. I mean, I'm going to do some coding, not coding, but like command line generation stuff. So it might crash, it might blow up. We'll see. So I have I already in one day I done a full stack application that will be available, and it's fully deployed on the cloud with all of the things I'm going to talk about. I'm just not gonna do the whole thing again, but I'm going to take some part of it and explain. So let's check that. The project generation first. So what you have to do, you go into, you don't know JHipster. So you go to the JHipster, right? You don't know it. You need to have Java installed, and then you just you go into a folder and you type JHipster, and then it's gonna ask you a few questions about what you want to do. Do you want to do a monolithic application, a gateway application, microservice? I will just put it maybe a bit, just so everybody can read. Gateway application, microservice application. So we're going to go for a monolithic application. What is the base name of your application? Well, we're going to go with to-do demo. Okay, I don't want to use Webflux. My default package name will be io.jblock.todo-demo. And what you want to do as an authentication, you have a choice there between JWT, OAuth and HTTP session authentication. We're just going to go with JWT simple authentication. For the database, we have a choice between NoSQL, SQL, graph database like Neo4j, or no database though, if you don't need. So I'm going to go with SQL and choose Postgre. For development, you can use like H2, so you don't have persistence. It's just going to be in memory, but I prefer to use Postgre also, so I can just tweak with it. As the cache for the Spring cache, we have a lot of choice. You have EH cache, Caffeine, Hazelcache, Memcache, Redis. I'm just going to go with EH cache and no second level Hibernate cache because it's not needed for a simple application. For the build tool, we have, well, as for Java main, you use either Maven, Gradle, and for all project, and sometimes Bazel, but we're going to go with the Maven, which is the main use. Do you want to have a JHipster registry? It's not really needed for the monolithic application because it's mainly for microservices, so we're going to go say no. Do we need other stuff like Elasticsearch, WebSocket, Kafka, APA first development with OAS? I don't need that. I don't need anything of that, so I'm just going to go with that. Which framework I want to use for the front end? I'm going to go with Angular. Do I want to generate an admin UI to do some monitoring, to admin the users and stuff? Yes, I do want. What bootwatch theme I want? I just want the default. I don't really care. Internationalization, I do care because I'm speaking fluently French, Japanese, and English. So I'm going to go with yes, English. I'm going to throw some French and some Japanese. I'm a lot into testing and quality, so I'm going to use as much thing as I want. So I'm going to go with Cypress for end-to-end test. Protractor is deprecated as for Angular 12. Gatling for performance test, and Cucumber for BDD testing. Do I want to install other generators? I don't want to. And then it's going to generate the application. No, not yet. Would you like to generate code coverage for Cypress tests? Yes, I do want. It's going to be useful. You're going to see. So now it's just going to generate a bunch of stuff. I'm not going to show you and wait until it's finished. I'm just going to go through my basic application. So it's just going to be the result of what's going to be generated. So I created several branches. So this is the init branch. And I'm going to teach you a little trick if you don't want to, because it's sometimes like a crazy overhead to go through all the directories in GitHub. So you just add one S after GitHub, and it opens an instance of VS Code, so you can actually see the code of your project easily, and it's quite fun to see that, and it's much easier to go through your project. You can even do some git blame and stuff like this. Okay, so what was generated? So you have the basic application with user, with security, the front end Angular, and something like this. I'm not going to go into details in everything. So you have, for example, in the Java code, you have your repositories. You have like authority for authority management, user management. The domain, you're going to have authority, same user, configuration for Spring configuration, logging, and a lot of things that come out of the box for Liquibase, for Jackson, for a lot of things. AOP for logging, they're using aspect-oriented programming for logging. The security, which is the JWT one. And then we have web services, DTOs, mappers to transform entities into DTO object that's going to be transferred through the REST API. And then we have, this is for the backend part. For the web app part, so the Angular one, we have all the internalization management. So we have EN, FR, GA. I don't know if you actually see, because I cannot see the I'm just going to go through this. So you have your app, and you have basically all the stuff that Angular is is generating. So everything in TypeScript, of course. So basically, that's it for the main part. I'm just gonna go back to the console and see if it's finished generating the thing. Did finish? Did it? It's not finished yet. So we're gonna go actually to the project I opened. I have my instance of the project running on IntelliJ. I'm just gonna switch branch. I'm just gonna go to the init branch and check out, so we can fiddle with that. What we want to do is actually, so we generate the project. This is the main thing. I put that on my repo so you can see exactly what configuration we did. Now, it also generated Docker images for what we want to use, for example, for the Postgres database and some other things. So right now we want to launch our application. So what do we want to do? So we have here. So it's back. It's the init branch. So it's basically just what was generated right now. So I'm gonna launch the Postgres database because I need to make it up. Even though I'm a development, I need to have my Postgres running. So I'm just gonna throw out a Docker container, which is a Docker compose Docker image. So I'm just gonna do that. Oh, sorry, it's just a mess. So it's just Docker compose -f. You're just gonna, will believe me, like this main, all the Docker images are in there. And here we have the Postgres one, Postgres up -d, and then it's gonna launch the Docker container for the Postgres. So now we can actually launch the website, the web application, just by executing the mdn command, mdnw, because it's the wrapper. So it's just gonna execute, compile the backend, compile the front end, and just we're gonna be able to see the application on port 8080. Which is going to be here. It's from right now. It's running, so we're going to have to wait a bit. What do I need to say? I don't have much time and a lot of things to say. Just let me check something. So yeah, I'm running the project locally right now. Once once the project is going to be running, we're going to have to generate the schema, the database schema that we want. So let's see. The schema, for the schema, we actually have something that JHipster is providing us. It's called JDL Studio. And you basically, JDL stands for JHipster Domain Language. And it's basically a JSON where you describe your entities as your table and your database, and it's going to be generating everything: your services, your MVC, your REST, your controllers, your entities, your DTOs. You're going to use MapStruct to be able to generate to transform the entity, the JPA entity, into DTOs. You're going to use service with service implementations. And you define also the relationship between all those blocks, like the to-do task. We have a one-to-one between the to-do list and the user. We have a many-to-one between the to-do and the category, etc., etc. So with that, once you generated this, you just have to download it. So I downloaded it. And then let's go back to check what's happening in the console. I'm pretty sure it should be finished now. Yeah, it is finished. So now it's finished here. And did it finish to, yeah, so now our application is running on localhost 8080. So you have here the JHipster standard page. well, I'm already logged in because my credentials were already registered. It's generating, so you have nothing yet because no entity was generated, but you have your user and stuff. You actually, that's the basic one. And we're just going to go with that for now. Now I'm going to show you how you actually use the JDL that we generated. So you just do JHipster. And actually, I copied the JDL file before, and you just do JDL and the JDL file, and the two, it's called to do demo JDL. And it's actually going to generate that. I'm just going to stop the application for now because it's going to yell at me otherwise. So now it's actually generating all of those entities, services, controllers, REST API, documentation, monitoring, everything just from just a config file that you generated. And it's so, yeah, you have conflict. You just need to override the stuff, liquid-based, routing, components. So now it's going to recompile everything. It's going to generate the new entities. It's going to use liquid-based to inject fake data in the database. It's generating the browser stuff, the bundle. So now it's compiling the Angular application. We already have that, but it's doing it again. Basically, after that, once the JGL is generated, so this is the one, I applied it to the schema, to the application, and then I will run again the project locally. So that's what we're going to do now. We're going to see if it's finished. It's not finished, but I do have my second branch here, which is init JDL, and which is up to date with the JDL. So we can just switch branches, and we're going to launch again the one we just did. So it's going to compile, and it's going to generate the whole, it's going to just launch the Angular instance, the backend, and we're going to have all the to-do lists, the categories, the tags, and everything. I'm pretty sure I'm going really fast, and maybe you will have questions, but everything, all the steps that I took to build this project is described in my POC, my MVP that is on my GitHub account, so you can see what step I've done and everything that I've done. And JHipster have a pretty good documentation, so you can find a lot of things about that. So it's just generating, it's just gonna compile and launch the application. I have another thing that I want to do is actually, once this is generated, we're gonna have, we have the possibility actually to not execute, generate the project inside locally, but you can actually deploy it into a Docker image that you can after upload to the Docker Hub if you want. So this is quite easy to do actually. You just have to, I'm not going to do it because it's taking time. You just, everything is bubble. So you just do run Java Docker dev npm, and it's basically just doing an MVN NTP verify, which is just packaging the application. You skip the test and you use Jib Docker build. Jib is a Maven plugin that's going to generate a Docker image. Once the Docker image is generated, you just have to do a Docker compose on app.yaml. This app.yaml was generated when we generated the JHipster project. So everything is done for you. You don't have to do anything. So now let's hope the generation is over. It was not there. Okay. So now we have this. Now we have entities with like dummy data, everything, categories, to-do list. You can edit stuff. You can choose the user you want. You have like a bunch of stuff like generated by Liquidbase. In administration, you can check the metrics. The metrics is actually really, really nice to see. It's based on Micrometer and the Spring Boot actuator to monitor the JVM. So you have the heap size, the garbage collector activity, the file log, the CPU usage, the RAM, and a lot of things like the HTTP requests. You can also do health checks and see how the database is. And you can check the logs actually because it's using log4j. Well, it's taking time to get the logs, but they're here. So this is basically all the logs that the application generated, all the application logs. So you can see that you have already a lot of stuff, and you have the Swagger API, which is amazing because it's already generated. You have your API. You can just check whatever you want. So you have a fully built documentation that you can share with your team and stuff. That's amazing. Also about the language, I told you, well, it's not going to translate the URL, of course, but you can change the language out of the box. No, you of course have to translate it yourself, but that's another matter. So now let's continue on that. The Swagger documentation we just saw. So this is it. Application monitoring, I show you what was that about. Authentication, it's using JWT. Yeah, I'm gonna get it. Because Spring Security doesn't support JWT out of the box. So it's an implementation that doesn't use Spring Security. So now about the tests and the quality. We have the backend tests, which are using JUnit, Cucumber, JUnit for all the unit tests, the integration tests, the architecture test, and Cucumber for the BDD test. So in order to do that, you just have to go to your backend, and I'm just gonna check it again here. Just gonna do MVN verify, and it's just gonna execute all the tests for you. So you have approximately 156 tests with a 80% coverage of your code. And this is just for the backend. The front end unit tests are executed with another command that I will show you after, and it's not working because, oh well, maybe, huh? Well, that's because yeah, I understand why. Because I'm not on the right one. I need to change my branch to the main branch because I have my Gatling tests which are messing up with my stuff. So I'm just going to do it again. Well, there's nothing much to show except like you have your Java test here. Not here, sorry. Here you have your Java tests. For example, services, DTOs, mail service, category DTO test, mail user IT, everything that finishes by IT is an integration test. Arc test is an architecture test. It's basically checking that no layers is depending on another layer that it shouldn't. Cucumber is fun. Cucumber is as a natural language description for scenarios and tests for BDD using the gherkin. So basically you have a scenario when I search user admin, then the user is found and his last name is administrator. Then you just implement this test. And it's just a way to define test using this. It's quite common to use that right now. So now it's just generating tests. So let's move on the presentation. So yeah, this is so for the front-end test, it's using Jest out of the box. You could have used Jasmine because it's really used in usually when you do Angular, by default you do test bed and it's using Jasmine, but they choose to use Jest, and I think it's better. That's just my opinion. So basically, to launch the test, you just have to do npm test, and it's just gonna do ng test actually, which is Angular test. So npm test. Just running it for the fun because so now the backend tests are starting. Well, it's taking time. So it's launching the architect arch test in the backend. Here it's doing some linting. Oh, I just have 10 minutes left. Okay, let's move on. So you can do front-end test. You have E2E test with Cypress, so you just have to run E2E or run Cypress to do that. I'm not going to show it because I don't have time. You can do performance tests with Gatling. So you can see on my repository, actually, you just do MD. I just added a Maven plugin with Gatling install, and it's just gonna, the tests are defined in Scala using the Scala language. And so, or maybe we can just see, because the Gatling tests are already generated, and I'm gonna show them to you. Actually, they're like this. This is the Gatling report that you get. So it's basically just a stress and performance test, like get created to do this. Like it has done 15 requests, and all of the tests have been under 800 milliseconds. You can see the peak, the response time. You can see everything. It's just basically testing the REST API quite aggressively, authentication and a lot of different things. For the Cypress stuff, it's actually this. No, this is Cypress is just like the E2E test. I can show them to you. Well, what's that? Okay. Oh, that doesn't matter. Seems to be having a problem with you. What? Okay, never mind. We have, so now that we have generated, I'm not gonna run the Cypress test because it's not working right now, but it's just basic command line, and you're gonna do this. So you just run Cypress and it's just gonna do that. Performance test with Gatling. You can, I'm actually gonna check that. You can also test, since now our backend is running, if we want to do just test the UI, it's gonna use Webpack and launch browser sync in order to like reflect your change immediately when you change something. For example, we have this page locally executed, if it's there. Yeah, it's there. Here I want to change something on my page. And, well, I have to wait for that to be okay. So now Webpack is like bundling everything. It's just like doing some optimization and serving on localhost. Not using. It's actually not going to use the same port. It's going to use. Wait. So you have. It's going to do on localhost 8, and you see browser sync is connected. So now you can check. Actually, sign in. I'm going to do admin. And now we're just going to have fun and check something like, for example, on the web app, we're going to change the, I don't know, maybe just one message in English. Home.json, question if you, welcome Java hipsters. Let's say, welcome Kotlin hipsters. Okay, so now it should detect the change and it should reflect it here. Immediately, it should be doing this. Sure. Unless it's not the one. Should have done it actually. Oh yeah. Well, it should have uploaded immediately, but I had to refresh the page. So now we have Kotlin Hipster here instead. So moving on, we here now the QA. So I'm going to pass quickly on the rest. You have a Docker image built in on SonarQube, which you can just like do a Docker compose, and the image is just gonna execute, and then you do a clean verify sonar and like this stuff, this line of code, and then it's just gonna build in production the code. And test everything and generate the sonar report. And the sonar report is going to look like this. I already generated it beforehand. It's this. So we have like, this is basically, it's including front end and back end. So we have a bit of cut smell, 4 hours dead for like a 13K lines of code generated. I think that's not a lot. So the maintainability is pretty really nice. We have 82% cut coverage, which is really great. So here now, let's continue on the presentation. QA also, you can do a verify to check the OWASP vulnerabilities on dependencies. It's not built into JHipster, so you have to add a Maven plugin. You can check my repo, it's in. So it's basically this plugin dep check, and is just checking the dependencies. So now the interesting part is the CI/CD thing. This one is kind of cool because it's all gonna generate automatically your pipeline with what you want. So I'm gonna show you an example with here. I'm gonna do JHipster CI/CD, and it's gonna ask me which CI/CD tool I want to use. So there is either Jenkins, Adrien, GitLab, GitHub Actions, Travis CI, Circle CI. I'm going to use GitHub Actions. What do I want to do? Deploy your application to Artifactory? I don't want to. I want to analyze my code with Sonar. I don't want to publish a Docker image. I don't want to use Snyk. Snyk is same as I said to check the vulnerability for the dependencies. I want to deploy to Heroku. And I want to enable the Cypress dashboard. So basically, when you do that, well, you have to tell your Sonar Cloud URL. Then you just like you continue with all the configuration. All the configuration is pretty straightforward. I'm not gonna go with everything. Is that I'm just gonna show you actually the pipeline that was generated. So here we have tech. I'm just going to go back here on the main page. And we have this action. It's normal that it's not passing, but yeah, here, this is all the build that I've executed. So let's check one. So all the steps that are defined in here for the CI/CD, it's checking out the repo. It's installing the Node.js package, running the backend test, running the front-end test, generating the SonarQube. So we have that on Sonar Cloud, actually, here. So it's like sending all the code there and using cloud platform analysis. Where is that? It's here. And also, it's going to do some package the application. If the SonarQube gate is passing, then it's going to package. So it's going to just build the jar, the fat jar, because it's a fat jar with Spring Boot application with the Angular application. It's going to deploy it to Heroku that I set up previously. So I have my Heroku deployment here, actually. I'm going to open the app, and you're going to see, well, Heroku have a cooldown time, so it's going to take just a little bit of time before it's open. And once it's deployed to Heroku, it's gonna run the Cypress tests. And for that, I also have a Cypress on the cloud client, which is using it, which I overloaded already my free tier. But with that, you have some continuous integration and continuous deployment on Heroku every time you do a pull request or every time you do a new push on the main branch with the GitHub Actions. And so you have a full-fledged deployed application with tests, with quality, with everything. So you can see now I basically have like my quality gate is passed, my coverage is for 82%, my Cypress tests are passed, and then on Heroku.gblog Geekle to do Heroku app, I have my application. I'm gonna sign in. It says admin. And then it's the same as the other one, except that I don't have the fake data because it's in production. I just like put some random data here. If you want to create a new to-do list, you just basically do something like this. Save, well, and whatever, yeah. Or because you cannot do that, well, there's a problem. Anyway, the thing is that it's deployed on Heroku and it's working fine. Last thing, so now the application is fully deployed. You can go further with that because I've just talked about a monolithic application, but you can do crazy stuff with the JHipster. It's supporting microservices, API gateway. You can put some ELK stack, monitoring not orchestrating your microservices and your micro front ends, using different sort of database, NoSQL database, JHipster, and you can do a lot of stuff. This schema was not done by me. I think it was done by Deepu. And so you can do pretty crazy stuff with that out of the box and with not a lot of tweaking. So I recommend you go to this website, startjhipster.tech, and you can do everything. You can do everything I did, but on their platform, or you can just do all the steps I've done. Everything is on my repo, and if you have any question, don't hesitate to contact me on my social network and everything. I can explain everything to you. Thank you all for listening. I hope I wasn't too long and it wasn't too quick, but thank you.
Thank you, Gaëtan, for this session. It was an incredible presentation, and indeed, JHipster is really interesting as a code generation tool, and we are seeing the trend now for generation code as with the new feature at GitHub Autopilot, and JHipster is with its large share of contributors is also getting more and more features. So that was, I know that time wasn't enough to present all the layers.
I didn't even talk about microservices and stuff. I could talk about that for 5 hours, and that would be a whole thing.
Yeah. Okay. I'm gonna add also Adrien to the stream. Welcome back, Adrien.
Hi.
So Adrien, wanted you to share with our audience on the challenges you faced while migrating your current application to use gRPC and protobuf. What are some of the main challenges you faced?
Actually, the main challenges, because we have a complex data structure in our industry. So it was not related to gRPC. But if I have to focus on specific gRPC challenge, I would say the production-ready server, because we are more like developer teams. So we had to, especially for gRPC web, we had to add the service mesh with a lot of configuration. Not a lot because they give you everything, but you need to override some istio settings in the service mesh or use Envoy. And actually, with Django, there was some DB connection that was not closed. That is done automatically with Hides GI and not directly by gRPC because it's a new framework. So I think it was the deployment phase because we didn't have the competence, and after it was like scripting all the automated tools. But in this part, it was really fun. You know, it was like scripting and coding. It was not like debugging. So I think the really harder things in the debugging process was in the deployment.
Okay, great. And so now you are running in production using gRPC, and what is your feedback either on performance, stability of the platform?
We are still working on it because it's a project that we launched at the beginning of March. The first microservices are in production since 2 weeks. So the feedback in 2 weeks, it worked very well. We won on performance on the biggest request. On the smaller request, it doesn't show a lot of modification, but actually it's on the bigger request that adds more importance because that's the one you see slow. So it was a benefit for them, and I am really expecting improvement about the maintenance cost with the strong tipping and the strict versioning of the API. And so I am really looking forward for the benefit in the next month, next year. But for now, it's really soon to talk about that.
Okay, thank you. Last question is your advice for our audience, for those who are interested in gRPC, where to start. So if you have some advice to give them, that would be grateful.
Actually, it's a little bit complicated because gRPC is a multi-local tool, so you can do in any language, programming language. So I think the best way to start is to type on Google, after learning the basic of gRPC in the official documentation, of course, is to type the framework, the web framework you use in gRPC, and look if there is already a framework for it, or if there is someone working on it, or with some input. And if there is not, don't close the door, but be aware of the complexity if you are in the small team.
Okay, thank you, Adrien. Move on to Gaëtan about JHipster. So same question to be asked: where to start if we want to use JHipster today?
Where to start, but as I said, it's a really easy to generate code with JHipster with a few lines of console. So it's a really good tool for junior dev because it's building a whole application quite quickly with a lot of standards and a lot of new technologies used currently. So you learn a lot just by generating the first application. You just check the code, you change something, you see what's happening. If, for example, you want to check the difference between generating a front in Angular or a front in React or something like this and see what's happening. You want to use reactive REST API instead of MVC async or basic REST API. You want to check different CI/CD tools. You can pretty much do on the shelf what you want and what you want to generate. So I say just pick what you like. If you like, well, maybe just start with Java because it's Java oriented tool. But so Spring, MVC, and one of the tool you want to try out. So one CI/CD tool like Jenkins or GitLab or something like this, and Angular or Vue.js, which Vue.js is a newer version. Like it just came out as an official blueprint of JHipster with the version 7. So I think it's a really, really good tool to learn a lot about full stack application and deployment and things like this.
Thank you for your answer. So maybe you can share with us if you have specific use case for generated apps with JHipster running currently in production.
Right now in production, I used to, my first time I used with JHipster was in 2017. I was working in a company and I didn't know JHipster before, but like they talked to me about this tool that could generate Angular and Spring Boot code like this. So the basic application, because at the time there was only the only option was Angular and Java and Spring MVC. That's all. So we just generated the code, and the DB was MySQL DB, and it was to handle the day-to-day consumers of beneficiaries in Sri Lanka. Like they were taking like at a supermarket, but for people who are poor and who cannot pay for it. So they use like a smartphone kind of like you use a tag to check the price of something. And I was designing the dashboards, like what everybody was consuming every day, like oh, this guy came 3 times this week, this guy didn't came, so I have to launch a notification. So it was a front in Angular and a backend, a simple backend application with like dashboards and the everyday consummation of they were not customers, it was beneficiaries. But that's in prod and still in production and evolving right now. But it's pretty basic application. But I know a lot of different application used using major microservices architecture using JHipster, and it's used in a lot of companies.
Okay, great. Last question. So once the applications are generated, so then do we still manage them by JHipster tools, or are we just, it ends with the generation of code?
No, the idea behind JHipster is like you generate your code, then if you're confident enough and you want to keep your code up to date, you modify the generator, you fork the generator to every time you redeploy your application, you regenerate your application, your impacts, the modification that you did to your application are always up to date with the generation. So it's basically you forking the whole blueprint and you're doing your own, and then for your company, for your practices, with your standards, with your way of doing things. And then every time you regenerate, it's always gonna go from your implementation of this generator. And you don't have to always use Java. There's plenty of blueprints available. There is Kotlin, there's Node.js, Svelte, Quarkus, Micronodes. There's plenty of things you can do.
Okay, great. So thank you, Gaëtan. Thank you, Adrien, for your great presentation. We'll have the presentation recorded and maybe slide shared with the audience. So we'll move on now to the next block. Okay. Okay. So we'll have an announcement before going on a break, and then we will go to the next block. So Victoria, if you can share the announcement.
Yes, sure. It will be ready just in a minute.
Okay.
Hey everyone, I hope all of us are enjoying this summit. And to make it even more value-packed, we have prepared great discounts for you. In 2 weeks, we are running a QA Global Summit, an event for the biggest community of 2021. And we have a special offer. During the next week, you can get the summit ticket at a 50% discount for your QA team. If you ask me, it's an insane opportunity. To get the deal, just use our promo code SUMMER50 at checkout.
always do that. And I'm on mute. Hey, everybody, it's Mike. How's everyone doing out there? Man, I'll tell you what, it's been fun. I'm sure a lot of you have gotten some great information. I have too. I'm just filling my head with all of this. And I think I need to, like, you know, pop some stuff off from previous stuff. What can I say? I guess I'm getting ready to start this next set with everybody. And what I'm going to do here is I'm going to announce our next speaker here. His name is Arnab.
No, sorry, Mike. So we have a quick announcement before the first speaker. So let's watch it. Yeah, let's watch it.
I am so sorry, everybody.
Don't worry, Mike.
Yeah. Go ahead and roll it. We have a great, cool announcement coming up, and here we go.
And now I'm here with great news for our lovely HRs. On September 22nd and 23rd, we gathered the most respected HR and recruitment experts to share their knowledge on human resources care in these complicated times. This event is no exception. You can get it at a 50% discount. To get the deal, just use our special promo code SUMMER50 at checkout.
Man, okay. Before we go on, I just want to say, if I was you, I would go to that. I'm serious, because everything that I have learned in the past, I don't know, last year, because I've been part of just signing up, right? Doing all this crazy stuff with Geekle, man. I tell you, it's really helped me out. And I would go to that. I'm serious. That's, you know, me. Yeah, there it is right there. The HR, recruitment, IT. Oh, my word. You know what? I know for a fact that everything that I learn normally through books, right? And then also through watching YouTube videos, there's just something different about these summits. I'm just telling you. And I would say take advantage of it. It's like a fast track way for you to get the information that you need to do your job. Or maybe, I'm just saying, you know, you might, you know, be looking for a job and you might need that, right? But these summits, these are amazing. These people who come in are the experts and the experienced ones in the world. They really are. And so when you sit there and you go to these summits that Geekle puts on, you'd be surprised. Somebody, when you're in a job interview, or somebody in your job is going to ask you a question, you go, man, I learned that. I learned that at the summit. I learned that at maybe the HR and recruitment and IT summit. You never know. I know for a fact some of the summits that I've gone to here at Geekle have really helped me out. I'm like, yes, thank you. Because there was something there that one of these amazing speakers brought to my attention that I never thought of, because of their amazing experience that they've had out there in the world. That's right, the world. Anyway, I just wanted to say that. I love when I can drop that in there, because they do, Geekle, an amazing job. So right now, what I'm going to do is, let me tell you about our first speaker coming up here in my block. His name is Arnab Choudhuri. And this is a founder of, it looks like, Xanadu. And this is so cool. Again, this is something, guys, pay attention to this. It's Introduction to Hypothesis-Driven Development. Hypothesis, sorry. The thing about it is, this kind of talk like this, I'm going to sit here, I'm going to be right here with you, and I'm going to be listening to this. So without further ado, I'm going to let him do his presentation.
Good morning, good afternoon, and good evening to all, based on from wherever you have joined. My name is Arnab Choudhuri, and I will today be speaking on hypothesis-driven development. So next, who am I and why should you even be listening to me? I call myself a divergent technology specialist and have a little over 25 years of experience in software, and so have seen a lot of changes. And because I have taken the time and effort to understand the reasons of these changes, I believe I have an understanding of this change progression. And to trust me when I say this knowledge is important, as unless you have this, you're going to use certain technologies, not because you need them, but because it's cool, and that too in a wrong way, leading to a massive mess up. Also, I work with companies and projects of different sizes and so have a good understanding of what is possible in, let's say, X amount of time and Y amount of money. Let me start with the context. We need to deliver new features and functionalities far faster than what was expected. Also, users of software expect customer experiences and delight them. If you are in B2C software development, then this is of utmost importance as only the best offering would survive. Even if you are into enterprise software development, even then, your users expect better customer experience as they are users of B2C softwares as well. Use of cloud, microservices, etc. are also something you need to consider. But the biggest disruption, in my opinion, is the shift from project to product-based approach. So what's the difference? According to Forrester, the difference lies in the mindset change of persistent responsibility of outcomes from temporary responsibility of deliverables. In this complex environment, where nothing is safe from disruption, the old ways of discovering and documenting requirements do not work. And so, I will present to you an alternate to the same called hypothesis-driven development. And you will see that this alternative helps you to move to a product-based approach, which has an iterative experimentation and in its build, measure, learn concepts. First, let me start with progression of methodologies. Now, these methodologies have multiple facets, but I'm going to be speaking of just one: requirements. All methodologies require the same type of requirements activities: identify users or stakeholders and elicit requirements from them, and finally analyze, document, and validate them. When I started on my software journey, the software development had distinct stages: requirement analysis, architecture design, coding, testing, and finally operations, which included delivery and managing. Unless one completed, the next did not start. Work flowed downhill like water and hence known as waterfall. People would spend weeks or even months preparing detailed documents before passing them on to the team responsible for the next iteration, or rather the next stage of the iteration. It was a well-known belief that further you are in this cycle, the cost of change increased exponentially. So having a rock-solid, prioritized requirements document or use case document was always good, as the cost of not having the same and finding in testing phase that you needed something else than what was built was a huge loss. Estimation for downstream phases was also done in this phase, I mean the requirements phase. Delivery time was between months and 2 years even. But dealing with issues arising of assumptions in requirements phase was delayed till testing in waterfall model. These led to integration failures, huge technical debt, and premature project end. Then, some smart people figured out that requirements defined too early in the project was wasteful, rather not possible. And moreover, changes in requirements was bound to happen. And a software where requirements was not changed was most probably a software which would never be used. So, they came up with methodologies known as lightweight methodologies, which later came to be known as agile methodology, after 17 people met at a ski resort. This, or rather these methodologies, had concepts such as high-level epic or theme stories, and more important, broken down user stories, which would emerge iteratively in a product backlog. Stories were supposed to be brief and represent only a single change or small set of interrelated changes to keep a team member's focus on a tiny portion of the project. Also, in this methodology, requirement details generation as well as estimation was done just prior to implementation. And so, the risk of this information being obsolete was far, far low. These user stories had to be simple enough to be developed in 2 to 4 weeks. And so the delivery time of a new feature was down to weeks now. I will speak on user stories in the next slides as well. Next methodology is a growing methodology and is known by many names such as DevOps way, etc. and many more. It is my suggestion that rather than getting into all the facets in this methodology, you could start with two I have stated: hypothesis-driven development and continuous deployment. And in turn, that channelizes the entire DevOps chain. I'm going to speak in this session on hypothesis-driven development, which is also a lean iterative process, and this mindset helps one in experimentation in production. Whereas in Agile, user stories were supposed to be independent, negotiable, valuable, estimatable, small and testable. In hypothesis-driven development, being measurable is a key in every development cycle. As far as continuous deployment is concerned, you will get enough info on the net, else just search for CDCon in YouTube. With these two, you could trace causal relations between the changes you made in a deployment against key metrics. And so, after every iteration, the team has not only working software, but also validation that whatever they have built is useful. As I stated in my previous slide, in waterfall, digital projects were constructed the same way as physical large projects, say a bridge or a large building. Requirements and priorities would change before the first line of code was written. One of the lightweight methodologies was extreme programming, and the proponents there created the concept of a story. The concept allowed high-level decomposition of the tasks needed, and the detailed analysis would happen at the time of implementation. Another methodology was Scrum, which also had a similar concept, though they explained this in product backlog item and its prioritization. User story term ensured that prioritized works would deliver value to user. The user or persona or role is the key here, and a template as guidance to help teams capture enough information in the story was born, as you see in the slide. This was by Rachel Davies. It comes very strong. It comes very strong when you state as first person, like in the template, as XYZ I want. You imagine yourself as that persona. What is necessary to understand is that here what is important is the conversation. The content written in the template generates, and not the content per se. Else the content would become a mini requirement and specs as well, which is not necessary. Moreover, this conversation is important because it enables the team to learn about the problem and the solution. It's important because this helps in discovering the requirements. But this is exactly what did not happen. Many teams use software like program management tools like Jira to build backlogs that contain hundreds of stories, each having detailed requirements. Moreover, these details are never discussed with the team. And so, a solution proposed to the problem of the struggle of writing user stories, which provide the right clarity to teams unable to deliver valuable solutions, is behavior-driven development. So let's understand how this happened. early 2000s, there was a new programming model called test-driven development where coding, testing, and refactoring was tightly connected. This methodology enabled one to think of the problem before you started on the solution, or rather, thinking of the solution. Now, user stories were supposed to be testable. In one of the test-driven development books, acceptance test-driven development was put forward, which involved team members with different perspectives collaborating to write acceptance tests in advance of implementing the corresponding functionality. How this came about was that some smart people figured out that there was a need for consistent vocabulary amongst analysts, testers, developers, and the business. They also figured out that describing software behavior as requirements eliminates some of the ambiguity and miscommunication that occur when technical people talk to business people. This they named behavior-driven development. According to Agile Alliance, behavior-driven development is a synthesis and refinement of practices stemming from test-driven development and acceptance test-driven development. You would define behavior and outcome in behavior-driven development in simple domain-specific language, in natural language constructs or English-like sentences. But a bigger plus is that there are tools which take these behavior-driven development constructs and convert them to executable tests. And so now you have a process of providing quality even as the system evolves by defining tests as part of detailing system behavior. The template captures the story's acceptance criteria in a given when-then format. I will not get into example, but there are sufficient available on the net. So, finally, hypothesis-driven development. This takes a step back and asks, how do we know whether what is expected is actually valuable to the end user? This started as a tool for product teams in startups where the requirements are volatile and as part of the lean startup. The product design team explored assumptions and tried to validate the same using experiments in the form of interviews, surveys, usability testing, and so forth to confirm if the assumptions are aligned with reality. So one was basically testing the problem. This idea is today also in the product development space. Smart people accept that discovering and documenting requirements based on any user's opinion is inadequate. If you remember our user story template, it basically stated the user wants. That is a prediction by dev team, or rather an assumption. It becomes a hypothesis if there are plans to test it. A potential pitfall in user story is around stereotyping. But users are not always going to match to the stereotype. And so, stories tend to build a false sense of user centricity. A hypothesis helps to prove or disprove an assumption. These temporary suppositions can be hypothesized, and then decisions based on measurable evidence can be taken. Pivot is a standard term in startups, which means completely abandoning one plan for another when a hypothesis turns out to be wrong. When you start building a product or service, there are multiple problems you need to think of. The target market, business model, customer experience, how code will execute, etc., etc., etc. You can think of solutions to all these problems as hypotheses. As software architects, your hypothesis based on certain assumptions are going to be for a problem of, let's say, how your code will execute and is your software scalable. rather than target market, and if your business model is scalable, which will probably be decided by the product team, and it will be their hypothesis. What I mean is, your hypothesis will be very different from the hypothesis made by your product team, and even there, the product design team would have a different hypothesis than the product management team. Not only that, the method in which all these different teams form a hypothesis might also differ. So let me start with the Sign-FN framework. Sign-FN framework was created in 1999 by Dave Snowden when he worked for IBM Global Services. Sign-FN offers 5 decision-making contexts or domain. I'm going to focus only on the complex context. If you're interested in this framework, please do search on them. The complex domain represents the unknown unknowns. Cause and effect can only be deduced in retrospect. Here, in this environment of uncertainty, extended periods of analysis, planning, and their traditional user value user story would not help you. What will is the probe sense respond approach. This approach is very similar to the build measure learn approach I spoke at the very beginning of the session in context of the product based approach. Now, requirements are valuable. When teams execute a well-known or understood problem, and so not all user stories will require a hypothesis. But you should create a mindset to challenge the concept of having fixed requirements, especially when you have to navigate through an exploratory, complex, or unknown space. In this context, it's a good practice to utilize the full potential, experience, and competence that cross-functional, multidiscipline team offers, which normally today all software teams have, or rather the entire business team. It is a very bad idea for projects to run based on a single person's opinion, however competent and experienced that person might be. So, when should you be utilizing this methodology? The first case is when you are building a greenfield projects. Rather than assuming that you understand what is needed to be done, it's better to document all your assumptions. Building a product with lots of assumptions or unanswered, rather unverified questions increases risk. If we constantly test the hypothesis based on these assumptions, we build a large database of insight. Else, these assumptions accumulate and a massive goof-up follows. The second reason is the presence of outlier conditions. Behaviors can be affected by specific audiences and other factors. Removal of uncertainties as a project progresses is always useful. The third would be the presence of volatile requirements even in brownfield projects. And as I have stated earlier, it's always good to test whether these so-called requirements are actually valuable. The fourth reason is probably the primary reason why hypothesis-driven development is picking up speed, especially as a methodology amongst software architects. That's modernizing legacy applications. Re-architecting old enterprise applications to cloud native using microservices has to it other nuances as well. Enterprise have hundreds or thousands of applications designed decades ago which have become outdated and moreover do not communicate with each other. There is a necessity to simplify the landscape, rather these business processes while re-architecting. Moreover, the evolution of these applications should be non-destructive. By this I mean, you can't just say that some of these applications won't work for a period. as these are necessary systems. Also, the knowledge that existed while developing these applications is in most cases absent, as the team who did that has either moved on to other projects or even other organizations. And so in this complex environment, hypothesis-driven development is very useful. And as I have stated elsewhere, as the process of re-architecting to microservices-based application increases, as building microservices becomes more commoditized, over the next few years, hypothesis-driven development will also gather more steam and become essential and useful for all architects. So the steps are, the first would be identifying assumptions. The assumption could be regarding usage of distributed databases. It could also be regarding the persona, the problem statement, the context, the scenario map, etc., etc. Find out if the product team did a proven hypothesis on every assumption, or at least if there was user research, and if so, how strong was it? Or did they guess? This way, you can have a backlog of assumptions that is ranked by risk. I use the word ranked and not prioritized, as several items might be of high priority in a prioritized list. But only one can be first when you have a rank ordered list. The second is to formulate a hypothesis. A well-defined experiment can validate or invalidate the hypothesis. It's crucial to set right test criteria or have measurable outcome for the hypothesis. This in turn means that we must have empirical evidence so we can determine whether this test has succeeded or failed. But you need to finalize the correct metric, especially since metrics can be overused as well as abused. Clearly state what the experiment will be as well as the outcomes that determine when the hypothesis is valid. The signal that is to be measured should be an actionable metric and not a vanity metric. So let me give an example. How many people visit your website is a vanity metric. On the other hand, measuring revenue shows how your business is really doing. But it's of no value to know that revenue increased if you don't know why it increased. Because unless you know why it increased, you can't repeat it. So the actionable metric will catch why the revenue increased. And you can use the approach of hypothesis-driven development to experiment and find the best way to add value. The third point is to build the quickest thing viable to test the hypothesis, deliver fast to experiment fast. The fourth stage is to deploy the application and conduct the experiment. Here, it is critical to have good monitoring and evaluation tools in place in order to measure the impact of your efforts and provide a feedback loop to the team. Do remember that results are only as good as your experimental setup. And so, your experimental setup must be similar to your production, meaning if in production you would have 1 million concurrent users, please ensure you have 1 million concurrent users during the experiment as well. Else, you would be blind to the outcomes of your experiment, and this can ultimately cost a lot. Gather data by implementing feature flags, performing A/B testing, or even multi-armed bandit experiments, especially when you explore multiple options. Then there are click flow tests to understand whether your users are comfortable with your purchase flows or any other flows. 5-second tests to get a user's initial reaction to a user's interface, etc., etc. The last point is to learn whether the hypothesis has succeeded or failed. The act of persevering or pivoting based on a hypothesis is always a learning opportunity. Even if you can't prove the hypothesis, the outcome might provide valuable insight you can use in another hypothesis. You might need to go through this hypothesis testing cycle several times until you validate all your key assumptions. Each iteration will help you know what worked, whether you're on the right track, thus reducing your risk. Unlike all other methodologies we have seen today, this one yet does not have a standardized template. I have found 4 to 5 templates. The one on screen is the one I like the most and use. In the very first line, by defining the functionality, we identify the feature and persona in turn the hypothesis we want to test. What is the outcome we expect? We define in the second line. The third line will state what key metrics are to be measured to provide evidence that our experiment has succeeded or not. So let me give an example. But prior to that, let me provide you the context in which I have written this hypothesis. Historically, when there has been a necessity to send information between services, request-based architecture, which include remote method invocation, whether REST or gRPC, has been used. But if you wish to deploy on cloud, you need to worry as to making the architecture resilient, and so you have microservices, event-based architectures, and message brokers like Kafka. I'm not going to speak much on microservices as there are quite a few sessions happening on them. Just like to state that unlike service-oriented architecture where all services wrote and read from the same data store, in microservices-based system, each microservice is supposed to have its own data store. Let's take an example. In an e-commerce system, you have multiple microservices. Of them, 2 are order and shipment. Once an order comes in, the order service persists the order in database, say order table. It also needs to send this information to shipment service, and the mode for the same is Kafka. But the challenge is, it is not possible by the service to write data in database and send data to Kafka as a single atomic operation, which basically means you might have an inconsistent system if either Kafka or database goes down. So in this context, I am going to put forward a hypothesis that I can solve this problem of dual writes, one to database and the other to Kafka, using change data capture solutions like Debezium, and by implementing the outbox pattern. I will know that my hypothesis has succeeded when I see the same number of data points in both the services data store, even if I shut either Kafka or order service database, and so in the process have a consistent system and a resilient one as well. So in case you do not know what an outbox pattern is, in outbox pattern what happens is that order service along with persisting data in order table also persists the message payload along with some metadata in outbox table. These database operations can easily be part of a single atomic operation as a transaction. A separate message relay process, in our case a change data capture tool like Debezium, tracks the outbox table and publishes event to the message broker, in our case Kafka. So that's basically the example of hypothesis-driven development. And so finally, summary. To recap, practicing hypothesis-driven development is thinking about the development of new ideas, products and services as a series of experiments to determine whether an expected outcome will be achieved. The process is iterated upon until a desirable outcome is obtained or idea is determined to be not viable. It is necessary for architects to be able to work with product owners. Speaking of developing mindsets, do try to get trained in product ownership principles, be able to communicate with product owners. This will help you. And this is most important. Even if you do not hypothesize, you still need to know this methodology, as your product designers are most probably using it. And you have to develop the test beds to test what they have hypothesized. As a practitioner, I have 2 pointers. Keep your experiments and documentation light. This will help you pivot if results turn out not as you hoped. And the second is, what is important is the hypothesis and the test, and not getting the hypothesis right. Don't be afraid that your hypothesis will be wrong. So I come to the end. Thank you. And I'll be available for questions during the question and answer hour. Please, if you have any doubts or questions, please do ask them. Thank you.
Okay, so we gotta thank Arnab for his amazing presentation he sent us. So our next speaker, Steliyana, is still joining, and I'm gonna fill just for 1-2 announcements of speakers while Mike is there on the Q&A session on the pro track, but he will come back and finish this moderation. So yeah, because Steliyana is still joining, and the video was finished a bit earlier, so we're gonna have a short break and we'll continue with the next session. So stay tuned. Okay, we're back from a very short break. So yeah, I'm going to announce the next speaker, and her name is Steliyana Gencheva, and she's going to talk about hexagonal architecture. So hello there.
Hello.
Yeah, I can hear you. Everything is good from your side. So yeah, happy to see you here. And are you ready for your presentation?
Yeah, I think so. Let's see. Yeah.
Okay, then we can start a bit earlier, but I don't think that could be of any problem. So without further ado, I leave the stage to you. Good luck.
Can you see my screen?
Yeah, I'm editing it right now. It's on stage. Yeah.
Okay. Okay.
Yeah, the stage is yours.
Okay, thank you. So, hello everyone. It's kind of weird that we cannot, see each other, but okay, I'm gonna imagine. So today I'm gonna talk to you a little bit about hexagonal architecture, and in fact, the thing that amazed me about the hexagonal architecture is, in fact, how things are ordered there, how tests are extremely easy to be implemented, and in fact, test coverage hits the roof. And I'm not talking only about test coverage, as percentage, but, real coverage. I believe that hexagonal architecture can bring a lot of benefit for us, not only for us as developers, but also to our code base. It changes the way we think. It challenges to unlearn what we have already learned. Oh, it's awesome and extraordinary. Before I start, I would like to thank a colleague of mine, Alex Barbo, for his inspiration, for inspiring me to dig deeper into hexagonal architecture. So thank you, Alex, if you're here. And let's get started. First, let me introduce myself. My name is Steliyana Gencheva, and I'm the software architect at vol.2. I've been fascinated and interested in software development basically all my life. To be honest, I was not able to read before I was able to calculate not only decimal but also binary numbers. I have more than 15 years or more experience in software development, and all these years I've been fascinated by it because it's always changing, it's always evolving, and it's amazing field, in fact. So let's get started. Let's get deep into hexagonal architecture. First, it's what's wrong, in fact, with our current application. We all have seen a lot of them. There's always something wrong. And then why talk about hexagon? A lot of questions might pop into your mind, but I'm gonna do my best to answer most of them during this talk. And the question that I won't be able to answer, we have a Q&A section later on that I'll do my best to answer. So, but first, let's go back a little bit back in time and see how things change and how we end up where we are today. Maybe some of you remember or heard that back in the days, PHP and HTML were living together. We have this type of code that it was working. It was working fine for that time, but over time things changed, things get more complicated, and we needed something. We needed to organize our code base in some way. And over time, people, maybe you remember, MVC was born. And MVC was kind of easy. You have a model directory, so you put all your models there. You have a view directory, you put all your templates and views. And basically everything that ends up with controller, you put in the controller directory. Easy peasy. Good. But again, for some time, because over time this way showed that it just cannot scale. With growing of software systems, this was not good enough anymore. And in fact, where does MVC come from? Well, it comes from the frameworks. We all know them, we all use them, we love them and hate them, mixed feelings. But we've seen a lot of software systems and applications that are tightly coupled to the frameworks that they're using. These frameworks that were picked up in the beginning when the application was created from the people who created that or you created. But okay, how do we usually start a new project? Okay, we pick the framework, the one that we like, the one that we have experience with, or the one which is the most modern one. Okay, then we remove some demo elements. We follow the documentation of the framework. We auto-generate controllers, entities, and so on and so on. And okay, it's all done, right? And so what happened at the end? We picked the framework, and then every decision from this point on that we make, every step that we take, suddenly we have to take this same framework into consideration. And I don't know about you, but for me, it's like the framework was something that was created to help us, but suddenly it starts restricting us in the decisions and everything. The same applies for the database that we have chosen and the libraries that we have chosen, the ORM, for the caching mechanism or the caching itself, the caching libraries, the front end, for all these external things that in fact are external, that have nothing to do with the application that we're creating. I mean, they are important, of course, they're very important, but the application that we're creating is related to the product that we're delivering. We're not creating Laravel applications, we're not creating MySQL application or Postgre application, we're creating our product application. So why focus on, all these external elements? Then if we go with this approach, what we're getting is slow tests. Because in order to test the core functionality, we end up in a situation where we have to instantiate all these libraries. We have to instantiate the database. We have to instantiate the caching maybe, or a lot of other external things, just because we want to test our core functionality. If we follow the documentation of the framework, we can end up with a code that looks something like this. And if we take a look at this piece of code, we see that it is tightly coupled to the delivery mechanism, to the request object, to the response object, to the ORM that we are using. And this, in fact, makes our reusability of our functionality impossible. Because imagine that we have this functionality, this core functionality, and we don't want to use it only from the web perspective, but we want to call it from the CLI. We just cannot. We cannot do that just because the core functionality is tightly coupled to the delivery mechanism. Yeah, a bummer. And then again, if we take a look at that example, we see that there is a lack of the intention. What was that thing that happened in the real world that triggered this functionality? What the user did, or what happened there? We don't know anything about it. We just see some data being passed from layer to layer, from object to object, and then nothing. But why? Why this basic question? We don't know, and then we cannot react because we don't know when this happened. We cannot react on that event. Yeah. So basically, what usually is wrong with our application is that first we are coupling to the delivery mechanism, which makes our code reusability impossible. Then we're coupling to the framework itself. So we cannot just change the framework tomorrow, or we're just tied to that, and that's it. And whatever happens to the framework, we're stuck with that, or we have to rebuild everything, which we all know that is kind of extremely, extremely difficult and painful. Then we have slow tests, which I don't know for you, but for me it's extremely annoying. Every time that you run your pipeline, you have to wait for so much time only for the test to pass. And then we lack the intention, which makes us unable to react on certain events. So how do we deal with that? How can we, in fact, deal with the issue? Well, I have this word. I love that word, one of my favorite words. Well, we decouple. So we can, in fact, start decoupling our core functionality from all these external libraries, all these external dependencies. So let's start focusing on the core of our application. What is the main purpose of our application? What it's all about? What are the use cases that we're tackling here? And then everything else, let's just call it other stuff. And let's not think about them for now. Let's just think of what is the product about and how can we deal with that. The core of the application, people also call it the heart of the application, which might ring a bell for some of you. Maybe you've heard of this book, amazing book, Domain-Driven Design, Tackling Complexity in the Heart of Software. And in this book, Eric Evans states that the heart of software is its ability to solve domain-related problems for its users. All other features, vital as though they might be, support this basic purpose. So let's think about that for a little bit. So basically, the core of our application, our use cases, this is the heart of our application. And our core should not care about all these external elements. They are, of course, they're essential, they're very important, but they're not essential to the main use cases, to the heart of our application. They're just, we can call them implementation details that we can in fact change over time without changing the application itself. And yes, of course, we can think about our heart of the application and our use cases, but we want to interact with that, right? So we need our application to be able to interact with the outside world. So in order for us to do that, we can create a layer around our core, and we can call that layer infrastructure. And now, when we have created this layer to help us interact with the outside world, we can easily say, whenever we want to interact with our application, we have this infrastructure layer. Only that layer understands and knows how to send an email or receive a HTTP request or receive a console command or read or write to the database. Or, for example, only the infrastructure knows how to write to the cloud or read something from the cloud or send message to a queue or receive a message. And that's it. It's kind of easy, right? And then we suddenly introduced layers. Oh, layers are amazing. And they're amazing because first, each layer has a definition. Each layer explains what it's all about. Each layer tells you what its purpose is. And then whenever you have a class, it's very easy to find the specific layer for this class because each layer is going to tell you what to put. And then layers have boundaries and they have rules for crossing these boundaries. This communication between layers is called, in fact, dependency rules. So we have these rules, how to communicate between different layers. And it's very interesting. But when we talk about layer, one layer can talk only to classes and methods within the same layer, or to layers within. We cannot have the communication from inner layer to outer layer. So you can imagine, I can see only things in my layer and things that are inside, but I cannot see anything behind me. And this is a very important rule to remember. So whenever we have a method in, let's say in the blue layer, we have a method A that wants to talk to a method B, which is in the green layer. In order to do that, this method A has to have the knowledge, have to understand what is the name of the method he wants to call, and then the list of input and output parameters. We can say that these parameters of the method B, we can call them message, just a simple message. And if we remodel a little bit our first example, we can structure these parameters in a class, right? We can pass only a single class, a single object that contains these parameters. And then we can even go a little bit further and say that we can use a handle, an anonymous method handle that can handle this message. And this is how we communicate between layers. We just pass a message and let someone handle that message. The same applies for the most outer layer, the infrastructure layer that I was mentioning earlier. So this most outer layer is the one that communicates with the outside world. Let's define a HTTP request that our application can receive, and it will contain a specific message that we define. Then we can define also a console command that we can receive with a specific message. And these messages, in fact, we call input ports for our application. And when we start talking about ports, suddenly our application starts looking more like a hexagon, because each side of a hexagon could be an input or output port for our application. Why exactly it's a hexagon? Well, I don't think that there is a specific reason for that. I think it's just easy to, to be drawn in a picture or a diagram. And yeah, it's just nice, look nice. Imagine the ports of your application like doors. They're just different ways how you can interact with the same application, different doors that you can enter. And of course, you can have output and input ports. And each port can support different protocols. You can have a web input port that supports HTTP protocol, and you can have a messaging output port that you send messages using AMQP. And you can have a lot more for your application, of course, more than the hexagon, of course, that it allows. And basically, the hexagon architecture is, also called ports and adapters. It looks something like that. You define your input and output ports, and you define adapters. And adapters, they might sound, fancy, but they're just translators. Imagine them, they receive and understand the outside world, the messages from the outside world. They take that message, they translate it in such a way that your application is going to understand. And that's it. That's all they do. If we, okay, let's start with example here so you can understand a little bit better. Let's see how our application can handle incoming HTTP requests. Let's imagine that we define an HTTP input port that we're going to receive HTTP request. So we create a controller. So far, so good, nothing new. And our HTTP controller is going to use the request method, most probably provided by the framework that we're using. And thank you, framework, for giving us that. Because all these things that the framework is going to give us, these are things that are going to make our life easier, right? It's going to encapsulate some complex logic that we don't want to focus. So yeah, we have a controller. We receive the web request. We take the data from the web request and we create a command message. We use the command bus so you can pass that message to the core of our application, where we have entities, repository, value objects, a lot of things that lives in the core of the application. And that's it. And basically, in this way, we have defined the port. This example is using Laravel, but yeah, basically it is very similar in most of the PHP frameworks. We defined a port in this example. We have method post and the path is /user, and we're using the register user controller, which is in fact our adapter. And our adapter, well, it just received the request, creates the register user command using the username, password, and email from the request, and just pass the command. So now what we have the command, which is, well, the command is just a message, nothing else. But this command contains the intention. Suddenly we have the intention. We know what we want to do, what the user wanted to do in the first place. The user wanted to be registered. And because the command contains only the information, username, password, and email, now we have the reusability, because we can create the same command from any other place with any other adapter. We just need to provide username, password, email, and we have it. And now we can pass it to the handler to handle it. And yeah, this is our command handler. And maybe you've noticed a little bit in my previous slides, we use command bus. And command bus are one awesome thing. They're used to orchestrate which command handler handles, which command can be handled by which handler. Command bus could be very simple. You can use different libraries for them. Well, it's up to you. And because they live in the infrastructure layer, you can change it over time. So yeah, let's focus on our command handler. Now our command handler holds in fact the use case, the business logic of our register user operation. And our command handler receives the command, creates the user entity using the username, password, and email, and adds our user to the repository. As you can see, suddenly our use case has no understanding, no knowledge of if the command came from the web request or the command came from anywhere else, because we have stripped that away. Also, you see that we're using user repository. We're not working with a specific database or anything. We're using abstractions to add the user somewhere. And if we take a look at how we handle the input port messages, we see that we have received the command in the infrastructure layer. Then we have passed the command to the application layer, and then, but okay, we suddenly have third one. We started with one, now we have three. Okay, so we have two more layers. We added the application and domain, and this was created on purpose because both application and domain layers, they are all part of our core of the application, but they have different purposes. In the application layer, we have the commands and the command handlers. And the idea of the application layer is to execute operations only, to call repositories, to follow the business logic, and that's it. But the domain layer is the one who holds the repository, who holds the user entities, our entities, the value objects. It holds the core, the most inner domain logic of our application. And again, if we go back to our register user command handler, we see that we have, in fact, at the end, we wanted to persist the data that we have created, which means that suddenly our user repository has to, in fact, find a way to persist the data. To do that, yeah, we said the core of the application cannot interact with the outside world. We have to call something in the infrastructure layer for that. Okay, so let's imagine that our user repository codes, in that example, it's an eloquent user repository class, which lives in the infrastructure layer, and this class knows how to write data to the database. Okay, so far so good, but to be honest, there is a mistake here in that picture, and I really hope that you can see that mistake because I make it on purpose. And well, this is the mistake. As we were speaking in the beginning, when we talk about the communication between layers, we cannot allow inner layer to communicate back to an outer layer. Okay, so how can we in fact deal with that issue? How can we reverse that dependency? Well, with the dependency inversion, the other awesome thing. Dependency inversion, how we deal with them? Yeah, we create interfaces. So our user repository, instead of concretion, let's make an abstract thing. Let's make it an interface. It still lives in our domain layer. It is still defined there, but the concretion, the concrete class, the concrete implementation is going to live in the infrastructure layer. And yes, in the concrete class, you can see the eloquent user repository, how it is implemented. We do something. And okay, so then in order for us to inject that concrete class, we're going to inject it in our command handler. So our command handler is going to receive the user repository on its construction. And this is going to give us an awesome flexibility, in fact, because we can now create tons of user repository concretions. We can create, for example, in-memory user repository. And we can create our tests in such a way that they're not going to use the real database. We're going to use the in-memory user repository. And this way, our tests are going to be extremely fast. Or tomorrow we decide that we're not going to use Eloquent, we're going to use something else, or we're just going to switch database to whatever we want. It's all good. We're not going to change anything in our application. We're not going to change the core of our application. We're just going to inject something new from the outside. We're going to just change the infrastructure, something there, and everything else is going to stay the same. Yeah, I don't know about you, but I feel so excited about all this flexibility. So basically, as a conclusion of everything that I've been talking about, what we have with the hexagonal architecture, we have separation of concerns. because we have layers. And layers, they define what is your concern, what is your purpose, how you communicate with people around you. We have clear use cases because we have commands and command handlers. They hold all the use cases there. We have reusability because our use cases, in fact, have nothing to do with the infrastructure anymore. They are stripped from all that. We have fast tests. Yeah, we inject our dependencies and we have extremely fast and awesome tests. Also, Hexagonal Architecture supports DDD, TDD, BDD, all DDDs that you can imagine. It supports event sourcing. Well, basically everything that you can think of. Hexagonal Architecture, we're gonna support it. I promise you that. And yeah, basically, I can tell you that I love it. I really hope that if you have the chance to touch it, most probably you're gonna love it as well. So thank you, and yeah, thank you.
I'm Mike. I was busy. I'm sorry. I just want to say thank you for your presentation and everything, and I really like your passion. Oh my word, girl, that's awesome. I love how you say I like it, and I also like how you're excited about it. That's what really makes That's what really makes a successful architect, because you have to get everybody to capture your vision. And I really loved your presentation. I was listening in, and you did an amazing job, because it caught me. It caught the vision, going like, oh yeah, she's right. The interface and going in, and so it was super amazing. So
yeah. Thank you.
Oh yeah, you got anything to say, real quick? I mean, we got a few minutes, and you know, do you have anything to say?
Well, I don't know. I'm still very excited about all this, and yeah, I'm really grateful for giving me this chance to share with you, and I'm really in love with the hexagonal architecture, and I really hope that everyone who was attending felt that. And yeah, let's see. Maybe more people are gonna join the code.
No, and I get it. I really do. I get it, because it's really, okay, this is a really bad analogy, but it's sort of like COVID, right? I mean, it's really contagious, but with the enthusiasm that you have, I mean, it's important. Okay, so here's my question. I don't mean to throw you off. How did you get such a passion? How did you get such a passion and enthusiasm about what you do? Because I think everybody out there really needs to listen to this, because you got to have this, because when you get in front of your management, and if you don't have that passion, it's really hard to convince them.
Yeah.
Right? Yes. Yeah. How did you get that passion?
Well, first, I think I was kind of born with that. I mean, kind of, yeah. And then, you see, I mean, over time, I've seen a lot of things, a lot of approaches, sometimes, you know, even on the same issue. But at one point, when you see that for years you've done things in one way, that you think, okay, this is the way, because the right way, right? And then suddenly you see something, and then, oh my God, how stupid was I? Then you see, people, I want to tell you this because I found it. Please don't waste years. Please save. I want to save you some time. And maybe next, I mean, you're going to share that with someone else, and you're going to save them some time. Because, you know, software development, you know, you start always with, yeah, we want this small thing. Please do it very fast. And then, yeah, we want something else, and then something else, and then, but let's add this. I mean, it's very easy. Please add that one. And if you haven't done your job good at the beginning, then you start with, bleh. It's very difficult. You say, oh, it's complex software. It's not complex. Software development, it's easy when you have good fundamentals. That's why I want to know people just to yeah, to share, because I've done things a lot of times in a, I mean, let's not say good, bad way, but in one way. Then I've seen that there is another way. And maybe tomorrow I'm going to find another way. And then I'm going to share that as well.
Right.
And hope someone else is going to share something with me. So, yeah.
That is so awesome, because I'm sitting here going, yes, I agree. Because I'm the same way as you. It's like, I don't know. I mean, and then how about you can probably relate to this, right? So you developed this really super cool architecture, and then you go to somebody and go, look what I did. I connected this and it works. And they're like, wow, that's pretty amazing. You're like, catch the vision. You want to just grab them and you want to say, it's the neatest thing, right? Can you relate to that? I mean, it's crazy. It's, I mean, and so it's vital, isn't it? I mean, I can tell you have a lot of that experience, and then what you do is just try to get the vision out there, try to get everybody to catch it, because it's really important out there, isn't it? I mean, how do you deal with all the technologies? Oh my word. So we haven't even touched that one. So tell me, how in the world do you deal with those kind of technologies?
Well, I don't know. You know, usually it is just like you listen to someone saying something that, okay, it sounds interesting. Let's dig this up a little bit. Or if you're lucky, you have a colleague or colleagues that, oh, do you know, I know this thing, let me share with you, read this book, or, you know, and then you get fascinated by it and you get excited and you start, I mean, and there's so many new things nowadays. And at one point you say, yeah, I know this. And at the point that someone tell me I know something, that means, you know, nothing. Most probably there's something, And then I remember when I was, you know, reading the beginning about hexagonal architecture, I was thinking, okay, I've heard this like 10,000 years ago, right? It's nothing, basically it's nothing new. I mean, it's just put in a nice, in nice words, you know, presented in a nice way, but the idea was there years back. How we didn't catch that at that point? We were still doing things, you know, in a bad way. Not bad, but in a different way.
Understand?
I mean, things are there. They just evolve, and it's good for you to listen. Basically, I think this is one of the most important things. Listen, and then. Because, you know, IT geeks were fans of Star Wars, usually. For me, absolutely.
And Lego Star Wars, don't forget it. Lego Star
Yes. So there was something that Master Yoda said, because Master Yoda is the master. You must unlearn what you have already learned. This is the thing. You always have to unlearn and unlearn and unlearn, because at the point when you see that you know, most probably you don't. So unlearn and start over. Because our ego is the one who is, you know, not helping us for sure. For sure.
No, and I'm in agreement. You see me going, because I'm remembering lots of people that I would have to convince. I mean, they're like, but it works. And I'm like, it don't work. I mean, you know what I mean? Whatever the architecture. And I would go like, what happens if, I don't know, this is tightly coupled, I'm just saying, and you move that thing. Oh, we didn't think of that. And so that's where the beauty, right, of architectures and reusing APIs, like you showed in your presentation. And you have to convince people of that. And it's exactly like you said too. I like what you said, to unlearn, right? Because so where I work, there's a lot of people that have been using the same thing for like 20 years. It works great.
Yeah, it works.
It works.
It works. Why change it, right?
Yes, exactly. But then you have to sit there, I touched that one, didn't I? Because it's true. Because then you have to just make them realize, but there's a better way to do it. There's a better way. And in today, the demand for the data or the demand of this information, I mean, it's just so different today. I mean, can you give me an example? I mean, we're going to just a few more minutes. I'm sorry, put you on the spot. Give me an example of something that you had where you had your management and you had to convince them or something. I don't know.
Oh my God. So
I know it's a lot.
Well, tons of them. Well, usually I can't think of anything specific now, but usually it comes to okay, let's do it this way. But okay, but why add this complexity? Usually people go with that. It's too much complex for something so simple. Oh my God. And then, okay. And then you start saying, it's not complexity, you know, we need to make things decoupled as much as possible because you never know what's going to happen tomorrow. No. We want simple. No. There was this project. Oh my God. I remember I was talking to the managers and we want this thing only for one tenant, only one client we have. And we were telling him, are you sure? Because we know what is the usual things in our company. Most probably you're going to want to sell it to another tenant tomorrow. No, we don't want that. We are going to sell this only to that people. At the end, I say, okay, I'm still going to leave a door open here. But, okay, a year later, we implement everything. It was working. Okay, now we want to sell it to another. Please copy that and paste it to sell it to another. No. So yeah, it always starts like simple. We want simple, and then please make it. I mean, it's just that simple thing. Just add it another tenant. I know you've done it before. Do it again.
Expectation on you.
And when you say a few months of changing. Why? It's so simple. Copy paste, guys. Why are you crazy developers? Management.
Yeah. Oh my gosh. I'm here to go. Management. It really is. And you got to have the right personality to deal with them. So I worked with interns before, right? And they come in and they look. I'm sure you get like new employees come in your company, like developers, and they're like, "What the heck is this thing? Is so complex." And I always go, draw a little box in this little box, and then connect them together. Do a Mickey Mouse or Star Wars Legos, right? Connect them together, and then when they understand that, then you go on to the next and the next, and you have to do that with management. When you present it to them, I get it. This is a huge sequence, UML thingy, architectural thing, and what am I looking at? Let's break it down. And then when you break it down to them, and that's our job, right? And they're like, oh, I get it. So I can totally relate.
Well, you have to make it simple because, you know, even for other developers, you might have to find the right words to speak to right people and the right emotion and the right everything. Some people you have to use, you know, technical words and terms, but for other you have to use emotions and find your right words. Maybe the first time you're going to fail, most probably. The second, the third, fifth. At one point, you're going to find a way. And there is no one rule, you know. It depends on who you're talking, how you're talking. And but this is how we learn. Today we make a mistake, tomorrow, you know. And that's why we read books and listen to webinars. Maybe someone is going to give us the answer there. Because, it is. It is the world we're living. We love the management. We have mixed feelings, with the management, but it is there. We can't live without it. We have to find, and then they have mixed feelings for us as well. So, but at the end, we are all aiming for the same thing, to make a good product. We have to just find a way to explain so everyone can be on the same page.
I gotta let you go. This has been a great conversation, and thank you for your time, for your presentation, and the time you took. And I'm gonna leave everybody my LinkedIn. Please connect because I really like your enthusiasm and your energy because I feed off that. So I gotta let you go. Thank you so much for this. It was wonderful having you here.
Thank you. Thank you.
Bye-bye.
Bye-bye.
Yeah, bye. Okay, I think I'm ready for my next person here. How's it going, man? How you doing?
Good. How are you?
Oh, you know, hanging in there. So what are you going to talk about today? What's your exciting presentation for us? I can't wait. So tell us about yourself.
Well, myself, so I won't talk about myself. That's not interesting to anybody except probably my mother, in case she is logged on, but I doubt if she has.
Hey, Mom.
What I'm going to be talking about today is the first third of my most recent book, Fundamentals of Software Architecture, which is non-functional requirements, or what we call architecture characteristics, and the importance of those in software architecture.
Great. Well, you know what I'm going to do without further ado? I'm going to go ahead and bring in your slides that you have here. I'm going to get off stage and you have it. Have a wonderful time.
All right. Thank you, Michael. Thanks for joining. Welcome, everyone. Today, I'm going to talk about, as I mentioned, the first third of our book, Fundamentals of Software Architecture, in what we call architecture characteristics. And I'll talk a little bit about what I mean by that in just a second. Now, this really focuses on the structural design aspect of software architecture. So software architecture is a very broad subject area with lots of facets, lots of interesting little side channels to go down. But definitely one part of the job of a software architect is this kind of structural design. And that's what I'm going to talk about today. And I'm going to talk about one important facet of that idea of structural design. So let's talk about what we mean by architecture characteristics. So let's say that you have a problem and you decided, I'm going to write software to solve this problem. So you have a problem of some kind. We refer to that as your domain. And so certainly you're going to write, design the structure of your software around that domain. But that's not the only thing you have to think about as you think about that piece of software. You also have to think about a bunch of these other things. Things like reliability and availability and performance and scalability and elasticity and deployability and testability and modularity and a host of other important things that what we call architecture characteristics. Some people call these non-functional requirements. We don't care much for that name because when you call something non-functional, then it's hard to get people interested in it, like managers and people like that, because you've already admitted that it's non-functional. We don't like cross-cutting requirements. We don't like the word requirement being in there because it gets mixed in with user requirements. You also hear them called system quality attributes. We don't like that name because it implies a sort of after the fact, sort of a QA perspective on these, when in many cases, these are some of the first things you have to do, which I'll illustrate here in just a moment. So we chose the term architecture characteristics. Whatever you call them, this is one of the important things you have to think about when you think about software architecture. And there are at least 4 complicating factors as you start considering these in the software architecture world. And the first of these is that these architecture characteristics are synergistic, both with each other and with the domain that you're writing code for. In other words, you can't really change one of these without potentially and often probably affecting other architecture characteristics and or your domain. For example, if I want to improve security, I'm probably going to have an impact on performance because now I need to do more on-the-fly encryption, more indirection for secrets hiding. And so very often these characteristics are synergistic with each other, meaning that it complicates your design the more of these you need to support. And I'll talk more about that in just a second. The second problem with them is that they are ill-defined. Certainly as an industry, we've done a terrible job of trying to define what these things are. There have been some attempts. The IEEE, the Engineering Society, the International Engineering Society made a stab at codifying a standard list of architecture characteristics back about 20 years ago. And, you know, shockingly, when they put that list together, they didn't say anything about the cloud or Kubernetes or containers, or of course they didn't, because those things didn't exist 20 years ago. It's impossible to create a permanent catalog of architecture characteristics in an ecosystem that's constantly changing and evolving, like our ecosystem is constantly changing and evolving. And so there's no use in trying to nail down the final ultimate list, because next week and tomorrow and the next hour, a brand new one will come along, because new capabilities, new requirements will come along that drive these things. Having said that, there is a very useful exercise to be had within your organization to codify exactly what you mean when you talk about architecture characteristics. One of the very influential books for software architects over the last few years has been the book Domain-Driven Design by Eric Evans. One of the things that he defines in that book that's not even software related, but more communication related, is this idea of a ubiquitous language that everyone on a software project, when you talk about software related things, you should make sure you're using exact technical terms to talk about those things. I believe it's important for an organization, for the architects within that organization, to develop their own ubiquitous language as they talk about architecture characteristics. So when one architect talks about performance, you know what they're talking about, versus one talking about one kind of performance and another talking about another, and talking at cross purposes. So locally, you can help define these, but there's no way we'll ever create a good comprehensive list as an industry, because there's too much flux and too much change driving the definition of these things over time. The third problem is there's lots of these things you could support in architecture. Here's a partial list from Wikipedia of what they call system quality attributes. But this is always going to be an incomplete list. One of my co-authors in the Evolutionary Architectures book, which I'm actually going to be talking about later on today at this very conference, one of my co-authors, Rebecca Parsons, talks about architecture characteristics and working on a project where the mandate from the client was a centralized design, but every time they showed a potential design to them, the first question they asked was, well, what happened if we lose Scotland? Because it turns out years before there had been a freak communication outage and they'd lost communication with their Scottish stores. And that became one of the first concerns they had with every new architecture, is would it withstand a similar kind of outage? So much so that the architects on that project created an architecture characteristic that they call Scotlandility, which is a combination of redundancy, caching, and availability that would solve this problem of a temporary outage between their stores. And so the point of this is that any architect at any time can create a new one of these architecture characteristics just by adding ility to some term, and it magically becomes an architecture characteristic. So as I said, there are a lot of these things, but even the number of categories have gotten larger over time. Because 10 years ago, architects didn't care that much about what happened in operations, because we designed architectures that were very independent of a lot of those operational concerns, which are very constrained in those days compared to what we have now. But with modern architectures like microservices, things like elasticity and on-demand scale are really a collaboration between architects and operations and DevOps and cloud providers, and that requires a much broader perspective from the architect standpoint about those things. So not only have the number of architecture characteristics continued to grow, but even the number of categories of them to continue to grow over time, which of course makes everything that much more complex. One of the things that Mark Richards, my co-author, and I wanted to do in our fundamentals book was come up with some good modern definitions for some of these concepts. And we couldn't find one that we really liked for architecture characteristics. And so we codified a definition that's in 3 parts. The first part is it specifies a non-domain design consideration. So that's that split that I talked about before between the domain part of the design and architecture characteristics. And the union of those two design efforts is really a software architecture solution for a particular problem. The second part of this definition is that it influences some structural aspect of the design. So what we're looking at as we look at architecture characteristics are things that require us to design around them structurally. But some things can be either architecture or design. So for example, security is a good example of one of those. I can either write a special hardened service as part of a distributed architecture, but even within a monolithic architecture, if I have good code governance and good coding hygiene around salting and hashing and encryption, et cetera, then the design of my code can offer the same kind of protection that an architectural solution can. So what I'm looking for here are architecture characteristics that either give me an option for an architectural solution or will prevent another particular architecture solution. So does it influence some structural aspect of the design? Then the third part is critical or important to application success. This is really a filtering criteria because a few slides ago I showed you that big 3 columns of architecture characteristics. You and your fellow architects, if you really wanted to waste time, could probably go to an ivory tower somewhere and create an architecture that supports almost every one of those and deliver almost no value to your organization. So this is really an effort to try to say, support as few of these as possible to be successful. One of the common pieces of advice that you always get is to favor simple design in architecture, but nobody ever tells you how to favor simpler designs in architecture. Well, here's how. Don't support things you don't need because of the synergy between these architecture characteristics. By definition, the more of these that you support, the more complex your design is going to be. And so part of the skill of an architect is not identifying as how many of these you can support, but rather how few of these can you support and still be successful. Now, overlaid on top of these 3 pillars is this idea of implicit versus explicit architecture characteristics. Explicit ones are ones that are written down specifically, like a certain expected number of users or certain level of scalability. But there are also implicit architecture characteristics, things that you design for and know you need to support, even if they're not specifically written down. Security, again, is a good example of one of those, because even if it's not specified, you know as an architect that you shouldn't create an insecure solution of some kind. But internal architectural code quality is also a good example of one of those, because as an architect, if you create a solution that barely limps its way to its release date and it's impossible to maintain or update, then you haven't been successful as an architect. And so building and maintaining good internal design is important, which is really around governance, which I'll talk about just a little bit later. That really is the foundation of the idea of specifying these architecture characteristics. The domain rests on top of these architecture characteristics. And we design this as sort of an unstable pyramid on purpose, because we're implying here that these are all things that are leaned against one another and trading off against one another. And so one of the things that we are fond of saying is that what you're striving for when you create a design in architecture is not the best, because that implies that you've managed to maximize everything and there are no negative trade-offs. Instead, what you're shooting for is the least worst design. In other words, what's the least worst combination of all these things that they fight each other least, which is often your best outcome for complex architectures. It's really important to determine these architecture characteristics. In fact, there are basically 2 steps required if you are confronted with a brand new problem that you need to design architecture for. One of them is going through an exercise and determining what design the domain needs. And another is an exercise to determine what kind of architecture characteristics you need to support. You have to do both of those things. You don't have to do them in any particular order. You can do them, in fact, in parallel, although a lot of the same people are involved. But it's important to do that because at some point you need to make a choice about what is the most appropriate architecture style we use as a starting point to implement this solution. And the architecture styles are things like microservices or microkernel or service-based architecture or pipes and filters or event-driven architecture. That's the entire second part of our Fundamentals of Software Architecture book. And so that's why it's important to understand the architecture characteristics, because if you don't understand those, then you can't really choose a style yet. It's the classic example of putting the cart before the horse, because each of those architecture styles, one of the things that distinguishes them from one another is a sort of default relationship around architecture characteristics. For example, microservices are very well known for giving good scale and elasticity, but sometimes suffer and need to be tuned if you want better performance. Monolithic applications are well known for simplicity and create high-performing applications, but don't tend to scale very well. And so each of these styles has a sort of default behavior, mostly around the way they support or don't support different architecture characteristics or combinations. For example, if I have really fast time to market as one of my biggest drivers, so let's say I'm in a startup that's using angel investing funding, and I need to get to market as quickly as possible, feasibility might be the architecture characteristic that is most important. And so I'll try to go toward the simplest architecture I can to be able to get to that date, because I don't have the time, the resources, or the money to build a more elaborate architecture. If agility is one of the biggest drivers for my architecture, then I may choose a style like microservices, which gives you really decoupled services, which allows a very fast rate of change at a very tight level, which allows you to evolve very quickly. There are specialized architectures like a space-based architecture, which is chapter 15 in our book, around handling extreme elastic situations like 10,000 new people showing up at your website within a half a second. There are specialized architectures for that. And if that's one of your drivers, you may choose that style. If you need a combination that's hard to achieve otherwise, like scalability and performance, you can go to a very low level, fairly complex, but very malleable, very bendable architecture, like an event-driven architecture. And so each of these are different kind of built-in combinations of these architecture characteristics. So let's talk about a few families of these things, because there are a lot of architecture characteristics. It's basically anything in your application domain that architects care about and are outside of the problem domain. And there's one family, one category of these that are particularly important, which are these operational architecture characteristics. These are ones that overlap with DevOps and operational concerns. Things like, for example, performance is a great example of one of these, because the way you design the architecture impacts performance, but also the way operations supports it, affects it, and also dependent components like databases impact things like performance. So those are integration points. And so you might want to measure, for example, average response times, request and reply. But this is a great example of dipping your toe into the ocean of how nuanced performance can be, because if you only track averages, then boundary conditions may be causing a problem that you can't even see because because it drowns in the average. So you might also want to check boundary conditions to make sure that configuration errors or something are not causing unusual problems. There are a lot of interesting tools available, and of course these keep coming out year upon year in our ecosystem, and better ways to think about and measure things like performance. This is from the Google ecosystem, their tool Lighthouse, which lets you measure particularly web-based performance on mobile devices. And they measure some interesting metrics like first contentful paint. That's the first time your web page shows life basically on a mobile device. And that's a really important number because, as you've probably observed, most users have the attention span of a gnat who's been drinking caffeine. And so unless you show some sign of life for your website, then they'll likely just move on to a different site. And so first contentful paint, a time to interactive is when they can actually start using your site. But the probably most interesting thing about this is in the upper left-hand corner. This is an emulated Nexus 5X mobile device on a simulated slow 4G network. And so one of the problems we often have is that developers and architects and QA people have much more robust resources than your typical user. This allows you to do automated performance tests because you can do these lighthouse tests using Node. You can automate these kind of performance tests to see what kind of real world impact you might have. And so this is a much more nuanced way of measuring performance. And of course, tools like this continually come around, and the value of some of these measurements depend on market and depend on changing demographics. Most people consume websites on mobile devices now, so that's becoming more and more important. Another good example of one of these operational architecture characteristics is scalability. The ability to support a large number of concurrent users with some sort of at least reasonable performance characteristics. A similar one is one I mentioned before, elasticity. This is bursts of new users all of a sudden. Elastic solutions are often also scalable, but scalability doesn't imply elasticity. So if you're a hotel booking site, you may have a nice consistent number of users at any given time. But if you're a concert ticketing site, you may see these massive bursts like this. There are also process architecture characteristics. As I mentioned before, anything that really impacts architecture or the software development process. But this is a good opportunity for me to talk about architecture characteristics like this. Agility. Now it has the appropriate ility on the end, so it must be an architecture characteristic, right? But if somebody comes to you and says, we want you to build an agile architecture, what does that mean? Well, this is a good example of what we refer to as a composite architecture characteristic. Remember I said before that one of our goals in this world is to come up with objective definitions for these architecture characteristics, because objective definitions helps you drill down on these and get to things you can really measure and ultimately govern. And of course, there is no objective measure for agility. But now you can think about, well, if this is a composite, what does agility consist of that I can measure? And so one of the goals of agility is fast, efficient deployments. Deployability. Oh, I can measure that. Measure and track an hour spent to deploy things, measure and track failed deployments, measure and track frequency of deployment. Is it getting faster over time? So these are all things that I can, in fact, measure. Testability is something that I can also measure. I can measure things like test coverage. Now, of course, any metric can be gamed, and you have to watch out for that as part of any governance, but this can be measured as well and assessed as to how effective it is. But really what they're asking for when they're asking for agility as an architecture characteristic is modularity and good internal architectural modularity. Because think about two solutions. One is basically a big ball of mud talking to a relational database. So think a simple PHP application with no real internal structure, event handlers wired directly to databases, or the same with a JSP or an old school ASP or an ASP.NET application. Think about trying to deploying a single part, make a change and deploy a single part. It's really tough because it's really hard to predict what sort of rippling side effects that change may have, because everything is connected to everything else. Contrast that with a modular system that has really good separation between components and very good, well-maintained modularity. It's very easier at least, to make a small change there and have confidence that you can test a small part of it and not have affected another part. And so having good internal modularity is a really nice characteristic to have. And so let me talk about just a few of the things that you can measure internally from an architecture standpoint. One of the things that is, so I spent just a very short amount of time in university studying mechanical engineering, both statics and dynamics, which is the study of things standing still and then the beginnings of things in motion. And that was enough to convince me to go to computer science. But what I realized by my time that I spent in the mechanical engineering world is they have a lot of really good measure and math and metrics, and we don't have those yet in the software world, but we do have a few that I'll talk about, a couple of them. And one of them, of course, is around coupling and how components are coupled to each other. And there are, so back in early 1980s, I think 1983, this book came out, A Structured Design. I know this may have been 78. Anyway, around that era, A Structured Design by Jordan and Constantine looked at structured programming, which is functions and procedures with parameters that call each other, and realized that was really a call graph, and defined a number of levels of coupling in software, which are demonstrated here. Now, to give you an idea of how old this is, pathological coupling, the worst kind there on the left, your language won't even allow that anymore. This is why you have encapsulation in your programming languages now. And while this is an interesting kind of list, data coupling is the by far and away most common one we use, because that's how you pass. This is parameter passing. This has nothing to do with databases. This is before they really were thinking much about that. This is a parameter passing and passing things, function calls, etc. But on top of data coupling, they also defined two useful bits of coupling that are quite useful to us even today. And most systems are still component-based. One of them is afferent coupling, which is the number of incoming connections for a component. Now, they were borrowing graph theory terms, which is why these two terms are so terrible. Afferent is one of them. They should have called this incoming coupling because it's the number of incoming connections. The other is efferent coupling, which they should have called outgoing coupling because it's the number of outgoing connections for a particular component. But even just these measures by themselves are useful. There are several tools. This is an example of an Independ, which is a tool, a commercial tool in the .NET world. There's a similar open source tool in the Java ecosystem called JDepend. And basically what this allows you to do is see the efferent, or combined coupling of components, or in this case, namespaces, because we're in the .NET world, to each other. So you see in the list of namespaces there on the left, and corresponding, the same numbers along the top are the same ones along the column in the middle there. And then the intersection is where these two namespaces are wired to each other. And so this is really useful if you are, for example, doing an architectural migration. And I have this address class that I need to figure out, should this be broken apart or should this be coupled to? How many places use this address class? Well, a tool like this will actually tell you. Even though these are very old measures, they're still quite useful. And for example, like I said, there are tools in just about every ecosystem that will give you these metrics. There are a couple of other metrics you can get as well, also supported by both Independ and JDepend. These were actually defined by Dr. Robert Martin, known colloquially as Uncle Bob Martin, in a book that he wrote about C++ and code analysis in C++. And these are, there are a couple of metrics and a drive metric that are interesting. They tell you interesting things about the balance of some interesting forces within a code base. So this is abstractness. Abstractness is the sum of abstract elements over the sum of abstract elements plus concrete elements. So abstract elements here are things that don't actually execute as lines of code. They're there to help you understand the other code that's there. So these are things like class definitions, abstract classes, interfaces, etc. So you can think of those as things that make it easier to understand the rest of your code. And the way to think about this is in the degenerate case. So think about if you had an application that had 10,000 lines of code and it was all in one main method. So you basically have one abstraction there and 10,000 plus one on the bottom. So you basically have 0 abstractions there. So that's one of the Uncle Bob metrics. These are all in clean architecture, by the way. The second one is instability. Instability uses our friends from before, afferent and efferent coupling. This is the ratio of efferent coupling to the combined efferent and afferent coupling. So again, the useful way to think about this is with an example. So let's say afferent coupling is 2, and in one case, efferent coupling is 3, and in the other case, it's 0. In the case where it's 3, we're going to have some sort of fraction here. But in the case where it's 0, the result of this is going to be 0. So what are we really measuring here? Well, so instability is the possibility that if you reach out to another component and it changes, then you may have to change as well. And if you reach out to no other components, then you don't have to change. But that also means you never delegate work to other components. And so big monolithic things have little instability, but they don't have a good balance because they have too much duplication, for example. So if you take these two metrics together, this gives you the distance from the main sequence metric, which both independ and JDepend will give you for an existing code base. And this is a compile time metric that it figures out. So if you take an individual component and evaluate its abstractness and instability, it's a point in space. Distance from the main sequence is the perpendicular distance of that line that you see there. Okay, so what is that telling me? Well, it turns out that things that fall near that line have a good balance between abstractness and instability. Notice that the more abstract it is, the more the less unstable you need it to be, because otherwise it gets too hard to understand. And so if things fall too far up and to the right of this green line, then what you're running into is too much abstraction and too much instability. And so things are very hard to understand there because everything is so abstract and there's so much indirection that it becomes difficult to understand. If you go to the opposite side, you enter into what's known as the zone of pain, too little abstraction and too little instability. So what do those code bases look like? Well, these are code bases that have a lot of big giant methods in them with too little delegation, which is measured by instability, and too little abstraction, meaning you don't have enough abstraction to help you understand the rest of the stuff. Here's an example of running distance from the main sequence on the in-unit testing library in the .NET ecosystem using the independ tool. And you'll see that MOX has crept up toward the zone of uselessness. More troublingly, the framework code has crept down into the zone of pain. And so if I were presented with this as an architect, one of the first things I would do is go in and refactor some of this code to clean up some of this dysfunction that's showing up here in our code base. So let's talk about where these things come from, where the sources for these architecture characteristics come from. One is inherent domain knowledge. If you're in the finance world, then you probably know a lot about finance and you get a lot of knowledge from there. Another is environmental knowledge, things that are happening within your company and your organization and how they respond to things. A third is from requirements from your actual users. So our business is constantly changing to meet new demands in the workplace. Excuse me. That means things like extensibility and maintainability, agility, etc. Due to new regulatory requirements, it's imperative that we complete end-of-day processing in time. So those are things like performance and scalability, availability, etc. We need faster time to market to remain competitive. Those are things like maintainability, agility, modularity. So you have to decode the things that people say generally within your organization, including things like that may drive decisions like integration architecture and some other decisions like that. A lot of this is another problem that you often run into in this world is this problem that's exemplified by the F-16 fighter jet, which when the U.S. Navy came to the Air Force, they said, we need a Mach 2 aircraft. And the Northrop Grumman, the aircraft builder, said, okay, or Mach 2.5 aircraft. And they tried to build one, but couldn't. It was just too complex to build at that time. And so they went back to the Navy and said, why do you need a Mach 2.5 aircraft? And they said, well, we want it to be able to escape in a hurry if it needs to. Knowing the real requirements, what they gave them was this plane, which went Mach 2, but it would accelerate fast and it was really maneuverable. Very often you get users who bring you solutions rather than requirements, and it's your job to go back and figure out what the actual requirements are for them. And so when you look at explicit requirements, part of what you do as an architect is go through and understand the parts of the solution that will lead to particular architecture characteristics. Online auctions, real time as possible, availability, reliability, performance, scalability. Sometimes you're lucky and things are written down for you. And so this gives you some clues as to what you might need to support from an architectural standpoint. But it's important here as well to understand that, so if you go through a domain exercise, for example, for going, gone, our example little kata here, if you go through a domain exercise, what you'll discover is something like bid capture here on the far right is used by both the auctioneer and the bidder. But if you look at and analyze the architecture characteristics in addition to the domain, remember earlier I said this is a combination of the domain and the architecture characteristics. If you go back and look at the architecture characteristics, you realize that auctioneer capture and bid capture need separate behaviors within the solution that you create for this architecture. You can't just get by with a single bid component because even though they have the same domain behavior, they need separate architecture characteristics to be successful. So it looks like I'm just about out of time, so I will save any further questions. I've got a little bit here about automation or governance, but I don't want to stay in the way of the person who's here after me. And so I'll answer any questions you might have in the Q&A session.
Thank you, sir. Thanks, Neal. I do have, let me pull this up. I do have one thing to say. When you showed the F-16, so I was in the Air Force before, right? And so there was this battle between F-15 and F-16. I think you know where I'm going, right? And the F-16 guys, man, we had the super bad fighter maneuverability. The F-15 guy goes, well, we got 2 engines.
Good point.
Sort of like architectures, right? Because when you were giving your presentation, I was like, that is so super cool. And then I thought, yeah, back up, hello, 2 engines at 15. So I thought it was really funny. I thought that was really cool. Thank you so much for your presentation. It was awesome. You had me fired up and inspired. So much information. And I guess what? I'll see you in the Q&A in a few minutes or something like that. So thank you, Neal, so much. I appreciate it.
See you.
Okay. Yeah, sorry. Oops, I didn't mean to. Adrian, what up, bro?
Michael, how are you? I must say your burst of energy is a welcome here at 5 in the morning in Wellington.
Dude, it's my muscle, man. Yeah, I know, that's right. I forgot the time zone. So everybody out there doesn't know, me and Adrian kind of know each other, right? Because
we go way back.
Way back,
the
bro.
last conference.
World War II. Oh man, okay, I'm done. Let me stop. Energy, slow down. What do you got for us, Adrian? What are you gonna tell us today? What are you gonna show?
Roles and responsibilities of the architect. So
really,
yeah.
I
Does
saw.
does that sound dry enough? I mean, you know,
Oh, dude,
are the
no,
excitement levels
no,
going to be high enough?
no. But I did see the one word in your thing. Let me read it. I just got it. Okay, come on, bro. What? Listen. Be a responsible parent, responsible of the architect. I was like, parent, whatever. This is gonna be so super cool. So hey, I'm gonna get off stage and go get fired up some more, and I'm gonna bring in your slides if I can find them here, and I'm gonna kick it off. Adrian, man, I'm so glad you're here, bro. You got it. Just go with it, man. You're.
Thanks for that, Michael. I know that you're not with us on screen, but you're definitely with us in spirit. Yeah, being a responsible parent, there's a lot of ways you can describe being an architect, and one of the more simple, fun ones I've heard was that being an architect is really just giving parental guidance. You're on the project, you're just kind of babysitting everyone else. So before I crack into this, I've got a bit of an ambitious deck. We're not necessarily going to get through all of it. The key thing to remember is that the deck and the two resources I'm going to give to you guys, they'll be available online. You'll be able to go through them in your own time. You'll be able to contact me offline, you know, with any questions you've got. So don't worry if we don't drain every slide or we perhaps skip over a couple. Okay, the resources will be there for you. So in terms of who I am, I played with Lego since I was quite young, and I'm a consulting architect with Middleware New Zealand. So I basically go into different companies and do solution architecture for them, which I find a lot of fun. So why are you here? I know I'm the last presentation and the last block, so I'm the last thing that stands between you and getting on with your lives. So, but why are we here? So basically understanding what you were there to do is foundational to success, right? If you don't know what your roles and responsibilities are, that's not going to work well. So what's in this for you? So I've got a practical guide for navigating solution architecture's roles and responsibilities. I've got some fine-grained info on what you're responsible for at the task level, which is not something you'll find a lot of online. How that may vary from situation to situation, understanding why the architect's responsibility is so changeable, and some resources you can take away. So let's crack into that. So first of all, the problem space. So as a solution architect, you tend to operate within the scope of a project. That project is there pretty much to deliver one or more systems, though that delivery happens within the construct of a software or system or solution delivery lifecycle, which therefore means that the SDLC drives a lot of what you do as an architect. So if we're going to look at the roles and responsibilities of an architect, the SDLC might be a good place to start, but there's a little bit of a catch with that. So this is a screenshot from the systems development lifecycle page on Wikipedia. And I don't know if you've noticed, but in the blurb there on the front screen, they've got that there's usually 6 stages to the life cycle. That's positioned next to a diagram which shows 5. And if you scroll down, they've got an SDLC which shows 10 stages. So not very consistent message, right? And anything to do with solution architecture tends to be a lot worse. There's even more confusion. The key takeaway here, though, is you shouldn't worry about so much what different articles describe the specific stages as being. The key thing is really just to think about the principles that drive the SDLC. Why are you there? What are the key things that need to happen, regardless of how people sort of frame that up. So don't worry about that too much. But the SDLC is a good guidance for us, and we'll use that later. So some of your responsibilities are pretty clear. So solution architecture, you're there to define and develop the architecture, make sure it's well communicated and understood. That's pretty clear. Others are a bit more murky, so developing the high-level design or interface specifications. Is that your job, or the developers, or the tech leads? But why is that? Why is this a problem? So there's a bunch of drivers that feed into the confusion. The first is organizational size and maturity, which I'll talk a bit more about in a second. You've got different methodologies in use. So we've got waterfall, Scrum, Safe. You have people working within a project, which is traditionally how most people tend to work. You've got the rise of product, of course. So you've got people working now in product teams, and variations on that. Not everyone does waterfall the same way, and I think we can all be pretty sure that no one does agile necessarily the same way. Within the solution architect role itself, or indeed software architect, there's not, well, I've found there's not really a consistent level of understanding with everyone as to exactly what the role means. So that sort of feeds into it as well. And then you've got organizational politics and human nature. So, you might be in a place where, you've got a middle manager who's quite strong politically. They've got sort of their fiefdom that sort of can sometimes warp the natural order of things and, who does what, because they're trying to protect their turf. It doesn't happen often, but you do come across it. So, but organizational size and maturity, that's a lot more important. So the thing about organizational size is that tends to drive role focus and how specialized you are. So large organizations tend to mean having more specialization. There's less need for you to wear many hats, and you can be more focused on your responsibility. Small organizations, obviously the opposite. With organizational maturity, that maturity drives role clarity. So how consistently the role is understood. So what I find with more mature organizations is that everything's much more well developed in terms of their processes. Things are much more clearly defined. That impacts on how clearly your role is usually defined. There's greater clarity all around. So current art. So this is the career track, right? So what we're pitching at here is people who are aspiring architects or new to architecture or want to learn more about sort of the fundamentals of architecture. So if you're coming into that space and you want to understand what your roles and responsibilities are, where could you currently go online? What could you currently find? So you've got TOGAF. So TOGAF is an is an enterprise architecture framework. It's quite a popular architecture framework, but it is at the enterprise level, not at the solution level. So a little bit high level. Now they say, and I'll just quote them here on the left-hand side, solution architect has the responsibility for architectural design, documentation at the system or subsystem level, such as management or security. A solution architect may shield the enterprise or segment architects from unnecessary detail of systems, products, and technologies. And that's about as specific as they get. So if you're coming into solution architecture, you want to know what it does, you find TOGAF because people say, hey, TOGAF's a good framework. It's not necessarily going to help you that much. They do have an architecture skills framework. Now that is pretty good. They've got a bunch of charts that look like the one that's on screen that describes various roles, areas of in IT knowledge. The only problem with that, if you're a solution or a software architect, is that this is pitched, as I said, much more at the enterprise level. So you see you've got architecture data architect, you've got architecture board members, and then you've got stuff down like networks, IT infrastructure, and systems and COTS, which is, those are very generic terms. You kind of know which bit of the universe they're talking about, but it's still a bit high level. So that's not really of practical help. It's interesting, but not necessarily helpful if you're trying to figure out what you do day to day. You've got SAFe, Scaled Agile Framework. So they've got different flavors of SAFe, like Essential SAFe, Large, Solution SAFe, and so on. Full SAFe looks like this, and they've got a couple of roles which are referred to as the solution or the system architect / engineer. So the top one there, the solution architect engineer. So if we look at that, they've got a bunch of information about this role. Like all the roles that they have, they do actually define them. There is some detail there about what they do. So SAFe refers to the solution architect or engineer as being responsible for defining and communicating a shared technical and architectural vision across the solution train. And that's a good definition. I like that. That's a good definition for an architect. And if we look at the screenshots here from some of their documentation online, they start to go into some of the detail about what it is you actually do. And if you go to the page that's referenced there on the bottom right, it's got a lot more information there. So they're quite good at talking about the context for an architect and some of the things that you do, broadly speaking. So looking at that and trying to think about, what people need to do in terms of their day-to-day tasks, think about tasks that you do, specific tasks, the artifacts that you might deal with and that sort of thing. Looking at the work that we do here and some of the companies that we work with and some of the architecture practices that we work with, just general community stuff. It felt like a bit of a gap. So I've had a crack at developing a model for that. So there's two parts to this. So the first part is the diagram that you see there on the top right, and then it's supported by a matrix or a spreadsheet down the bottom left. So the diagram is basically just a visual map of concepts and work and things that are related, and the matrix provides detail on that. So what each thing is, and then we call that sort of a racy about responsible, consultant and so forth. So and that's all for you as the solution architect. So for a particular given item, should you be responsible? Do you need to be informed? And then some comments about that. Now you might see there that you might looks like you're responsible or accountable or for in more than one on a particular row. We'll get to that in a minute. But anyway, this is just based on my personal experience. So I've got this concept called Parsino. It's basically just a variation on racy. So that we talk about being where you participate, responsible, consulted or informed, or perhaps no involvement. So the work and artifacts roughly fall into 3 categories, which we cover in the resources. So there's stuff that you're responsible for, stuff that you need to know about, and then there's sort of everything else in the middle, stuff that requires your involvement, usually in a consultative capacity, or perhaps more of I'm not going to say this right, to participate, participatory. So consult versus participate. So consult usually means that you've probably got a degree of authority about what's going on. People are coming to you to consult with you because they need to get your opinion. Now, for some things, particularly where they're sort of on the side of your project, you might just be giving guidance to them, which they may or may not ignore. Hopefully, they'll take your guidance on board. But there can be stuff, particularly within the project, where you do at least have some implied level of authority. You might not have veto power of it, but hopefully people should know. If you're the architect, that's a leadership position within a project. If you're not going to like something or you don't think it's the right way to go, obviously it's going to be harder for people to get that across the line. Participate similar to consult in that you've got a degree of authority perhaps, but the practical application of that is or should be more through collaboration and driving consensus. So a good way to think about these is if you perhaps think of the stereotypical waterfall project, and perhaps coupled with sort of a command and control sort of culture and way of running the project versus an agile or a scrum way of working the project, which is much more collaborative, which should be safe. People there should be there to provide support for each other. If you're working in an agile manner, you would kind of expect or hope that people would participate more, they'd have those conversations, they'd work as a team to get stuff done. And a command and control style doesn't really seem to sort of fit with that, right? So what I often find with doing solution architecture, for me, is it's very much about collaboration and trying to get people on board and driving consensus. A really key learning, I think, is that if you go into something as an architect and you come up with the architecture, you've got to do that through consensus, because the moment you leave, people will just start pulling your architecture out. Architecture done right should be foundational. It should be long lasting, as appropriately as it needs to be, and that's not going to happen if you don't find consensus. If you find consensus, you can get people on board. They buy into the idea. They put their ideas into it as well. It's sort of, you grow it together. It's got a much stronger chance of lasting for an appropriate amount of time because people are bought into the idea. So that's where the idea of participate comes in. There is a little bit of a degree of responsibility in that. So often when I'm participating in things, some of those tasks I might think I'm responsible for, but I'm sort of participating because it's the right thing to do. I do need to get people on board. It's sort of a little bit like that servant leadership kind of role or approach to things. So going back to the SDLC, so if you remember just back to that diagram that I had on the top right with all the that visual map of all the things, we've got the gold elements there that represent the SDLC. Now, it's not an SDLC, perhaps in the language that most people would use. I've used concepts that sort of encapsulate the different groups of things that you do as an architect, or that might be related to what you do as an architect. So looking at the SDLC stream sort of in there in the blue, obviously there's a bit of upfront planning and analysis. You then get into doing the architecture proper, design and build. Related to those, you've got delivery methods and engineering. You then move through to testing, release and deployment, BAU operations, And then you might move through to decommissioning, or you might have system change. And if you're doing system change, that sort of loops around back to the beginning, and you might sort of, depending on how big the change is, you might do a little bit of all of those things, or you might do a lot. So that's sort of the SDLC part. A bit that people often tend to miss is transitioning to operations. So if it's your first project, or sometimes you see the rookie architect, or they'll come along and they'll be focused on getting the solution designed and built, and then you switch it on as though that's the end, but really it's just the beginning. You need to hand over to support teams in a lot of cases, if you're not working in the product sense. So that journey for transitioning something into support, into operations, that can start whenever, and ideally it should start relatively early on, depending on what you're doing. So that's just why that's showing as a bit of a line there crossing a number of the points in the SDLC. Because what I find is, from a practical sense, most of the work for developing, and transitioning towards operations, that will happen towards the end, but you really do need to start at least thinking about it and having conversations with people much earlier on. And then wrapping around all that, we've also got the architecture practice, current and planned constraints, and project and the product construct that you're actually working within. So that's the map there. I'll just give you a couple of seconds just to have a bit of a browse. Like I mentioned, these resources are online. As soon as I've finished the presentation, I've got a blog post which has got all of these online right now. I'll put that in the chat and you'll be able to get straight at them. So just moving on now. So just the legend there, looking at the colors, those gold ones that we had, those are major concepts, or parts of the life cycle. Elements that are green tend to come through at the organizational level. So if I just go back for a sec, so if we look at the organization's SDLC, or their governance approach, maybe they've got a high-level design template. That's stuff that will come through at an organizational level usually. The stuff that's blue is usually determined within the project. So again, if I go back, you might be doing options analysis, detailed design, your test plan, the retrospectives that you might have if you're doing Scrum. That's all stuff that happens within the project level. And there's a few things that are red that are kind of neither sort of here nor there. It's a bit more variable. In terms of the elements, the round blobs are, that's usually work to be done, or a process or a phase. The square boxes with a little document icon in them. So those are specific artifacts that you might be working on or have to provide input to or whatever. And there's a couple of things, for want of a better word, which aren't, it's not necessarily a document, it's not necessarily a bit of work, it's a bit of a thing. So this is a first draft. And just a quick glance at the spreadsheet. So what you've got there is, the type of thing, the name of it, a description of, just a very short description of what that is. And then we've got the Parsino, whether you should be participate in getting that developed, responsible, consulted, or informed. And then there's some notes about how to apply that. Now, why? Now you might think, okay, if you're the architect and the task is, to do with the domain architecture, shouldn't you just be responsible, or shouldn't you just be consulted? Why more than one thing? And that goes back to the drivers we had before around, why there's a bit of confusion around, what the architect role is and what your responsibilities are. Stuff like the organizational size and the organizational maturity. So if you're in a large, really mature organization, then you might have a very narrow focus on some of your tasks. They might be quite well defined. That might drive in a particular way what you need to do. So that might mean that that might mean for a given task that you might merely be consulted or informed. If you're perhaps in a smaller organization that's less mature, you might have to wear more hats. You might find that there are gaps in their processes or in their thinking. And you might find that that's around topics which actually they're quite important to getting your project completed, and therefore you're forced to take on a greater level of responsibility to perhaps fill that gap in some cases. So it is a bit of a sliding scale. Depending on the situation that you're in, you might merely just be informed or consulted, you might have to participate, or you might be responsible. And so the comments that I've got off onto the right, which you can't see in the screenshot, they talk to that. So just a bit of detail about that. So in the last 20 minutes, I've got some examples. So we've got 5 examples that we can dive into that sort of help explain, give you a bit more of a feel for how this works and and what you need to do as an architect. So the first one is looking at the project construct, specifically, what methodology you're going to use. Now I find this tends to play out in one of 2 ways. The first is, the project or the organization that you're in, they might have very strong views on how a project's going to be run. So one of the organizations I'm working with at the moment, they're very much bit of a waterfall shop. Their EPO or their project management office, that's quite strong within the organization. And so they have all these stage gates that they work through. At the, I guess, sort of more at the coalface, there are people there using Agile in some way, shape, or form, but it's not widely adopted throughout the organization. So for some of the ways that they run their projects, they've got quite strong views on that, and you just kind of need to fit in. The second way that this can play out is where there's a bit of a void there, and as a leader within the project, which the architect absolutely is, there's scope there for you to come in and help shape what the delivery should look like. So for example, I was on another project where they had started doing waterfall delivery. They'd been doing that for a year. They had documentation that they would take up to their board, the steering committee. I think it was about that thick. And the project manager spent most of his time in this cycle of just preparing the papers for the next board meeting. But ridiculous. And eventually people started gravitating towards the Agile train. And so as the architect, one of the things I had to do there was really help try and guide that conversation. And I said to the project director at the time, because I went through a couple, I said, look, if you're going to go Agile, you need to get some Agile coaches in, otherwise I'm going to leave. And I wasn't totally serious, but he thought I was perhaps a little bit serious, and so they did get Agile coaches in, and that actually became quite a successful project. The Agile coaches that we got in were good. They did a good level of fundamental training, and they were there to sort of coach people through the process. So that worked well. But as an architect, being in that leadership position, making sure that people do some of that stuff, there is definitely scope there for you to do that, and arguably your responsibility. So just to recap on that, if the organization has a strong way of doing things, the project manager might have a very strong way of running the project. Cool. Well, okay, you can just sort of fit in. You can make sure that they're not going to get themselves into trouble. That parental guidance. But if there is a gap, it's there for you to step in. Current and planned constraints and architecture. So current and planned constraints is, this is quite a key thing. So let's talk about this for a little bit. So the difference between, I don't know if you've heard the term solutioning versus solution architecture. So for me, solutioning is where you walk in and you sort of imagine you have a green field and you start picking technologies and you just, taking whatever you want and you go with it. You've come up with your solution. Solution architecture is very different, and that's much more disciplined. So where you would start is one of the things that you start with is you look at your constraints. So if you're going into an organization to put in a new system, typically that organization will have already made a bunch of decisions around what technologies they have. They'll have some key systems and what those are written in. Very crucially important, they'll have a certain set of skills. The people who work there will have a certain set of skills. So if you're going into say a .NET shop or a Java shop and you have lots of developers who are skilled in one of those platforms, then bringing in the other platform isn't necessarily a sensible move from the organization's perspective, because they just don't have people with those skills. Well, who's going to support this? So those are constraints that you need to take into account. What's the technology stack that they have? What are the skills that people have? What technologies are they trained in? So there's all sorts of constraints like that help define, sort of the remaining space that you need to put your solution in, and what the right shape is that you need to fit in with. So you've got those current constraints. Planned constraints is more stuff like, perhaps they've got a technology roadmap that they're working on, a digital strategy, something like that within the organization. They'll also have perhaps other projects in flight. So you might have a major upgrade project, or you might have, say, a new CRM coming in. Sometimes when you go in to do a project, there'll be other projects in flight at the same time. Some of those can be quite large, and some of those can be dependencies for your project. Sometimes those projects will be depending on your project to deliver something which they are going to consume, or the other way around, they'll be delivering something which you need. For an example, the project I'm working on at the moment, we're delivering some digital services for this organization's suppliers. So, as a supplier, you can win work with this particular government organization, and then when you're working with them, a lot of the communication is not through a system. It's sort of manual email, phone calls, and stuff. So what they're looking at doing is putting in some digital services so that suppliers can do sort of more self-service. They can register and they can submit RFP responses and so forth. And one of the critical backbones or dependencies for that is identity management, right? So you might have heard of IAM, Identity and Access Management. You might have heard of CIAM, so it's CIAM, so it's Customer Identity and Access Management. So right now, if you had an organization and you were going to, throw the doors open and do some digital services for the first time, to the outside world, might be suppliers or just the general public, you're going to need some sort of platform for managing customer identity. And there are a bunch of solutions out there that will do that for you. That's what they've been designed to do. They've got the right tools straight out of the box. It's a sensible move if you want something that's sort of enterprise grade. And so for us, that was, for this particular project, that's a critical dependency, and that was one of these constraints. So when we're looking at the authentication that we're going to do and how we're going to manage our users, there's stuff that's going on within the core product we're delivering, but then there's sort of these wider constraints and thoughts around how the organization wants to manage suppliers. Because if you imagine it from the supplier's point of view, you log into the organization, into the portal, you get into the system that we're delivering, which gives you sort of your main stuff. Over time, more and more of the systems that the organization currently has are going to be transitioned online, right? They will add digital services as well that will be exposed to the supplier. From a supplier's point of view, you just want to log in once and access all the services. You don't want a different login into all the different systems. And so therefore, there's the organizational constraint or direction that, hey, everyone's got to use the CIAM tool so that people can authenticate with CIAM, and then they get access to all the digital services no matter which service they're on or which system they're on. So stuff like that is quite important. So domain architecture is quite a critical, important subject there. So if you think of the different IT domains, so stuff like just really high level topics like data, applications, security, infrastructure. As a role, as an architect, you can take on a domain architect role, which I think is what TOGAF refer to as a segment architect. So you could be an infrastructure architect, you could be a data architect. So in that sense, you're worried about, if you're a security architect, you're worried about security for the entire organization, not just for the scope, within the scope of one project. And of course, if you're a solution architect, your scope is for that one project. So if you're the domain architect and you care about security for the organization, you're going to be paying a lot of attention to the key systems that you're putting out and projects that come along that are using those for the first time. So you, as a solution architect, you do work closely with domain architects. And then the second thing we've got there is that little red blob called breaking new ground. So what I often find in my role doing solution architecture is you'll do something like these digital services to the suppliers that I was just talking about, and you'll get to the point where you say, okay, well, what are you guys thinking about in terms of authentication for suppliers? Are we just going to do it within the system, or what we're thinking? And you get into this big discussion. You talk to the domain architects, and you realize that, well, hey, we really should have an enterprise CIAM tool to manage that. And so, from your perspective, you've got your project, which is just trying to deliver these digital services, and then all of a sudden you've discovered that actually there's this huge gap organizationally, and your project depends on that. You talk to the project manager, of course, they're like, well, implementing a CIAM solution, that's not part of our scope, and you have all those sorts of discussions. So breaking new ground when you're a solution architect, it's lifting those rocks and finding those gaps, those things that are going to be showstoppers for the project, those dependencies, that sort of thing, and working through those. So So your level of involvement, so are you responsible, consulted, informed? How does that work? So it's very much situation dependent. So sometimes the domain architect will just inform you about what's happening, and you just sort of go along with that. Other times you'll have a lot more input. What I tend to find is that domain architects usually want to engage with you really, really closely because you have something that they don't. If you're on a project, you will have people there, like a delivery team, and you'll have a budget, so you can actually get stuff done. As a domain architect, you're basically just drawing boxes, right? It's not like domain architects sit there with a huge budget could just implement any system that they want. So often you will team up with a domain architect. Usually they're pretty good. They will want to work with you. There'll be good collaboration there. They'll usually respect your viewpoint because you're at the coalface. You've been brought in as an expert to help deliver the project. Usually they want to listen to you and get your ideas about, well, at the coalface, how is this actually going to work? And you get down to a level of detail that they haven't really thought about. So in that respect, you're in more of a participatory mode rather than just being consulted or informed. And of course, if you're in a small organization, perhaps not a very mature one, they don't have, say, a dedicated security architect, and you come along with that situation and you say, well, hey, you've got more than one system here that you're going to be putting out to the outside world. Something like a SIAM solution would be a better idea. Then you're basically taking on responsibility. You've found a gap which somehow your project needs to either implement or get around and avoid somehow, and you're going to be instrumental in navigating, what the approach is there and navigating a path through that. So that's current and planned constraints in architecture, breaking new ground in domain architecture. Non-functional requirements. So Neal was just talking about non-functional requirements before. So what's the story there? So this is, on the surface, this is quite clear cut. As the architect, you are absolutely responsible for making sure that the non-functional requirements are properly defined and understood, and navigating all of that. The bit that's sort of a bit more variable in what looks straightforward on the outset is the journey through which you get to that. So just as a quick aside, so let's look at how you would get your NFRs developed and approved. And for the purpose of this conversation, we've got three main actors. We've got yourself, the architect, and then we've got the business and IT delivery. So if you think about it from a governance perspective, I like to think of governance in a really simplistic model as being about stewards and custodians. So the business and the governance model are stewards. So they have service quality expectations. And if you're an IT, you're the custodians. So you have delivery responsibilities. To give you an example of just trying to understand that a bit more, think about data quality. So the people who define what data quality should be, those are the stewards. That's the business's job. It's their data. Well, you guys want this data. What are you going to do with it? Do you want name and address data? Why do you need that? Do you want address data because you're actually going to bulk mail stuff out? In which case you need the quality of the address data to match what the postal service needs, right? There's a very specific data quality there. If you just want names and addresses to put into, say a petition, maybe it doesn't really matter if they spelt the street wrong or got the suburb wrong. And the only people who can define that are the stewards. It's the business. It's their job to define what quality means, and it's the job of the custodians to implement that, right? So you've got the business, IT, and the architect. So you've got three ways by which the NFRs might get approved and delivered. So the first model, which is the preferable one, is to discuss and agree. So you'll get together with the business and the IT custodians who are responsible for the systems and who sort of have to meet the NFRs. You'll discuss and agree what the project needs. As the architect, you'll take that away. You'll define that. You'll facilitate that process of getting the NFRs actually defined. They'll get approved, and then people will go and deliver them. Model B is more business-led. So that's where, as the architect, you'll have a sit down with the business, and you'll have a discussion. Well, what is it that you really want? Now, you might think that sitting down with the business and talking about NFRs won't go well because you're talking different languages, and that's certainly true. You have to obviously use the right terms. It could just be as simple as finding out, well, what's the big ticket items for you? Is security a really hot topic for you, or is availability? Regardless of how you manage that conversation, you'll come up with a bunch of NFRs that the business are happy with. They'll approve them. You'll then swing around to the custodian side, to IT, and we'll say, okay, well, look, if they can have whatever they want, this is what the business wants in terms of NFRs, and you'll do a bit of a gap analysis and see what's actually achievable. And then you'll go through this process of saying, well, okay, well, we can meet all these NFRs, that's no problem. These ones we can't. Look, we just can't meet that level of performance. It's a little about the 1 versus 2 engines, the F15 and the X16, right? We can't give you 2 engines, but we can give you 1. And you can have this conversation about, okay, does the business just accept that we're not going to meet that NFR for the project, or we might not meet it now, maybe we can meet it later. The thing I like about that approach is if you get gaps out in the open, you can put those somewhere, and then you can start dealing to them, because some of them, if you're talking about a big infrastructure investment, that's sort of outside the realms of what the project can do. And by having those there, people can see them. So the more projects that come along and have the same requirements, hey, we really need better availability. Hopefully you get to the point where the business actually does something about, the organization actually does something about them. But what usually tends to happen, which is not preferable, or certainly from the business perspective, is Model C. It's delivery led. So IT will say, okay, well, these are the systems that we've got. These are the different levels of NFRs that we can provide. Just pick what you want. And then the business is sort of limited to working just within the scope of what they've got. So let's say you're doing something kind of groundbreaking as a business. So let's say you're putting digital services out there for the very first time. It's quite possible that you're going to be pushing systems beyond what they were set up to do, the NFRs that IT are comfortable with. You're going to be breaking new ground. And so those can be quite hard conversations. And in that sort of a world, Model C doesn't work very well. But where Model C does work quite well is if you don't have very technically orientated users, business stakeholders. If you've got some NFRs laid out already, a lot of organizations have like a gold, silver, bronze. They'll just have very simple tiers of NFRs. And there might be costs associated with those. It's a lot more simplistic. It's more easy to explain to your business, well, you guys need like the top level of service, or are you happy with just the bottom level? And you can use that as a starting point. So in terms of the roles and responsibilities for the architect, you're responsible for just getting the NFRs defined, but how you do that really varies. Fundamentally, you're responsible for navigating both parties through that. You're responsible for navigating the business through the NFR discussion, making sure they understand what they need, working with the IT in terms of what's achievable, trying to bring those two sides together. Absolutely your responsibility. Design. So I've just got a couple minutes left. Mike, feel free to cut me off if you like. I've really just got these examples now. So just to quickly talk on this one, system interface specifications and API specifications, you might think that that's quite detailed and not something that an architect should do. Again, obviously it's situation dependent. Sunny day scenario, I guess, is as an architect, you don't need to be involved. What I do find from a practical perspective though is that it's one of those things that you want to pass off to the tech leads and the developers as soon as possible. You don't want to be there as an architect, maintaining API specifications for the rest of your life, but it is a good thing for you to do it like a first draft of those. And one of those reasons for that is the box we see down the red. The danger with with developers doing the API specifications, given that API specifications define how systems talk to each other, and often those systems will not be within your control. They might be outside the organization. When you're developing those, it's quite important to have that wider view. And this is not disrespect to developers, but frequently with developers, because they are focused on their job and what they need to do, that's usually focused on the system that they are working on. They don't necessarily have the wider view. And what we've found in a practical sense is that you can definitely get developers to have a first crack at the API specs, but they don't necessarily have that wider view, and that can lead to problems later on. So having an architect take a bit of a lead role in getting the the API specification stood up, at least like a first draft, that's actually a really good thing to do, and then sort of transition that more to the developers later on. How are we doing for time, Mike? Do you want to? you want to get into the QA?
Yeah. Man, dude, this is really awesome. So yeah, can we do that? Are you all right? And then come back in, and I've already got a lot of stuff I got to ask you anyway. But I first got to go ahead and allow them to do an announcement. So if you're good, I'm going to go ahead and remove. This sounds really weird. I got to remove you. Dude, seriously, I'll bring you back in a minute. I promise. Okay. So anyway, I got an announcement here for everybody. I just want to say we got the super cool Game Development Global Summit, and I think what they're going to do is they have a video, short presentation video. So take it away if they have it.
Scientists say that even die-hard software architects at least once in their life wanted to start a game-related. This summer, Geekle game dev community gathers amazing artists and developers from the top studios to share their knowledge and skill with us. And today, you can buy it at 50% discount. To get the deal, use our special promo code SUMMER50 at checkout.
Okay, everybody. I just want to throw the pitch out there real quick. I just want to let you know. I always say this. Take advantage. I'm serious of these summits that Geekle does, because I heard somebody tell me it's a fast track way for you, if this is your thing, game development, because I would like to know that. You know, how to really get into it. And you have all the experienced people in the world. And the reason I say all the experienced people in the world, I'm going to start bringing people in. Like, hey, Adrian, Mr. Experience. And then I've got Steliyana. Hey, girl, what's up? And then I've got Arnab, and I got Neal. How is everybody doing today? You guys okay?
Good.
Doing great.
Yay, let's all get fired
I've got speak envy.
Okay. Everybody's doing great. Everybody's happy. Some of you are like early in the morning, like Adrian. Steliyana, what time is it where you are? What's the time zone where you are?
I'm currently in Eastern Europe, so it's 8:45, in fact, here. And people are having drinks outside waiting for me, so...
We better speed it up. Where are you, Neal? Where are you? Yeah, got it. Where are you, Neal? Where are you located?
I'm in Atlanta in the Eastern time zone, so it's almost 2 p.m. here.
Yeah, I'm sort of California. I'm 10:42. Arnab, where are you located? Where are you?
I'm located in India, so now it's 11:15 p.m.
And probably, so the two of you are probably like, hurry up, Mike, let's get this over with, because I'm getting tired. Okay, so I've got some super generic. Hey, by the way, Adrian, I love the F-15 part. I heard that. Yeah, that's so cool. I heard that because that came over from Neal. So yeah, let's start there, everybody. I mean, you are the most super amazing, craziest, best architects in the world. You like that? You are. Do we think of backups, in other words, in our contingency? I mean, do you have examples of that? Go ahead. Somebody just go. I mean, like the F-15 with the extra engine and the 16, it's going to crash. So how do you prepare that? Go ahead.
So, I'll answer for all of us. It depends. but you knew that was going to be the answer from an architect, right? But I mean, it really does. I mean, so the question I would go back to you as an architect to say, well, how valuable are backups? To what value does this add to the business to have backups? If we're in a business that has a lot of data that we don't want to lose, then yes, backup should be absolutely critical to my architecture. If I'm designing a sandwich ordering app for all the people in the office, I don't care if I find out last week that somebody ordered an egg salad sandwich. So it depends. This is one of the tricky things about architecture. And one of the things that I tell you architects is try to get away from absolutes like always or never, or even things like better or worse, because, it's just a different set of trade-offs. Once you get to the architecture space, there's almost nothing purely bad, but there's almost nothing purely good either. So, it's always balancing the trade-offs. So I think that's actually the better skill for an architect, is learn how to objectively balance trade-offs.
And I got another word. Is promise a good word? I promise you this. Is that a good word?
Well, I mean, it depends on whether you're going to make that promise come true or not. But I mean, that's not an absolute. So I typically say never say absolutes in architecture unless you're talking about absolutes.
The other thing that you can do there with backups is if you're in an organization that already has operational support, they're already running systems, they've already got a backup regime in place, just leverage what they're already using, if that's appropriate.
How do you know that? Neal, how do you know that? I mean, I have my answer. I'm an architect guy. I am completely, okay, a little bit of the answer here. I don't even work with IT over there. So how do I know that? How do I know what kind of backup? Because this is a really good point, what you said. Anybody, I mean, how do I know what their infrastructure is? I mean,
have you tried asking? It's mind-blowing, right? So it depends how the organization runs their IT support and how they do that. If they're good and if they're not running products, if they're doing projects, then they'll have some sort of operational teams. They'll have people who manage that. There'll be like an organizational structure. So just reach out to someone and say, hey, we've got this system coming and you guys are going to be supporting. Tell us about how you guys do backup. Tell us about how you do stuff. Start a conversation.
Anybody else have something you want to add to that, of an example of having to do that, maybe interface with the IT group or something like that?
Speak with them. That's the best way to handle things. Just have a chat with them and ask them. There is no other option. Means if you are not an IT person and the IT is handled by a separate team, I'm not speaking about you not being an IT person per se. You might be an IT person of another department. I know of organizations where there is an IT department and then there are techies working in different departments. Okay, so the only way is having a conversation.
Steliyana, you want to add to that? Go ahead.
Yeah, I think communication is the key part in anything, not only in architecture. I mean, we just need to communicate. I mean, people don't have a crystal ball to understand what we think. We need to communicate, and the clearer we communicate what we want, the clearer the other person or the other team is gonna, understand. And yeah, we need to communicate, whatever it is, Siemens backup or not, whatever. For creating a backup, yeah. First, this is something we all need. We all remember, back in the days when computers were crashing, everything was, now we have Git and everything. We feel better. For the data, it still depends on the business itself. Because if you're making an accountant system, yeah, you have laws that restrict you for some stuff. And yeah, you need one type of backup and then another type and another type. I've heard some companies making, even tapes of backup just because it is so critical, the things that they have. So yeah, we need that no matter what. We need it.
Yeah, exactly. So you mentioned communication. We live in
it just somehow happens sometimes, and we need to make sure that we all agree that shit's happening, and we need to communicate to the whole company that we need to be ready for shit.
Yeah, okay, we got that. Okay, but we live in a COVID world. Neal, have you wrote any books on impact of a COVID world and how we communicate? Right? I mean, I actually what I do, okay, we have all moved to a totally teleworking environment, okay? And it's completely different now. We're talking the dynamics are absolutely different. I don't have to look at somebody face to face anymore and sit in a meeting or in a design and point to everybody, here's my design here, and I'm presenting my architecture to you, because we all live in this, well, I do, in this post-COVID world, and it's just different dynamics on how you communicate. So you have any examples of that?
Well, I would not write a book about it, because exactly about the time you get the book done, the pandemic would be over and you'd never sell any copies of it. And you'd have wasted 2 years.
I was trying to give you a pitch.
But, I mean, to your point, communication has to change when everything moves to a remote world. And a lot of face-to-face communication is harmed when people don't want to turn their cameras on for whatever reasons, or, there's chaos in the background because of kids or pets or something like that. But back to what Steliyana was saying around communication, a good piece of advice I recently heard from Pat Qua, who's he's got a great newsletter for tech leads, Pat QUA, Pat Qua. He's a well-known technologist, and his advice was, a lot of people think you should don't repeat yourself, which is a kind of mantra for developers. But as an architect and a manager, you should repeat yourself early and often. Repeat yourself as often as you need to so that people understand what you're talking about. Because as an architect, you're very often the nexus of a lot of important decisions and discussions, and you need to make sure that all the people involved in that know what you're talking about. So get used to repeating yourself a lot. And that's even more crucial in an online world because not everybody's around to overhear things or in the appropriate meetings. So that's one of the things I think one of the habits you have to get better at is what feels like you're repeating yourself too much is probably just about the appropriate amount in the current day and age.
Wow, I wish I could get that in my relationships because everybody says I repeat myself too much and I sit there and ask the same question too much. But I agree with that because it seems like every time I ask that question or every time I repeat myself, somebody's getting a little bit more information and it's becoming more clear to them exactly what I'm trying to implement that. And that kind of goes into the next thing. Everybody, this is just general time. We're just having a good old, round table here. Can you give me an example, all of you, where exactly that you felt like you just over and over that the people you're trying to implement solution, they just didn't get it at what you were trying to implement? And how did you go about that? How did you go about finally getting them to understand it, what you were trying to implement?
Well, if I can start with that, well, when you talk to someone and you share idea, you say something right in some way, and you see the other person just his confusion, he cannot get you somehow. Then you try another way, and usually what I do, I try to find the language of that person. Try to find example, some metaphors, something, just try to make that person imagine the things that I'm imagining in my head because of my background and my knowledge, for example. I want him to imagine it because when he can visualize that, then things get more easier. I mean, we can always go with pictures and, show something, but it's always better to to stimulate the imagination in some way, with pictures, with some metaphors, or whatever you can think of. And as Neal said, repeat in 10 different ways if you need. Write an email and then explain, share a video, and do whatever you need to do to make the other person just understand, feel, and imagine, see what you're seeing. Then it's better, it's easier than to to convince, to influence, or whatever.
Yeah, I'd echo that 100%. The other thing I find useful is finding common ground. So if you can find some sort of a common ground or sort of a starting point, find something in common, you can usually branch off that, particularly if the subject's sort of contentious.
That's a good point. Anybody else?
Okay, fine. I touched base upon this. As software architects, we tend to speak only with coders and techies. It is my belief that we should rather tend to speak with business people and project management teams. We must understand their vocabulary, and that helps a lot. They have completely different vocabulary than the kind of things that we speak. I do a lot of things, that's a separate issue. I'm speaking about software architects per se, which I personally see. And this seems to be a huge challenge in putting forth your views to people who do not understand the context in which what you are speaking.
That's so true because Neal, I think I heard you. I see you nodding, and I think I heard you mention you had the F-16, which you got me going, man. I mean, if you were trying to present something, I'm like, he's got me, and I think that what is it? Sorry, Steliyana. I'm sorry. That's what you kind of mentioned. You said find something in common with the stakeholder, the people, the influencers that I'm trying to bring this super cool idea with. Because Neal, you got me when I saw FCD. I'm like, that's my old Air Force days. And that's sometimes you having to do maybe some research, right, on what the company is, what it's all about, what the culture is, and anything like that. I got, man, we could talk all day, seriously. But here's some real generic questions that came out. Okay, I'm just going to bring it up, and then somebody just go away. Not go away, but go ahead and fire up here. What is the best place to learn practically to design an infrastructure side project startup corporation? Where's the best place to go? You got all this wonderful experience. Where would I start? Where's the best place to learn all of this?
Well,
The best place.
Oh, sorry.
You go. I was talking to myself there for a second.
I was thinking, if there was a best place to learn to become, whatever. If someone knew of that place, please tell me as well, so we can all go. Because most probably it is, you just go, you start a project somewhere, and you learn. As you go there, you learn. I don't think there is, a specific place or a planet in this universe.
I know of 2 planets. Well, so the first is
maybe it's Dagobah. I don't know. People go there to learn.
So a good place to practically learn the infrastructure side is to have been an infrastructure engineer, right?
Yeah.
And I don't think it's any secret that a lot of software architects were former developers. So if you're coming as an architect to do infrastructure for something and you've never done infrastructure before, then whoever's put you on that engagement's probably not done you a favor. The second thing, if you are in that situation, is you can learn from the engineers you're working with. What I find is that being an architect doesn't mean that you need to know everything. It just means that you have to help facilitate and guide people. So if I'm working on, say, an infrastructure project, which incidentally I know nothing about, if I've got a good infrastructure engineer with me, which hopefully I do, I'll leverage them. I'll get them to, I'll leverage them as much as possible, and I'll help make sure that they can sort of, lead the work. It's not my job as the architect to sort of be there making all the decisions and trying to be the smartest people in the room. My job is to help get the most out of people who do actually have the information.
Totally agree. I mean, no one expects from you to know anything. Whatever your position is, I mean, no one expects for you to know everything. There is no such a person. And as I usually say, if someone tells me that, okay, so this is, okay, I cannot believe that. So that's why we team up. And someone comes who has experience, okay, you can help, you can learn from that person, and then the whole team goes. I mean, yeah, that's it.
Yeah, and so this is really good.
I have a point out here.
Go ahead.
Probably depends on the context as well. Who is asking this question? Is the person a student? Is a person a professional who wants to start his own startup? Probably if he's a architect and he wants to start a startup, he has to know infrastructure probably as well, because he cannot get a new person or a senior infrastructure person to be part of his team. It's probably a 2-person startup, one hustler and one a coder. So he needs to know the stuff as well, right? So
yeah, and so
it depends on the question, depends on the context as well.
Yeah, Neal, you gonna say something?
Well, I was just going to say what this illustrates is something that my co-author Mark Richards often says is software architecture is the stuff you can't Google. So when you're a developer, you get used to Googling questions like this where, hey, I need a step-by-step guide to set up something, but that doesn't exist for software architecture because software architecture is not some turnkey thing. It's the stuff that's good and the stuff that's bad and the legacy stuff that we like and the legacy stuff we don't like and the things that were forced on us and the things that are good. And every one of those is a magical snowflake. And so you can't Google because who on earth has the same combination of things that you have? And so that's one of the reasons why software architects are rarer than the role who can just Google the answers to problems, because it is always about context. It's about measuring trade-offs. The problem with software architecture, unfortunately, is there are very few silver bullets laying around. And so, it's hard to find these magic solutions to problems So you just have to work through and come up with the best, the least worst combination of trade-offs you can come up with and move forward.
So would you say that, okay, would you say that you're all inventors then? I mean, you're all creating this masterpiece painting. I'm trying to make you all look really good here, but it's true, isn't it? That's right. You can't Google that.
Engineers. I think it's engineering. I think that's the part of architecture that's really appealing, is that, part of engineering is being artistic within very specific constraints. Mm-hmm. So the constraints are, the lines and boxes and the capabilities. And within that, you can be quite creative. And so I think that's a lot of the appeal, that combined with the, instant gratification takes too long nature of software developers in general. I think that's what gets architects instead of software architects instead of building architects, or some field that has a slower feedback loop. We like fast feedback. So
I completely agree with that. And just to riff on that for a moment, as an architect and as a, to use the term inventor, critical thinking is such a big thing. You are a thought leader, and when you actually get down to it and trying to do thought leadership, that's actually quite hard. You're thrown in the deep end. No one's there to help you. Everyone looks to you to provide the thought leadership. And if we take the DR example, if you want to tip that on its head and come at it from an outside angle, you might say, well, rather than trying to do backups, why don't we just make this thing super available? Why don't we have multiple nodes? And so no matter which nodes go down, we're always going to have something running. We don't need backups. So that's the kind of the inventor mindset, going right back to base principles, asking fundamental questions, not assuming anything.
And that goes back to a point I made. Michael, as my business user, comes to me and says, we need backups. It's like, okay, you're bringing me a solution, not a problem. What is the problem?
Yeah.
You need really high availability.
Totally agree.
Okay, there are a handful of ways we can solve that problem from an engineering standpoint.
What's the problem you're trying to solve? Yeah.
Right. The requirement, in other words, and not how to. Yeah, that's true. That gets us in a trap too. So the example of what you said on the whole architecture, have you ever had an example of, you've had, I'm trying to get examples out of you guys because your experience really helps me. For example, like having that manager, that everything you suggested, they just constrain you, because I heard that word. I heard, like, I'm in this tunnel. I am the architect. You're supposed to listen to me, but you're not. And then that takes away the creativity, right? Because then you find that they're the ones that are kind of giving you those rules and you have to follow that path. So, I mean, I have examples, but I'm just wondering for you guys out there where, you can't do that. No, you can't do this. But yeah, you can do that one thing. And then that takes away the creativity. So do you have examples of that?
Well, you have to understand that there are different kinds of architects. I am cutting off someone again and again. I seem to make a mistake. But anyway, there are different kinds of architects, right? There are solution architects, there are cloud architects, there are .NET architects. So there is one person at the top who's going to do the architecture design, preferably. There are some project managers who also do this and then mess up the whole thing.
Oh, yeah, dangerous. Yeah, you're right.
It's a separate issue. I'm speaking in best case scenarios. You have a solution architect who does the base thing, and then there are different architects who come in and get stuff done in between. So it depends on what is your role, what is your competence, right? So there are these points that I can think of. But yes, as I said, it's not always software architects who get to decide things, which is unfortunate. There are some. The worst part is in India, because we have so many people who are among so many techies per se. I see even project managers who have some idea about tech. There are some marketing guys who also have gone to IITs and have some knowledge of tech. So people tend to decide things. But
there's another example I can. Oh, sorry, Arnab.
No issues. Please go ahead.
So there's another example I can give you, Richard, if you, Michael, if you want one. So commercial boundaries, it can be a problem. So there's a place where we're doing some stuff. There's a vendor in there which is quite entrenched, and they look after the middleware. And so some of the architectural decisions that get made have their input coming from more of a commercial bent where they're just trying to protect their patch. And so it's not so much about sort of, necessarily what's best for the customer or architecture in a pure sense. It's more driven by commercial concerns.
Interesting. Steliyana, I know you were going to add something to that.
There was this, I think Napoleon said that it's easier to ask for ask for apology than ask for approval. So sometimes you just need to do something proactively, and then sorry if people don't like it, or if they like it because they've seen it in action. Oh, great job for you. Sometimes you just need to be. Sometimes, I'm not saying every time, please. But yes,
we're quoting you. Just kidding.
It is, sometimes you just need to do something and show, because I can tell you 10,000 things why option A, for example, is better than option B, but you just, again, cannot imagine that. So let me show you why it is better, for example. And sometimes it is the way.
Yeah, proven technique.
Yeah, that's really interesting. So I kind of guess this next one kind of rolls into it here. So what is the depth of solutions? Only framework level, or architect must also dive deeper in component structure and make decisions in atomic level? So yeah, just what is the depth of the solution? I mean, how far does it go?
This is actually a pet peeve of mine, because every architecture diagram that I see from my clients is drowning in design details, so much so that you can't see the fundamentals of the architecture underneath. So one of the things I really like to do, all the nice drawing tools, whether it's OmniGraph or Visio or Draw.io or Mural, all have the ability to create layers. And most people use those decoratively. I use those semantically. So the bottommost layer is just lines and boxes, and the lines are either solid or dotted, synchronous or asynchronous, and the boxes are cylinders, and that's the topology of the architecture. And then create another layer on top of that that has protocols, REST, AMQP, and all that kind of stuff. And that way, as you get into the more complex, as it gets more and more complex, you can strip away the layers and get back to the fundamentals of the architecture without seeing too many of the design elements. And I think it's actually dangerous for architects to go too far down into this micromanagement of things like class structure, because if you're not ever allowing other people in your project to make decisions of consequence, then how are you growing your next generation of architects and leaders if they can never make decisions on their own? You want to grow decision makers, not constrain decision makers. And so my technique in my Building Evolutionary Architecture book is to build architecture fitness functions that build a safe sandbox around them, and then allow them to make decisions to make sure they haven't broken anything important, but then give them the autonomy to make decisions of consequence.
Anybody else?
Yeah, so architectural significance is something I look for. So you don't want to go down to the low level if you don't need to, but sometimes you need to. So, obviously as an architect, you don't really care about, the color of the button so much, but if clicking the button is going to have massive implications for infrastructure or whatever, then you do kind of care about that. And this is where design patterns can come in. So if you've got like an approach like MVC or something like that, or some sort of pattern that you can use that solves a particular problem, someone else has solved that problem before, if you can get the team using that pattern, then you don't really need to worry about what they're doing, so long as you're confident that they're following the pattern, right? So sometimes it's just sort of setting a direction, giving something that people can follow, and let them follow it. You don't need to be there looking over their shoulder all the time.
Anybody else have any experience, anything they want to share about that?
I remember back in the days, I don't know, quite some time ago, when we were using, in fact, piece of paper and pen, to draw everything. I remember one of the first things I was taught was, whenever you're making a diagram, whatever it is, the database structure, the whole structure, whatever diagram you're writing, it should never be bigger than A4 page. If it is bigger, then it's complicated. People cannot understand it. So looking from that perspective, no matter how big and complex your system is, you can always make it fit in A4. So for me, this is the rule. Then if you need, okay, I'm taking this piece, for example, so let's dig deeper there or something. But somehow, people, our mind is just limited. We understand small things. And I believe that this is how deep we should go. Whatever perspective you're looking at into your application and, infrastructure or whatever you're drawing.
Yeah, and it's funny because I gave a critical design review. It was about 2 years ago, and you guys know me, I'm crazy. So I always throw a joke out there. So the first one of my slides, it was a bunch of boxes and squares, and then the architect is going to his manager, and the manager's like, "What is all this?" And then the architect goes, "It's just boxes and squares." And the point about it is he's looking at it, like you said, from a simplified point of view. But then everybody else is looking at it like, what are you trying to do here? This crazy, big, conglomerate, complex thing. And when I had interns, same thing. They would go, "Whoa, what are we doing here?" I said, just draw a little box, a little square here, and just connect it. And when you take it, right, you guys agree, I hope, that when you do that and when you simplify it and you break it down into smaller pieces, it comes together. And then when the whole thing works, that you just explode. Next thing you're like, I see it all now, because you can see everything flowing. Anybody want to add to that, or am I just weird? Go ahead. You got it.
Yeah.
I'm actually moderating the next block, so I was zoned out, checking out what I'm supposed to be doing and when I'm supposed to be there. So I missed your question entirely, man. I am so sorry. I'm going to be honest.
Man, Adrian, we got to talk later. I'm going to fly over there to Wellington,
Right.
and we are going to go have coffee or whatever. And
Yeah.
no, that's okay. My point is just that I'm kind of segueing, launching off of what Steliyana said, is that sometimes we just got to make it simplified, right? We got to make it smaller so that they understand it. And I was saying, anybody have an example of that? That's all. And
I've got to drop. I've got a call coming up. So
okay, I think. Yeah, thank you so much. Bye, Neal. It's been great having you here and everything. And I think we all got to go. Actually, that's kind of it. Anybody want to say their last words to everybody out there? This is your chance. Go ahead. Inspire everybody out there that's listening. So go.
No pressure.
Just work hard.
No pressure whatsoever. Hey, is that how we're trained as architects? We are, right? I mean, we've got to react fast. So yeah, just go.
Yeah, just work hard, study hard. What else is there to do? The way the pandemic is going, you could die any day.
Uplifting thoughts there.
And
complexing.
So if we can say something
Epsilon, God knows how many else is going to come.
Oh my gosh.
So if you can find something positive after this, I would say, may the force be with you guys.
Yeah.
What are you trying to say? This wasn't impactful. I got a lot of information. I don't know that you got. It was really awesome, Adrian. I'm putting you on the spot.
Sustainable pace is a bit of advice I've got for architects. So when you're on the project and you look at your own career and stuff like that, take a leap out of the agile book. Go for a sustainable pace. It's a marathon, not a sprint. Make sure you set yourself up for the long haul. Be methodical. Don't get yourself into a fluster. Just you got it. Just methodical, sustainable pace.
Awesome, guys. Thank you so much. Thank you for your wonderful comments, input. You're all truly professional to me, but I gotta let you go. Thank you for your presentations. It's been wonderful. Bye everybody.
Bye.
Thanks. See you later.
Do the wave.
Bye.
Okay. All right, and let's see. I got one more here. Oh yeah, I got you. Bye. Okay, guys. I guess we got another announcement, don't we? I'm gonna close and just let everybody know. I just want to say thank you, everybody. This has been wonderful. I've had a really good time. I just learned so much. I hope every single one of you out there has gained something from this. That's all I can say. I mean, for me, I'm listening to every one of these speakers, and I'm sitting there and I'm writing notes, I'm taking pictures, because I'm just learning more and more about what's going on out there. So this is Mike signing off, everybody. And I just want to say, keep learning, because that'll help you in your job and everything. And I just want to say goodbye. Have a great one, and have a good, safe, day, night, wherever you are. Bye.